path, and I'm pleased to have you. Now let's look at the topic, adverb and types. Now, what is the definition of an adverb? And what are the different types of adverbs? How do you identify an adverb in a sentence structure? To learn more about this, I would like you to do something for me. Kindly join the class while I get to explain to you majority of what is required. I will be waiting for you. All right, let me explain in detail, class, about this particular topic, adverbs and the different types of adverbs. Now, what exactly is an adverb? Now, an adverb is a word which modify three things, basically. And what are those three things? A verb, that's the first thing, an adjective, and other adverb in a sentence. When looking at an adverb, your attention should be on an adverb modifying a verb as the first thing, an adjective, and other adverb in a sentence. Three basic things. And there are different types of adverbs, okay? There is an adverb of time, an adverb of place, an adverb of frequency, an adverb of manner, an adverb of concession. There are many of them, and I'm going to explain each of them one after another. Now, if this is understood about the different function that an adverb performs, an adverb, and I'm pleased to have you. Now, let's look at the topic, adverb and types. Now, what is the definition of an adverb? And what are the different types of adverbs? How do you identify an adverb in a sentence structure? To learn more about this, I would like you to do something for me. Kindly join the class while I get to explain to you majority of what is required. I will be waiting for you. All right, let me explain in detail, class, about this particular topic, adverbs and the different types of adverbs. Now, what exactly is an adverb? Now, an adverb is a word which modify three things, basically. And what are those three things? A verb, that's the first thing, an adjective, and other adverb in a sentence. When looking at an adverb, your attention should be on an adverb modifying a verb as the first thing, an adjective, and other adverb in a sentence. Three basic things. And there are different types of adverbs, okay? There is an adverb of time, an adverb of place, an adverb of frequency, an adverb of manner, an adverb of concession. There are many of them, and I'm going to explain each of them one after another. Now, if this is understood about the different function that an adverb performs, an adverb modify a verb, an adjective, and an adverb. And there are different ways to which you can notice an adverb in a sentence structure. And what are those different ways? Basically, adverb ends with ly, okay? So when you add an ly to an adjective, you will definitely form an adverb. In a case of where you have the word, you have smart, for instance, okay? This is an adjective, the word smart. Definitely, by the time you add ly to the word smart, you would form exactly as what? As smartly, which is what? Which is an adverb. There are other examples to that. Like you have a word like active as an adjective. The moment you add ly to active, you would form actively, which is an adverb. You can use them in a sentence. Let's look at the different types of adverb in a sentence. The first aspect is an adverb of time. What do you think that an adverb of time will indicate? An adverb of time shows the particular time or when an action is performed. An adverb of time helps to indicate at what time or when exactly did the action happen. That's an adverb of time. And before you could use that, there are certain words that are very important to occur, and which are the word like when is very important. The words like soon is very important to indicate time. You can even have whenever. You can even have after, and so on. These are examples of adverb that helps to indicate time. You can make a sentence with that. He arrived. He arrived when it was late. He arrived when it was already late. So what do you have? He arrived when it was already late. That's a full stop to that. Trying to make a sentence for you to understand better for adverb of time. He arrived when it was already late. What can you observe? There is when there, which indicates what? The time to which who arrived. The person, which is the identity or the subject. This is the subject of the sentence. And you have he, okay, I arrived when it was already late. I arrived when it was already late. Here is the subject of the sentence, and this is the verb, okay? And this is what? The adverb of time that indicates at what time did he arrive. It was already late when he arrived. Now, if this is clear enough, let's proceed to the next one. We have adverb of place. There's also adverb of place. Now, what exactly is adverb of place? An adverb of place helps to show the location or where exactly the particular action occurred or happened. So it indicates where an action happened or occurred. That's an adverb of place. And there are certain examples of an adverb to help you indicate or notice this. Examples can be where, for instance. You can even have wherever. Okay. Aside from that too, you could possibly have here. Okay. You could even have there, indicating a location, and so on to this. So you can have an example in sentences that's e.g., where did he go to? Meaning you're trying to seek to know the exact location of where the person actually proceeded to. So where did he go to as a question? Now where is indicating an adverb of what? Of place. It's indicating an adverb of place. Now let's proceed to the third part, which you have as adverb of manner. Adverb of manner. Now what exactly is adverb of manner? An adverb of manner helps to tell or to show you how an action is performed. Do you understand? How an action is performed, basically. If an action is performed in a particular way, the adverb of manner will reveal. And there are other examples to show the adverb of manner. Now take a look at that. You can have as if, as though. Okay, you can even have even though, and so on. You can see that. So these are examples to show an adverb of manner in a sentence. Now look at that. He acts as if he was the captain. He acts as if he was the captain. And what can you notice? As if is used here to indicate what? An adverb of manner. An adverb of manner. And what does that mean? He's not the captain. He's simply acting as if he was the captain. Meaning it is so glaring that he wasn't the captain. He was simply acting as if he was the captain. So that's why you have he acts as if he was the captain. So now, an adverb of manner there, which shows how an action is performed, is as if. Now, if this is clear enough, then let's proceed to the next part, which is number 4. where you have an adverb of frequency. An adverb of frequency. Now, what's an adverb of frequency? Now, this helps to show the rate of an occurrence of an action. How many times, at what rate does an action happen or occur? Now, there are certain adverbs that is going to give you a guideline to those adverbs of frequency. Take a look at this. You have, for example, you have always. Now, obviously, always will tell you that such action happens frequently, okay? Now, you can also have often, for instance. Aside from often, you can also have seldomly. Seldomly simply means it doesn't happen most times. Then you can also have occasionally, for instance. You can have occasionally. You can even have sometimes, and so on. There are many more to this. These are called adverb of frequency examples. Now, you can have, in example here, you have he visits. Okay, he visits always. He visits always. And what does that tell you? Now here, always here is what? An adverb of what? Of frequency. An adverb of frequency, which tells you at what rate does he visit? Meaning he visits always. Now let's look at the fifth part. The fifth part is an adverb of reason or an adverb of purpose. And what is the function or what's the meaning of this? An adverb of reason or purpose tend to indicate why an action is performed, the reason behind an action, or what led to an action. That's an adverb of reason or purpose. An adverb of reason or purpose. So practically, both of these means the same thing. And what are examples under this? You can have why, you can have because, you can even have so, you can have so that. Do you understand? And many more. There are many more examples to this. So we can pick any one of these to illustrate a sentence for better understanding. Okay, take a look. E.g., we could pick this where you have he ate the food, all right, because he was hungry. He ate the food because he was hungry. And that's a full stop to that. Now let's analyze this together. Now, he has performed an action. He ate the food. And the writer went further to tell you why such action of eating the food was performed. And what's the function? Said, because he was hungry. Meaning that he had to eat the food. He had to eat the food because he was hungry. Okay? That means if he was already satisfied, he wouldn't have eaten the food. Now, if that is clear enough, let's proceed to the sixth part. We have the adverb of condition. The adverb of condition. Now, from the word, the adverb of condition helps to show at what condition, what could possibly necessitate an action, or under what condition should an action occur. That's an adverb of condition. And there are different adverbs that can suggest to you how to identify adverb of condition. Take a look at this. Now you have if, can necessitate that. You can have provided, okay? Provided that, can necessitate that too, okay? Any of this can necessitate that. You can even have until, you can even have unless. Let me give you more. Unless. So please, class, anytime you see any of these adverbs, they help to necessitate, to show you or to tell you that this is talking about adverb of condition. I'm going to give you a very funny example, and let's see. So I can use any of this, e.g., I can use any of this. Okay, I have provide. So this could be provided that. Let me make this provided that. So you have this as provide, you have this as provided that. You know how ladies behave? This is a very funny way, actually, but just to illustrate an example, ladies will say, I will agree to go out with him, provided he foots my bills. You can see that now. So there's a condition to that particular statement. Meaning, if you're not ready to foot the bill, she's not ready to go with you. All right? So now take a look at that. So I will agree to go with him. All right? There you have provided, that's the conditional form of it. Provided you foot my bill. Meaning that as the man, you have to be financially capable to do that. All right, so class, here we have about 6 adverb. Let me see. Let me give you one more to make it 7. Okay? And I'm going to illustrate this here. Hope you don't get confused. This is how we go. 1, 2, 3, 4, 5, 6. And I'm going to give you one just right here because of the space. Okay? So now let's take a look. Number 7 is called an adverb of concession. An adverb of concession. All right, so now let's take a look at this part, which will be the last part, an adverb of concession. And what's an adverb of concession? It helps to show the contradictory nature, the opposite idea, okay, of a statement or an information. So that's what this helps to show. A contradictory idea or information. Now, examples of adverb of concession could be though, could also be although, okay? You can even have even though, and so on, that's etc. So we can use any of these for an adverb of concession. Well, let me give you an example, okay? Now you have although he was invited for the party. He was invited for the party. Although he was invited for the party, but he didn't attend. Now look at this now, class. Now, although he was invited for the party, okay, yet he didn't attend. I purposely illustrated this. I wanted you to see this. If you construct a sentence, don't always use although with but. All right? Always use although with yet. I illustrated this to make a correction to you. And you don't say although and but. You don't say so therefore. You don't say still yet. They are tautological statements and you're not supposed to use them. Okay? You don't say should in case. No, they are very wrong. You have to apply redundancy rule, which states that out of those two, just pick one. In case he returns. Don't say should in case he returns. No, in case he returns. Okay, so don't say so therefore. No, therefore is practically applicable. Okay, they'll also use although but. So here we would replace redundancy rule with yet in this case. So although he was invited for the party, yet he didn't attend. Most appropriate. Now, class, I'm going to give you a drill, and what I need you to do is for you to identify or tell me what type of adverb, okay, that could indicate. Is it an adverb of time, or an adverb of place, or an adverb of frequency, or an adverb of manner? I need you to identify that for me, all right? So now let's take the drill. All right, class, so let's look at a drill on adverbs. And the instruction here is to identify the type of adverb in each of the following sentences, okay? Now, look at the first sentence. You have, she acts as if she were the captain. And in that case, what can you identify? As if here is present, like I explained in the class. So now, she wasn't the captain. She's possibly acting as if she were the captain. So in that case, you have an adverb of manner here. So I should expect you to also indicate same in your notebook. Now, if that is clear, now let's proceed to the next part, which is number 2. Tolu slapped Tola because she insulted him. All right. Now, Tolu performed an action of slapping Tola, and there's a reason for that. Now, you have because, which gives you an adverb of reason, while Tolu had to slap Tola was actually because she insulted him. So in that case, you should have an adverb of reason or the purpose to which the action is performed. So we have reason or purpose. Now let's proceed to the next part. You have, I know where Michael kept the book. Okay, and this is somebody talking, saying he or she is aware where the book could be found. Okay, in that case, you have where is indicating what? An adverb of place. So let's look at this. So this is an adverb of place. Now proceed to the next one. I think I like her personality, though she misbehaves sometimes. So in that case, what do you have? Though here is showing what? A concession. All right. Concession, I told you earlier, was a word to which shows a contradictory idea or an opposing idea. And what is contradictory about this? Now, someone is affirming that he thinks that he likes her personality. Okay, that's the positive aspect of that sentence. And the negative aspect here is, though she misbehaves, as a negative complement. She misbehaves sometimes. So in that case, what you have is concession. That's an adverb of concession. Okay, now if that is clear, let's proceed to the fifth part, which is the last part. Said, although she's friendly, that's a good compliment. Although she's friendly, yet everyone dislikes her disposition. All right, obviously, if someone is friendly, everyone should at least like her disposition. But in this case, you have although, which is showing a form of contrast, and you also have yet, which is showing a form of concession too. So in that case, number 5 will be an adverb of concession. Now take a look at this. I believe this should be clear as at this point. What I needed to do is, if you have any particular question, all right, quickly post that on the platform. I'll read that and I will give a feedback on that. I hope you enjoyed today's lecture. Then I hope to see you in subsequent classes. Thank you so much.
Introducing your study path. Your study path is a curriculum-based online learning platform for desktop and mobile devices that gives you access to high-quality learning materials. Our platform hosts high-quality pre-recorded videos, live classes, question banks with detailed solutions, and social learning features to ensure that you excel in your academics. We currently have content for high school students in West Africa. You can now have the entire curriculum at your fingertips, pass exams like Jamb, WAEC, and NECO easily. Here's how to use our platform. Using an internet browser, log on to www.yourstudypath.com. Click on Sign Up to create an account, fill the forms, and activate your account. Congratulations! You're now a subscriber to Africa's largest learning ecosystem. Log in with your user details. Here is your dashboard. You can select a study path to get streamlined content for a particular examination goal. To access our video content, select any subject of your choice. You can easily watch videos on any topic. You can find details about your tutor and the topic being taught by accessing the Overview menu. You can also access the question and answer menu to ask questions and get answers. Discussion menu offers interactivity with other users who are taking the same course. You can access the question bank by clicking on the question bank button. Select any subject of your choice. You can view the questions and detailed solutions that follows. Questions can be filtered by category, level, topic, question year, question type, and difficulty. Mock exams offer our users the ability to simulate an exam they're preparing for. To access mock exams, click on the Mock Examination button. Here, you'll get access to the upcoming mock examinations. Welcome to your study path.
Welcome to your mathematics study path. We have concluded the fact that plane shapes form a very important and essential basis for the construction or formation of solid shapes, right? Of course, we have said that some examples of these solid shapes have included the cubes, the cuboids, the prisms, the pyramids, and so forth. However, these plane shapes are not just put together in any given form. they have standard structures, they have standard combinations, and they have standard rules that guides their combinations into these various shapes. In fact, to calculate or to construct the various plane shapes themselves, we have to take note of the sides. We also have to take note of the angles with which they are combined, right? So it becomes very, very important for us to now look down at those angles and those sides and then learn exactly how to construct each and every single one of them. This brings us to the focus for this session. And for this session, we'll be looking at the concept of geometric construction. In this session, we will learn how to construct basic angles, the angle 30, the angle 60, the angle 90, the angle 180 as well. All basic angles that exist, we would learn how to construct them in this class. You would also now be able to extend these basic angle constructions into other angles like 135 and so forth and construct them as well. We will now take our learnings from these basic angles into the construction of various triangles and other quadrilateral polygons that can exist as well. Of course, you know, when we talk about quadrilateral polygons, we'll be talking about the squares, the rectangles, the parallelograms, and so on as well. So we'll extend the construction from the angles and the sides into the plane shapes themselves. Remember that once we have the plane shapes, we can easily also extend that concept to the solid shapes in total. Now, after we have learned about constructing different kinds of triangles, we will now also extend the concept into the construction of an equilateral triangle, right? For an equilateral triangle, we know that this means that all the angles are the same. They are not just the same, they are 60 degrees. And then all the sides are also equal, right? This is the unique consideration that equilateral triangles have. So we'll use our constructions of angles and of sides and of general triangles as well to now look at the specific constructions of equilateral triangle. This particular session will be hands-on and will be done with your full practice in mind. So while we do it in class, you would also have your questions and examples which you also practice in tandem with the lecture as well. This would prove to be very, very interesting and engaging as well. So join me in class. Welcome to class. Now for today's session, we are going to be taking a much more hands-on approach. This is because we are dealing with the topic of constructions, and for these constructions, the best way to learn them is to learn them by practice. So we will be doing this hands-on on our A3 paper. So we'll see the process and how it goes. We'll carry the process step by step for each part of the construction process and then piece everything together in a meaningful whole. As I am making this practice on the A3 paper, it's expected that you also will carry on this practice as well, so you get a feel for the process and learn this practice session. So let's begin. Now, the very first thing to note is the fact that for our geometric progressions or for our geometric constructions, we are much more importantly focusing on the angles, right? The sides and the angles. We cannot construct any plane shape or any solid shape without a focus on the sides and the angles. The sides and angles make the bulk of the construction. This would not change in this process. So we'll start first and foremost with the basic line, then our basic angles, and then continue from there. Now, the very first part that we are going to be considering is what we call the line segment. Now, when we say the line segment, we are simply talking about a representation of angle 180 degrees, right? In another term, we can also term this as the angle on a straight line, right? So whenever we have a straight line, just simply know that we are simply talking about the line segment or the 180-degree angle or the angle on a straight line. Now that we have that measurement, let's now see how exactly we plot this. Now, to plot this, the most important thing is just to first and foremost draw a perfectly straight line. Now, our instruments for this session will be our instruments in the mathematical set, right? So we have the ruler, we have our protractor, we have our set squares, we have our compass, we have our dividers, and of course we have the pencil, the eraser, and then the sharpener. Right? So these are the basic instruments. I've also added a 30 centimeter long ruler as well, in cases where we have a construction that the small ruler in the math set would not be sufficient for. But these, in major terms, are the instruments that are necessary for geometric constructions. Now, the very first thing we must know is that for these constructions, you must pay very, very important note to the side and the angle. Now, we are saying we are drawing the angle 180 degrees. The translation is that we are drawing an angle on a straight line. So the very first thing is pick an angle on a straight line, right? So we have a straight line. Ensure your measurement is standard. In this case, because we are constructing the angle itself, we can use any arbitrary measurement, right? So if you pick a measurement of 8 degrees, for instance, 8 centimeters, for instance, now this is a 0 point and these are 8 centimeter points, and then we draw our straight line from here to here, and then we label this A, and then we label this B. The very first thing we note is that this line, which is 8 centimeters, would obviously have a midpoint, right? So if it's 8 centimeters, then the midpoint is obviously going to be at the 4 centimeter mark. That's the very first thing to note. Now, if this is our midpoint, which is the 4 centimeter mark, at this point, let's measure the angle we can find at that position. So we place our protractor here, and then what do we find out? We find out that the line is perfectly straight on that protractor, and then from 0, it goes extremely ending at 180 degrees. This is what it means to have an angle on a straight line. So on that straight line, from any point, of course, you don't even have to be at the midpoint. Any point you measure it out. We are just using the midpoint to ensure simplicity. At that point, at any point on the straight line, the total angle here is 180 degrees. So that's the very first thing we are looking at today. The angle on a straight line is 180 degrees. And we call that straight line, in fact, the line segment. Now that we have talked about that, let's also look at the concept of the 90-degree angle. The 90-degree angle. So how do we plot this? The 90-degree angle is also what we refer to as the right angle. Now, the very first thing we note is that 90 degrees is obviously half of 180 degrees. That's the very first thing we are noting. 90 degrees is half of 180 degrees, right? So it means that if we have 180 degrees here, what we need to ensure is we need to ensure half of this 180 degree angle. That's all well and good. Now, how do we ensure this 180 degree angle? Let's continue. There are some standard steps we can follow in order to ensure the position of this 90-degree angle from our drawing of the straight line. Now, how do we ensure this? The very first thing is you must be able to choose an angle point. So that's the very first step. We must choose an angle point. So we have steps here. We are going to list them out. We have to choose an angle point. Then, when we have that angle point, in this case, the moment we have those angle points, we must now pick from those angle points some designated points that would attach to it. It is now from those points that will now extend our drawing. Now, in this case, usually our angle point is going to be at the edges of the straight line, wherever the straight line would be, right? However, it doesn't mean that that must always be true in every single case. We can also extend the angle point away from the edges. So let's see exactly what we are talking about. Now, in this case, we will not just be using the pencil alone, we'll have to use our compass as well. So let's get our compass, and then let's see what we have. We'll put in our pencil into the compass, right? So we have to put in our pencil into the compass. Of course, this is the very first thing. The moment we have to plot in our curves, then we need to use the aid of the compass here to ensure that we have accurate descriptions of whatever curve it is. Of course, whenever we are putting in the pencil into the compass, we must ensure that the pen mouth of the pencil and the mouth of the compass pin itself are aligned, right? this would ensure that we are picking the direct or accurate center point itself. Now, so we have our compass here. We would also need an extra pencil now because we can't keep using the pencil in the compass, right? So these are tools you need. All these will be found in the math set, right? So we need an extra pencil to draw a line, and then we use the compass and whatever instrument we would need. Now, we have to choose an angle point first and foremost, and then at that angle point, we now have to pick our edges. So that's where we are talking about. That's our goal now. The first thing is we have to have an arbitrary straight line of any measurement you like. So for simplicity, let's pick a measurement that is not too small or not too big. So let's pick 10 centimeters, for instance. So from here to here, let's pick our 10 centimeter line, and then we have here to be A, and then we have here to be B. All right, all well and good. Now we have our straight line. The next thing is, first off, we can find the midpoint. Now remember I said that you have to choose an angle point, right? Now usually the angle point you will choose is placed at the midpoint of the straight line. However, it doesn't mean that that is the only point where you can draw your 90-degree angle, right? So we'll draw the 90-degree angle at the midpoint, and we'll also draw the 90-degree angle at any other different positions on the straight line, right? So first off, let's pick a middle point. So we have this as 5 here. So that's our angle point now. Now, what exactly do we need to do? At that angle point, we now have to pick an arc of equal measure on both sides of the angle point. So right, this is our angle point here now. We now have to pick an arc of equal measure on both sides of it. So we are bisecting, or we are intersecting this line on both sides now. So we come here, we make an arc here. We come here, we make another arc here, right? Ensure that you are maintaining an ample distance on your compass. Ensure that the distance is remaining constant. Don't just open it as you like. Now, remember, from the angle point, bisect here, bisect here. Good. We have ensured that. Now, the moment you bisect this, the next thing for you to now do is take the full measurement from arc to arc, right? Take the full measurement from arc to arc. So here, at this point, that's the first arc, we will now extend to the second arc, right? Now, we have picked up the full measurement now. Make a bisection here. So to make it easy, let me label this C, point C, and then let's label this point D. So from point C to point D, or arc C to arc D, extend your compass. Now that you have extended it, now you make an arc on top and bottom from each of the points C and D. So at point D now, I make an arc on top. At point D, I also make an arc below. I switch my compass to point C. Of course, the distance still remains the same. I make an arc on top, and then I make an arc below. The goal of this arc is to ensure that it is forming an intersection point, right? So I'm not just extending the arc, I'm extending the arc at a position where both arcs from C and D will intersect. Now that I have that intersection point, from that intersection point on top to the intersection point below, I draw a line. I ensure the straightness of the line, so using the intersection point below and then the intersection point on top. That's why I use my dots to ensure that I am not pushing my ruler unnecessarily. Then I draw a straight line. So from here to here, ensure the straightness of your line. It cuts from this intersection point to this intersection point. The next thing for you to now do is take your protractor and measure. And you see the protractor point is exactly 90 degrees from line to line. So we have bisected the angle on a straight line into two equal parts of 90 degrees. This is the process for the 90-degree angle. Pick an angle point, make arcs on both sides of the angle point, extend the compass from first angle point to the other angle point, use the compass at each angle point to create an arc on top and bottom, then move to the other one, bisect the arc on top and bottom, and then join the arcs with a straight line. The angle formed is exactly a right angle triangle. Of course, we can do this at any other point on the line, right? The only thing that is important is that you are using that point as your own angle point. Let's say I pick my angle point to be at A, for instance. Now, A is the edge of the straight line. No problem. If I pick my angle point at A, the very first thing is from A, picking A as center, I must make an arc first and foremost. Right? So I've made my arc position. You see that now this arc extends beyond the line. That's fine. That's lovely. It doesn't make any difference. From here to here, that is to my angle position, right? Now that I've made this arc, there are two ways you can go. You can either decide to come here and extend this line by broken lines so you can ensure the straightness of your angle points. So from here, you can extend by straight lines here. So you know, okay, if I place here, I must land here so that you won't be having here and then you are extending this point into here, for instance. You know you are coming on that straight path, right? So let's do that. Let's call this point E, and then let's call this point F, right? So from point F, I plug in my point, and then I extend to E. Then I go up, I make an arc, I come down, I make another arc, I switch, I go to E. From the middle point, I pick an arc, I come down, I extend the arc, all still ensuring that it is still at equal distance. The equality of the distance is very, very important. Now that I've done that, I go from this point here to this point here, and then I draw exactly a straight line. And then again, if I measure at this point, I have exactly a 90-degree angle, right? So this is how we plot our 90-degree angle, which is also our right angle triangle, our right angle point, which is our 90-degree. And you'll find out that this 90-degree angle is the premise for the type of triangle or plane shape which is termed as the right angle triangle, right? So the right angle is simply the 90-degree angle and is gotten from the bisection of the 180-degree angle or from the angle on a straight line. You can also try the same bisection process at B to see if it works clearly. Now that we have done the process of creating the 90-degree angle, we can now move forward and then pick equal bisections of any kind of angle. Now in this case, of course, we have picked 180 degree and then we have split it into two equal parts, 90 on this side, and of course you know that this side also is also a 90-degree angle. So adding them together, you have the angle on a straight line. We can also carry out this process for any kind of angle. We can also bisect any kind of angle into two equal parts. This is what we are going to be doing in our next part of the session. Now, we have looked at the process of constructing the 180-degree angle. I also looked at the process of constructing a right angle, which is the 90-degree angle. In fact, the 90-degree angle is just half of the angle on a straight line. In fact, the technique for plotting the 90-degree angle, which is us bisecting the angle of 180 degrees into two parts, is the same concept that would extend for us dividing any kind of angle into two equal parts. And that process is what we are going to look at now. Now we are going to divide, in this case, we have picked a 60-degree angle. And now we are going to divide it into two equal parts, right? Now we have our 60-degree angle here. We need to divide it into two equal parts, which means that each part of the angle would be 30 degrees, right? So that's our goal. Now, the same process would apply. The very first thing is we know where our angle point is, because in this case, we have it at the 60-degree mark. So this is our angle point right here. Now, from this angle point, we need to also pick our edges, our arcs. Now, remember in the 90-degree case, we moved from the angle point, cut an arc here, and then cut another arc here. We will repeat the same process for this one, but in this case, we are not cutting our arc on this point, on that straight line. The arc will now extend from the lines that cover or bound the angle. Now in this case, this is our angle of 60 degrees. This 60-degree angle is bounded by this B part of the line and then by this upper line here. So we can call this upper part C, right? And then we can call this point O. So 60 degrees is bounded by OC and OB here, right? So it means that if we want to create our arcs, we are going to create our arcs on OC and OB, right? So let's see. Remember, you don't have to use an obscenely large arc. It can just be of normal measurement. So let's reduce our arc a little. Now, make sure your point is at O. That's the most important thing. That's the angle point. And then you cut the arc here and you cut the arc here, right? So ensure that you are using a respectable kind of angle size or arc size. So you have an arc here and then you have another arc here, right? Another way to do it is, instead of plotting two separate arcs here, you can simply just plot a full arc that cuts throughout the entire process. That's fine as well. In the process of doing this is just like saying, on this point, instead of cutting an arc here and arc here, I now cut a full semicircle that cuts through the entire process. That's fine as well. Now that we have done that we have made an arc point here and an arc point here, the next thing for you to now look is, okay, this is our point, let's say this is X, and this is our point, let's say Y. Now, the next thing is, from this point here to this point here, ensure that arc distance, right? So the arc distance, you start from here, that cuts here. The next thing for you to now do is place the compass at one point of the intersection point and ensure that from that point you are also reaching the other point here. Now that you have this, make an arc up top here, right? And then switch to the next point and then make another arc here, right? The goal again is to ensure that both arcs are connecting. Now that both arcs are connecting, you move from the intersection point to the angle point, right? So this is our intersection point here, and this is our angle point here. Ensure straightness of the line, right? And you're done. So if you measure this by the protractor, what do we have? As you can see, this part is exactly 30 degrees. That's the number here, 30 degrees. And then the full arc is 60 degrees. So you can see that 60 minus 30 means that this point here is also 30 degrees. From 0 to 30, this point here is also 30 degrees. So we have bisected this 60-degree angle into two equal parts of 30 degrees and 30 degrees. The process is simple and straightforward. From that angle point you have chosen, make an arc on the line that covers or bounds that angle itself. In this case, 60 degrees is bounded by 0C or OC and OB, right? So we make an arc on OC and then OB, right, at point X and Y. Another way to do it is to draw a straight, or is to draw a continuous arc from OC to OB that cuts it. That's fine as well. Then from X and Y, place the compass at one of those points, extend that compass to the other intersection point. Then once you ensure that distance, make an arc on top, make another arc on to intersect that point, then draw the line and you are good to go. This same process works for when we constructed our 90-degree angle, right? In that case, of course, just as I have mentioned, from this middle point where we made our arcs at C and D, instead of just making the arc, we could have just drawn a semicircle that cuts the entire distance, which is going to be like this arc we have here. And then from D to C, we extended the compass to ensure that the line moved on, and then we made the points on top and then intersected that point. That's the same thing we did at X and Y. We intersected the point on top and then drew the line here, just as we drew the line here, right? So you'll see that in constructing the 90-degree angle, this bottom part can also be ignored, right? We only did this bottom part to ensure that you see the process, that it's compulsory for your line to be straight. If your line is straight, then your protractor reading will be accurate. In this case, you see the same process here now. So let's extend that concept now. We know we have a 90-degree angle here. Let's now try to bisect this 90-degree angle and divide it into two parts. How do we do that? The same process we just did for the 60-degree angle, we can repeat it for the 90-degree angle. Now, in this case, our angle point is still here. Now, from this angle point, pick a respectable distance and then make an arc. So in this case, I'm going to pick an arc that is bigger so we don't cut our D position. So I'm making a full arc now. Now, let's label this P, and then let's label this Q. Now the next thing is place your compass at either P or Q, then ensure that the position extends to the other intersection point, right? So we move the compass here till we get to Q, till we get to P, sorry. So we are at P now. Ensure the distance is completely covered by the arc, right? So we have from point P or from point Q to P. Now that we have ensured this, go up here, make an arc, switch, go to P. Then from P, ensure your tip is exactly at P, make an arc that cuts it. Now that we have done that, from that intersection of the arc, draw it to your angle point. So from the arc to the angle point. And then you have your line. Good. Then we measure. We have our 45-degree line here, 40, then 5. So that's 45 degrees. And then from 90 to 45 degrees, you have another 45 degree here. Brilliant. So it means that we have bisected the 90-degree angle into two parts of 45 degrees, 45 degrees. This is the process for constructions of angles on lines. The straight line has an angle of 180 degrees. You can bisect the straight line into two equal parts to get the 90-degree angle. Then from the 90-degree angle, the same concept that allowed us bisect the 180 into 90 degrees, we can extend it to any kind of angle at all. We picked an example of the 60-degree angle. We bisected it into two equal parts of 30 degrees. We went back to the 90-degree and bisected it into two equal parts of 45 degrees. Now, let's now bring all those concepts together. We have constructed individual angles. Let's now extend the concept into plots for our two-dimensional shapes. We'll start with triangles, which is like the basic closed two-dimensional shape that we have. So we'll now plot angles, sides within a triangle and see how we can use the concepts of construction of angles into the construction of plane shapes. So far, we have looked at the concept of line segments and construction of angles on lines, right? We have also looked at the process of dividing angles into equal parts within lines for any kind of angle. Let's now extend this concept into our construction of two-dimensional shapes, right? Into our concept of two-dimensional shapes. Now, the two-dimensional shape we are starting with is the triangle, right? Now, there are three popular universal ways in which we can construct our triangles. We'll be covering those three types or those three processes in this session. Well, we'll start with the first one. So for the first method, so we have our triangle construction, that's our goal. So the first method is the construction of triangles based on three known sides, right? Now, do not forget that the uniqueness of the triangle is in the ability or the probability of construction of those triangles based on values in the sides or values in the angles, right? Those are the two distinct features in a triangle, the sides and the angles. Now, you can construct triangles based on those distinct features. So the first one is the construction based on 3 known sides. So if you don't have any value for the angle, but the only things you have is the value for the sides, so you know the side A, you know the side B, you know the side C. Remember that in a triangle you should have 3 sides, so you know the value of those 3 sides, and you want to construct a triangle. How would you carry out the process? So that process is what we are going to look at now. Now for this part, we're going to consider a very simple example. We are going to be using our compass, our pair of compass, and our ruler, and we'll be constructing a triangle ABC, right? Of course, the full question will be displayed to you, so you see exactly where we are getting all these values from. So we are constructing a triangle ABC. Now, the feature of this triangle ABC that we know of is the fact that the line AB is 3 centimeters, the line BC is 4 centimeters, and then we have that the line AC is 5 centimeters. Beautiful. So we have AB, BC, and then AC given to us. Now we have to construct the triangle based on only these 3 informations. How do we proceed? Now, the rule of thumb is to always try to ensure that the longest side is the base side, right? So always try to ensure that the longest side is the base side. In this case, the longest side is AC, right? Remember that we are only allowed to use a ruler and a pair of compass. So these are only 2 instruments, right? Of course, as an added advantage, you would also be using the pencil. There is no way the compass would work without a pencil, so the pencil is thrown in as an advantage or a plus, right? So we have to construct this triangle using only these instruments. Let's begin. The longest side should be the base side. We have AC is equal to 5 centimeters. So we'll have that as from 0 to 5. Ensure the accuracy of your line, right? So we'll label this A, and then we'll label this C. So that's 5 centimeters. Of course, the angle on this straight line would definitely be 180 degrees. So we are good to go. Now that we have drawn AC, the next thing is we now have to plot the other 2 sides. AB means that what? The line starts from A, ends at B. BC means the line starts from B, ends at C, or vice versa. And then AC, the line starts from A, ends at C, or C to A. Now, we have drawn AC. To draw AB, it means that we have to start our line from A. However, our only tools are the ruler and the pair of compass. So let's keep our protractor on side. We don't need that now. Now, our ruler, first off, place it at A. Now, the goal at A is to ensure that, yes, we have this to be at 3 centimeters. However, we can't just plot 3 centimeters anywhere. Of course, we can plot 3 centimeters this way, we can plot 3 centimeters this way, we can plot 3 centimeters here, we can even plot 3 centimeters all the way up here, right? So we won't have an idea of where exactly we are going to be plotting this. This is where our pair of compass comes in. So we have, first off, place your compass point at A, then 3 centimeters. So we extend our compass pin from 3 points to the 0 point, right? So that distance, that arc gives us 3 centimeters. Now that we have 3 centimeters, what else? From that point, extend an arc. Make it as reasonable as possible, right? So within this arc, we know that the distance is exactly 3 centimeters. So for any point we measure on that arc, we would have exactly 3 centimeters, right? So this is a safe way. We don't know exactly which part of the arc is the 3 centimeters we seek. So we just draw a straight arc, or we draw a continuous arc that extends reasonably. Now that we have that, we go to BC, 4 centimeters, right? B is an uncertain point. You don't know where B is. So we extend from C. So from C, we have to take 4 centimeters. So we start from the 4 points, and then we extend our compass to 0 yet again. And then here we draw another extensive arc. Now this arc does not have to be as extensive as possible. Your goal in this second arc is to now ensure that it cuts through the first arc, right? So this first arc has extended, this second arc cuts through it. That intersection point is exactly the point of B. Again, from A, extend the arc that covers 3 centimeters. From C, extend the arc that covers 4 centimeters. Those arcs will intersect at a point. That point of intersection is the point B, which is common to both lines. And then from that point B, of course, you see it's 3 centimeters. Draw it to A. And then from that point B again, which is 4 centimeters, draw it to C. And then label as appropriate. So you have 5 centimeters here. You have 4 centimeters here. And then you have 3 centimeters here. Beautiful. So all we have done is use the value of our known sides, 3, 4, and 5, to construct the triangle. We do not have any idea of what the angles within the triangle is, but we have used the concept of the sides to construct it. Start with the longest side as the base side. That's like the rule of thumb. It doesn't mean that you cannot walk around it and start from any other side, but starting with the longest side gives you a kind of balanced structure, right? So then from that side, extend the other 2 sides with the compass. The point where those 2 arcs intersect is your point of intersection of B, which is what brings them together. Join your lines, and then you have the triangle ABC formed and labeled as appropriate, right? So this is 3 centimeters. This is obviously 5 centimeters here, and then you have 4 centimeters here. Now, a good point of note as a trivia is the fact that if you draw a triangle where all the sides are in Pythagorean triples, that means all the sides conform with the standard Pythagoras theorem for whole numbers. Of course, 3, 4, and 5 is a Pythagorean triple. 3 squared plus 4 squared will give you 5 squared. Once you have a Pythagorean triple and you plot that as a triangle, the first thing that happens as a bonus is that one of the angles must give you a right angle. One of the angles must give you a right angle. In fact, that angle that gives you a right angle is usually the angle opposite the longest side. So the longest side here is the angle to be a right angle. So let's just confirm that. We place the factor B straight at the other line. We check. We have 90 degrees. This is a rule of for constructions of triangles are Pythagorean triples, right? If you have sides that are not Pythagorean triples, you are going to have 90 degrees. No, this is only holding true for sides where you have Pythagorean triples as the side values. Now that we have looked at constructions of triangles based on 3 known sides, let's now move on to the next method of construction of triangles. In this case, we don't just know the sides, we just know it may be a part of the sides, and then we also know a value or some values of the angles. How then can we construct that? This is going to be our focus in the next part. So for our first part, we have looked at how to construct triangles using 3 known sides. Now, let's now extend the concept from 3 known sides into an introduction of construction using the angles as well. And not just sides alone, let's also use the angles. So for our second method, we'll be considering the construction using 1 known side and 2 known angles. Right? So in this case, we are picking 1 known side and 2 known angles. Lovely. Now, the very first thing you have to note about this kind of construction is that the known side must be in between the 2 known angles, right? So wherever we are picking the known side from, it has to be in between the 2 known angles. We will see that in this example now. Now for this example, the question again will be displayed on your screen. We have to construct a triangle, right? Of course, we are constructing a triangle ABC. Now, for this triangle ABC, let's pick out what we know. The very first thing we know about this triangle is that the angle at C, angle ACB, is equal to 30 degrees. So you can either decide to write it as this, angle ACB, so the angle is at the middle point here, or the middle letter here, or you write it as C with the caret on top, which displays that we are talking about the angle at C, whichever one works. So we know angle ACB to be 30 degrees. The other thing we also know is we know that the angle ABC, that's the angle at B, is equal to 60 degrees. And then we also know the side BC, which is equal to 10 centimeters. Right? So these are the three facts we know. We know the value of two angles, ACB as 30 degrees, ABC at 60 degrees. Then we know one side, which is BC, at 10 centimeters, right? So let's now begin the plot process. Now, the very first thing in our constructions is we will start again with our side that we know. This known side should be used as the base side. The known side should be used as the base side. Now, the very first thing to note is that when constructing angles or triangles like this, give yourself as much room as possible. The more room you have, the more pretty your diagram will look like. The more constructive and effective your diagram will look like, right? Instead of having to shrink into space, give yourself as much room as possible. So to do this, we are going to shift our baseline towards beneath our page. We have here, let's construct our 10 centimeters here. All right, so we have 0 here, we have 10 here. Let's now piece our line together. And we have here, right? So this will be B, and then this will be C. Lovely. This is 10 centimeters here. Now, let's now pick out the other values we know. We know that the angle at C is 30 degrees, and then the angle at B is 60 degrees. So let's start with the bigger angle first. We are now going to be constructing 60 degrees. Now, we have not thought about to construct 60 degrees, so we'll be using this question as a sample of how to construct a 60-degree angle. Now, to construct a 60-degree angle, just like any kind of angle, the very first thing that is important to note is you have to pick an angle point. Now, in this case, the angle point is easy for us to pick. We are constructing 60 degrees at B. So it means that the angle point is at B. Now, once you have your angle point to be at B, that's lovely. Place, of course, remember to keep the arc of your compass at a respectable distance, keeping your attention on the complete whole of your construction. So, keeping the angle point at B, again, you can either decide to make an extended arc that cuts the line, or you can just decide to cut the line here. That's fine as well. Now, of course, the very first thing is, let's pick this cut here, right? So you can either decide to cut here or create an extended arc throughout the entire process. Now, personally, I prefer to create an extended arc across the entire point, right? The reason is because of this extended arc, I would not have to come back to B to do any of that work, right? B has already extended from here up to this point. Now that I have this, do not shake your compass. Ensure that you still have that particular distance, that particular arc that constructed that point for you. And then at this point where the arc intersected the line, bring your metal tip to that point, right? Once you have your metal tip there, make a bisection of the extended arc, right? So we can call this point of metal tip as, let's say, x1, right? So at x1, make a bisection of the arc using that exact distance or arc that cuts this extended arc in the first place. Now, that point of intersection to your point B, connect it, right? Now, when we connect it, the angle formed there will be 60 degrees. But however, you don't know how long your line should be because you don't know the length that extends from B upwards, right? So it means that using your own discretion, you connect it as long as possible, right? So this is the intersection point. Extend it upwards as long as possible. Now, once you check your point, you find out you still have 60 degrees, right? Beautiful. So you have 60 degrees here, which is exactly what you need at B. That's lovely, right? So this is how to construct your 60-degree side. All you just have to do is first and foremost, pick your angle point. From that point, pick a respectable arc. Make sure that arc cuts the line. Then at that point of intersection of the line, using that same exact distance, cut the arc. Then extend the line here. So you have 60 degrees here, which is here. And then you know A is somewhere on this line, right? You don't know the position of A because you don't know the value of AB. So you can't, you just extend this as long as possible. Wherever it stops, that's fine. Now, let's go to C now. For C, the angle at C is 30 degrees, right? C, which is 30 degrees, is exactly half of 60 degrees. Lovely. What does this mean? It means that once I have 60 degrees constructed, I can just move further to bisect my 60-degree line, which is lovely, right? So first off, I construct 60 degrees and then I bisect 60 degrees into two equal parts. So repeating the process, make C your angle point, extend a respectable arc, right? Ensuring that same distance, make a cut on the arc, right? You know that at that point, once you extend from C, passing through that intersection point, you'd have 60 degrees, but that's not what you need. You need to bisect 60 degrees into two parts in order to get 30 degrees. So using the same concept of bisection, ensure that, of course, by the time you have this 60-degree point here, this 60-degree point here, place your arc at this point. Ensure that you're at equal distance or equal arc to the other bisection point. Then come up here, make an arc, move to the other bisection point, come up here, make an arc. Lovely. So we have bisected 60 degrees into two equal parts. So we have moved in compact form now. First thing is construct 60 degrees, just as we did here. Next thing is bisect or divide 60 degrees, just as we did for 60 degrees here. Remember, we move from X and Y. So this is like our X, this is like our Y. From X, make sure we extend the arc to Y. So from here, make sure you extend the arc to here. So let's have this as, let's say Y1, Y2. So Y1 must extend the arc to Y2, just like X extended to Y, where we did this example. Then from there, make an arc up there, make an arc up there, and then draw. So at this point, we just have to draw a line that cuts from C through that intersection point, right? That's nice. So from C, we extend it upwards, right? Of course, we don't know how long this will be, so we just continue extending it. Now, what do we find out? The moment we extend this and we extend this, there will be a point of intersection of both lines, right? That point of intersection of both lines is exactly the point A. Lovely. So it means that AB is exactly the distance from here to here, and then AC is exactly the distance from this point of intersection to point C. So we have constructed the triangle ABC in between. So we have 30 degrees here, which you can obviously confirm using your protractor. We have 60 degrees here, and then you have ABC as a triangle formed in between. This is a very lovely, neat and precise construction of the triangle. You'll see that by extending our line or by extending the triangle construction into as much space as possible, there was no fear of us running out of space. We were able to extend this line as long as possible and give ourselves room enough to extend this other one to meet that line, right? So this is what it means to give yourself ample space to work on when constructions are concerned. This is how we construct triangles using one known side, which is 10 centimeters in this case, and then two known angles which binds that known side, which is 60 degrees and 30 degrees respectively. we have now gotten the full triangle ABC, and then we can check the value of AB by measuring, AC by measuring, and then the angle at A as well, which should obviously be 90 degrees, right? Do not forget the total angle in a triangle is 180 degrees as well. So if this is 60 plus 30, which is 90, if you subtract from 180, you should have 90 degrees left here. Do check your own construction and confirm that these values remain very, very true. Now that we have done this second method, let's now move on to the next method of constructing triangles. What kind of parameters would we have to have in order to use that kind of method, and then how do we carry out that method of construction? So far, we have looked at the concepts of construction in total. We have started with construction of line segments as well as construction of various angles that can be found on the lines themselves. We have also moved on to look at geometric constructions of two-dimensional shapes. We have started with our construction of triangles, right? We have looked at the first method of construction using 3 known sides. We have moved on to construction using 1 known side and 2 known angles. We have also specified that this known side must be in between the 2 known angles. Let's now move on into our third method, which would now specify the kind of parameters we also need to have in order to make this construction possible. Now, in this case, we would need to construct using, in this case, of course, we have worked with 1 known side and 2 known angles. In this case, we would have 2 known sides and 1 known angle. Right, so unlike the second method where we had 1 known side and 2 known angles, now we have 2 known sides and 1 known angle. That's lovely. Now, the very first thing to also note, just as in the case of the method, is the fact that this known angle has to be in between the 2 known sides, which means that the 2 known sides must bind that known angle, right? So that's the very first thing that is very, very important for us to note. Of course, let's now pick an example to further clarify this concept. This example will be displayed on your screen. In this case, we have to construct again. We are constructing triangle XYZ in this case. Now, the parameters for XYZ is the fact that number 1, the angle at Y, that is angle XYZ, is equal to 60 degrees. The next thing we also know is the fact that XY is equal to 6 centimeters, and then we have that YZ is equal to 8 centimeters. So these are 3 parameters we have. The angle at Y is 60 degrees, XY is 6 centimeters, YZ is 8 centimeters, and we are then to construct the triangle XYZ. Now, of course, remember that we have to use the base, one of the known sides as the base side, right? Now, in this case, we have 2 known sides, so we move into our rule of thumb. For our rule of thumb, ensure that the base side is the longest side, right? So ensure that the longest side happens to be our base side in this case. In this case, the longest side is 8 centimeters, so we will make that our base side. So, of course, make your constructions of 8 centimeters, 0 here, then we have 8 here, so we then connect this to 0, fine, and this will be Y, and this will be Z. Great. Now that we have connected YZ, the next thing to now mention is what other thing can we construct? From constructing YZ, which is 8 centimeters, the next thing is now plot or construct the angle attached to YZ, right? Now, in this case, we have angle XYZ, which is 60 degrees. The angle is at Y, so we move to Y and then construct that angle 60 degrees. Again, the process remains the same. Make Y your center point or your angle point, place your compass at Y, extend an arc that cuts through YZ, then using that same measurement, move to the other part of that intersection, of that point of intersection, then cut the arc here, beautiful, So once you have that arc, that intersection gives you that 60-degree angle which you need. The next thing for you to now do is extend 60 degrees, extend the line based on the value of the length which you have. Now, in the case of method 2 and the example we picked for method 2, we had that we didn't know the length of this line. We didn't know the length of this line. So we just extended it as long as possible. But in this case, we know that at y, there are two possible lines, yz, which is 8 centimeters. And then we also know what y extends to on this 60-degree side. This will give us xy, which is 6 centimeters, right? This is why it's important that the known angle is in between the two known sides, right? So we know that we should have a 6 centimeter line extending from that 60-degree mark. So we place our 6 centimeter point at y, place our compass at that point as well, and then we extend the compass to 0. Now that we have our compass at 0, the next thing for us to now do is create an arc, right? So it means that that arc at that point represents the 6 centimeter mark. Then after creating the arc, we can now extend the compass, or we can now extend the line from y up to that point using the point of intersection. So, boom. And then at that point, we will know that we have point x. Lovely. Now that we have point x at that point, the next thing is now to extend x to z. So from that point x, using that same point, we extend it to z. So our goal now is to reach z. So we have z here, and then we have x on this point here. Then we extend. Lovely. And then we have completed our construction here. So all we have simply done is, first and foremost, choose a baseline. We have chosen the baseline to be the longest side. Next, from that baseline, construct the angle attached. In this case, the angle attached is this 60-degree angle. Of course, verify it using your perfector. Then, from that 60-degree angle, we can extend the line for 6 centimeters up to the point x. So this place is 6 centimeters. And then from that point x, join up to the point z on the other side to complete the triangle xyz, where the parameters are 2 known sides and 1 known angle. Lovely. This completes all the 3 popular methods of constructions for triangles. Of course, triangles are not the only kind of 2-dimensional shapes that we can construct. This is just the basic elementary kind of shape that we can begin our constructions from. Having looked at the concept of our triangles, let's now move further from 3-sided shapes, 3-sided plane shapes, into 4-sided plane shapes. 4-sided in this case is what we now refer to as our quadrilaterals. Quadrilaterals are simply 2-dimensional shapes that are 4-sided. So how then can we construct these quadrilaterals? This is what we are going to be looking at in the next part of this session. So far, we have looked at the concept of geometric construction, basic line segment, basic angles that you can find on a line, as well as the construction of 2-dimensional shapes starting with the triangle. We have looked at the different methods in which you can construct the triangle. Let's now move a step further. Let's now move into the construction of 4-sided 2-dimensional shapes. When we say 4-sided, we are simply talking about the family of quadrilaterals. Now, quadrilaterals is just the full name or the full family name for every single 4-sided plane shape, right? Be it the square, be it the rectangle, be it the kite, be it whatever 4-sided shape you can have, they are all jointly called the quadrilateral, right? Now, for these quadrilaterals, as in the triangle part, we can have different methods in which we can construct the said quadrilateral, right? Now, we'll look at those methods one by one, taking time to consider the steps in which we can construct based on each method, and then how we can construct the quadrilaterals in general. Now, the very first thing to note for our quadrilateral is the fact that for these quadrilaterals, for some regular quadrilaterals like the square and the rectangle, we do not need so much information, right? So for that, we'll start, of course, we are starting with the quadrilateral. Now, for the quadrilateral, in fact, for the square, we do not need so much information. The very first thing we know about the square is that all sides are equal. So if all sides are equal, it also means that all angles are equal, right? And in fact, all the angles being equal is exactly 90 degrees each. So each angle within a square is 90 degrees. All sides are equal within a square. So it means that for the construction of a square, we already have the angle, standard 90 degrees, right? And with that angle, we can move further to construct whatever side value we are given. So that is a simple, straightforward construction itself. For the rectangle, the process changes a little, but then it's still a little bit standard, right? So for the rectangle, you have two distinct sides, right? You just have two distinct sides, which are the length and the breadth, right? Even though you have four sides within the rectangle, you only have two distinct sides within that shape. You only have two distinct sides within that shape, which is of course the length and the breadth, right? So the other two sides are just mirror reflections of the two distinct sides. So let's say you have a basic shape like this. If this is your length, then this is just a mirror reflection of it, and if this is your breadth, this is just a mirror reflection of it, right? So you don't need a lot of information for this as well. The other thing you also have to know for the rectangle is that all the angles are equal as well. So all angles are equal still. So all the angles are equal and they are exactly 90 degrees each, right? So you already know the value of the angle, and then you have two distinct sides for the square, for the rectangle, and then for the square, all the sides are equal in length, right? So it means that for the square and the rectangle, we do not need to go through a very, very rigorous process in trying to construct it, since we already have an idea of what the value would be, right? So these are trivial cases of the quadrilateral. Let's move. Our focus will now be on the much more complex kind of quadrilaterals that you can have, quadrilaterals that do not have equal sides, or even if they have equal sides, you do not have the luxury of figuring out what angle you would have inside. But like this case, we already know that the square, the rectangle, it has 90 degrees all sides, right angle triangles in each point. So you have right angle here, you have right angle here, you have right angle here, you have right angle here. You don't have that for all the kinds of quadrilaterals. So we look at all these quadrilaterals where you do not have the simplicity of value, and then how to plot them. Now, for a quadrilateral, we'll start with the first method of plotting. Of course, just like in the triangles, there are different methods in which we can use to construct our quadrilateral. So now for the first method for constructing the quadrilateral, we are going to consider having four known sides. Right, so all four sides are known, and then one known diagonal. Right, so you have four known sides and one known diagonal, right? So in this case, of course, even the diagonal can still be thought about as a side or a length, right? So we are considering the lengths themselves. We are not considering any angle in this first method, but you have four known sides, which are the edges or the sides around the edges, and then you have a diagonal, which is the bisector of those edges, right? Now, the very first thing is, let's have an idea of exactly what we are getting ourselves into as far as this quadrilateral is concerned. We are going to have a four-sided shape, so this is just a sketch. We're going to have a four-sided shape, and then we have a diagonal, right? A miniature diagram. So we have a diagonal value, and then we have four known sides. So this is what this first method is talking about. Now, let's consider a question. Again, the example would be displayed on your screen. Let's now pick out the exact values within this example. Now we are to construct a quadrilateral. So we are constructing a quadrilateral ABCD. Now, what are the parameters that we have for this construction of ABCD? We have that AB is equal to 3 centimeters. We have that BC is equal to 5 centimeters. We have that CD is equal to 4 centimeters. And then we have that AD is equal to 4.5 centimeters. Then we have that AC is equal to 6 centimeters. Lovely. So these are the values we have, and we have to construct a quadrilateral using these values, right? Now, the very first thing again is let's try to image out how our diagram or construction would look like. We should have 4 sides because it's quadrilateral. Let's say this A, B, C, D, right? So we have AB as a side, BC as a side, CD as a side, AD as a side. Then we have AC. So it means that AC, which is not a side, but a length within the quadrilateral, is our diagonal, right? So AC is the diagonal. That's the very first thing we have to understand. You must be able to ensure the position of the diagonal. You must be able to ensure which of the lines is acting as the diagonal. That's the very first start of the construction process. Now that we have identified that AC is in fact the diagonal, let's now move forward to construct this using our ruler and pair of compass. Now, we are going to start with the diagonal. So the diagonal now is our start point for this method, right? So we start with the diagonal, which is 6 centimeters. Ensure that you are giving enough room for your construction, enough room on top and then below. So we have 6 centimeters. Of course, start from 0, then move to 6. Then, of course, we connect this. Lovely. So this is A and this is C. Okay, we have constructed the diagonal. Now, what else can we notice from our rough sketch? We notice from our rough sketch that by picking AC as our diagonal, we notice something very, very important. ABC is a triangle. ADC is also a triangle. So it means that by using that diagonal, we have splitted the quadrilateral into triangles. Triangle on top, triangle below. Right? So it means that we can construct the triangle on top and then construct the triangle below, and then we would have the quadrilateral in full. We are going to go forward to do exactly that. So we have AC here. From our rough sketch, we need to have ADC, and we need to have ABC. So if we have ADC now, it means that from A, we should construct AD. Again, when we are constructing line where we don't have any angle, of course, you know how it is. You have to construct using your compass. Now, AD from our given value is 4.5 centimeters. So it means that we have to ensure 4.5 centimeters on the ruler itself. So we have 4.5 mark here, and then we need to extend this compass to the 0 position. Now that it's at 0 position, we extend an arc, right? So we know that D is somewhere on this arc, and then from C position, we would extend CD. So come to C position, CD is 4 centimeters, so place the 4-point mark at C, and then this time we have to reduce this compass, then extend to 0, and then we'll plot. Right? So we have an intersection. That intersection is what we need. So it means that that intersection point is exactly D. And then from that intersection point, we return to A, connect it. Beautiful. And then from that intersection point again, we return to C and we connect. Lovely. Right? So we have CD. And then we have AD. AD is 4.5 centimeters. And then CD is 4 centimeters. Lovely. Now that we have done that for ADC, let's do the same thing for ABC. So from A, we need to construct AB. AB is exactly 3 centimeters. So from A, we put the point at A, and then from the 0 point, we extend this to 3. So we reduce this now to 3. Great. And then we have our arc. Lovely. So we know that the point B is somewhere on this arc. And then from C, again, we should have that CB or BC is 5 centimeters. So we put our point as B, right? And then we have 0, and then we are extending this now to 5. Great. So from here, we put our arc, and then we have an intersection point. That intersection point gives us B. Lovely. So from that intersection point, we return to A. From that intersection point, we return to C. Right? So it means that AB is exactly 3 centimeters, and then BC is exactly 5 centimeters. So you have 5 centimeters here, and then you have 3 centimeters here, and then diagonal AC is 6 centimeters. This is our construction of the quadrilateral when we have 4 known sides and 1 known diagonal. The process is simple and straightforward. Identify which of the lengths is the diagonal. Draw the diagonal first. From the diagonal, extend the triangle upwards and downwards to get the full quadrilateral shape. This is the process we have done for this method. However, this is not the only method in which we can use to construct our quadrilaterals. Let's now move on to the next method, see the parameters we have for that method, and then how to use it to construct the quadrilaterals. Lovely. So we have started with our first method for construction of quadrilaterals or 4-sided 2-dimensional shapes, which is the 4 known sides and 1 known diagonal. Let's now continue to our second method. Now for this second method, we are now going to be considering the case where we have 3 known sides, 3 known sides, and down we will now have 2 known diagonals. Right? So now we have 3 known sides and 2 known diagonals. Right? So in this case, we had 4 known sides and 1 known diagonal. In this case, we would have 3 known sides and 2 known diagonal. Right? So how do we plot this? Let's use an example to showcase this construction process. Now, this example will be displayed on your screen. We have to construct a quadrilateral again. So we are constructing a quadrilateral. In this case, I'm just going to put this shape here, and then we are constructing a quadrilateral PQRS. Now, what are the parameters we have for PQRS? We have that QR is equal to 4 centimeters. We have that PS is equal to 5 centimeters. We have that RS is equal to 4.2 centimeters. What else do we have? We have that PR, in this case, this is the diagonal, which is 6 centimeters. And then we have QS, which is another diagonal, which is 6.5 centimeters. So in this case, we have been alerted enough to be given the values of the diagonal straight, but it wouldn't hurt for us to construct a miniature graph or a miniature plot or a miniature construction to show exactly what the shape would look like whenever we're done. So of course it's 4-sided, so that helps us out. Now a 4-sided shape, it's PQRS at the edges, PQRS, so it continues. Ensure the numbers must go whether clockwise or counterclockwise. It follows PQRS. Now QR, PS, PS, RS. Now PR obviously is a diagonal because it's inside. Then QS is also obviously a diagonal. Now what else can we notice? What we notice is the fact that we have QR, we have PS, we have RS 4.2. We also obviously have the values of this diagonal and this diagonal. So I'll just put a mark here to simplify or to showcase the fact that we have the values for those 2 diagonals. Right? Now, if we look at it carefully, we don't have the value of PQ. Right? So it means that the triangle PQS is incomplete because we don't have the value of this side. However, if you look at the triangle QRS, we have all the values we need. We have QR, we have RS, and we have QS, right? If you look at the triangle PRS, we have all the values we need. We have PR, which is the diagonal, we have PS, and we have RS as well, right? So it means that if we split using the diagonal, we can start our construction with the triangle that is complete and then extend it to the other parts of the quadrilateral where we do not have the value. This is the process we are going to use for this construction, right? Now, in this case, we are going to start with the PR diagonal, right? Of course, you can either start with the PR diagonal or we start with the QS diagonal. The goal is to ensure that it is connected to a triangle that has all the sides known. That is the key fact. If we start with the PR diagonal, then it means we are using triangle PRS. PR, RS, and PS are all known. Lovely. If we start with the QS diagonal, it means we are using QRS. QR, RS, and QS are all known. We cannot use QS and then try to plot PQS as a triangle because PQ is not known. This is the usefulness of a rough sketch to show exactly what we are trying to get within our construction. So we can either decide to use PR or we can either decide to use QS. If we decide to use PR, all well and good. Let's use PR in this case. PR is 6 centimeters. So, of course, give yourself enough room to operate. So we have 6 centimeters from the 0 position here and then 6 position here. So we have PR drawn here. Now, what do we know? We know that from PR, the complete triangle attached to PR is PRS. So it means we are trying to construct PR and then RS and then PS as well. We have constructed PR, all well and good. We now need to construct PS, which is 5 centimeters. So we pick our compass, put the metal tip at P, then we are plotting 5 centimeters. So we extend this to ensure we have 5 exactly. Beautiful. Then we draw an arc representing that 5 centimeter point. So we know that S is somewhere on this arc. We go to R as well. And then we are plotting RS in this case. RS in this case is 4.2. Now, don't forget, these little points are 0.1, 0.2, 0.3, 0.4, 0.5, and it continues like that. So 4.2 will be the second small line here. So we have 4.2, trace it carefully. Of course, you're at R, you have 4.2, and then you are returning this back to 0.0. Lovely. Ensure you are stressing or you are stretching the arc as possible. It's also neat to ensure that you have a compass that is sturdy, right? A compass that does not shake around a lot when you make these adjustments, right? So you have a sturdy tip, you have a sturdy pen, and a sturdy hook, and then the metal tip is also sturdy. And then at this point, you intersect the line. Great. So that intersect point will give you S, right? Because you're constructing PRS. And then from that intersect point, we stretch for 5 to P. Lovely. And then from that intersect point again, we stretch from S to R for RS. Beautiful. Right? So we have PRS. And then we are now moving on to construct the other part, which is PQR. Remember, we don't have PQ. So we move to R and construct Q that we have. So from R, place our compass, put our ruler at the 0 point for the compass, and then reduce this connection to 4. So reduce this to 4, ensure accuracy. So we have 4, then we draw a line. Brilliant. So we have a line there. Now, of course, we can go to P and then try to form a connection with this line here for Q. Why? Because we don't have the value of PQ. So what do? Since we have already formed the connection from R to Q, which is 4, we look for the other line that connects to Q that we have its value. What else is that line? We look from our rough sketch to Q, we have RQ, PQ. We also have SQ or QS. Right? So it means that from S, we can also form a line to Q once we have that value. Eureka! We have the value of QS. The value of QS is 6.5 centimeters. So what do? We move back to S now, place our point at S, and then extend 6.5 centimeters on the ruler, right? So we have 6.5, lovely. And then we make an arc to cut and intersect the line, right? So it's essential we have an arc that is long. In this case, you see that our arc at R almost did not meet the intersection point. So of course, you can go back to R and try to increase that intersection point as appropriate. So yeah, just extend the line as that. And you have that intersection point. That intersection point is the value of Q. Right, so we have formed the intersection point from QS, which is 6.5 centimeters, and then QR, which is 4 centimeters. So we come here, we extend this to the point of intersection. Lovely. We can extend the diagonal here if you like. So I can just use broken lines to express that, okay, this is the diagonal QS which we used. But now with these two values, we can now form that intersecting line to P and then get PQ, right? So we have used the value of the diagonal here, SQ, which we know, to form the point of intersection, which is Q. This is the usefulness of this diagonal line. So we have PS, which is 5 centimeters. We have RS, which is 4.2 centimeters. We have QR, which is exactly 4 centimeters. And then we have PR, which is the diagonal here, which is 6 centimeters. And then QS, which is 6.5 centimeters. The plot or the construction for Q will have been incomplete if we did not have the value of this diagonal QS. This is why 2 known diagonals are important when you only have 3 known sides. This is the process for construction of quadrilateral using 3 known sides, in this case PS, RS, and QS, and QR, and then 2 known diagonals, in this case PR and QS, right? Remember that your start point should always be to pick out the part of the quadrilateral where every single side of the triangle is known. Once you have every single side of the triangle, you can start your construction from there and then extend it to the other part of the quadrilateral, right? So you see that for method 1 and method 2, we have followed the process of trying to split the quadrilateral into 2 triangles and then plot the join of both of them. This has worked for method 1, this has worked for method 2. Let's now see what method 3 brings into play. In method 3, what will be the parameters we have to work with, and then how then can we now plot those parameters in order to construct our quadrilateral.
All right, it is known that as far as figure of sound is concerned, we have many of them. However, we have those that pertain to repetition of same consonant sound and those that concern repetition of same vowel sound. And that's talking about alliteration, consonants, and assonance. In this lesson, I'll take you through the meaning of alliteration, consonants, as well as assonance, how to apply them, how to identify them, and of course, different examples of the use of these figures of sound by different authors in their various works of art. Why not join me in class as we do justice to this topic? See you in class. Okay, so I welcome you once again to yet another time of learning. In this lesson, we shall treat 3 very important figures of sound. And we're talking about alliteration, consonants, and assonance. Now, when we talk about sound, basically, whether in literature in English or English phonetics, we are talking about two sounds, the vowel and the consonant. So figures of sound talk about the repetitive use of the same consonant or vowel sounds in two or more successive words in a poem. Let's bring this knowledge home. When we talk about alliteration, by alliteration, we refer to or we mean the repetitive use of the same consonant sound, usually at the beginning of two or more successive words in the line of a poem. So the point is this: if I have, for example, 5 words making up a line of a poem, and at the beginning of maybe 3 or 4 or even all of the 5 words in the line of that poem, if what we have there is the same consonant sound, then we talk about alliteration. That's why we said that alliteration simply is a figure of sound in which there is a repetitive use of the same consonant sound usually at the beginning of 2 or more successive words in the line of a poem. Examples, we can have the following. Father Francis fried 5 fish for 5 French friends. Now, in this case, you see the repetition of the same consonant sound here as underlined. Then the next one talks about Sally stole some salt. Sally stole some salt. We have the word now, sound, being used repeatedly as also underlined. So these 2 sentences exemplify the application of alliteration. Now the next one talks about consonants. Now this also refers to the repetitive use of the same consonant sound, usually in the middle or at the end of 2 or more successive words in the line of a poem. Now note, alliteration is usually at the beginning of the words, while consonants is usually in the middle or at the end of those words. Now, because we have the same word now, consonant sound used repeatedly in the middle or the end of 2 or more successive words in a poem, then we can refer to that as consonants or internal alliteration. So you either call it consonant or refer to it as internal alliteration. So let's go on. So what are the examples we can have? He has a stash of cash. He has a stash of cash. Stash, cash, sound is used as a consonant. All right. The next one, it was zigzag. G. The sound G. Zigzag. G. You can see at the end, consonants or internal alliteration. Then the last example says, I have 11 silver knives. The sound all right, in the middle of the 1, 2, 3, 4 successive words. So these exemplify the use of consonants. Don't forget we said alliteration usually at the beginning of the words, while consonants usually in the middle or at the end of the words. And we said also that if we don't want to refer to it as consonants, we can also call it internal alliteration. All right. And the last one talks about assonance. Now, this has to do with vowel sounds. So, in the case of assonance, we refer to a figure of sound in which the same vowel sound is repeatedly used at the beginning or in the middle or at the end of two or more successive words in the line of a poem. So assonance implies that it could be anywhere, whether beginning, whether middle or end. It could be anywhere, provided there is a repetitive use of the same vowel sound in those words. Then you have assonance. So let's see examples we have there. We can have chips and dips. Chips and dips. E, chips and dips. This is assonance. The next one, do good, have good. The oo sound. Do good, have good. As you can see, underlined. That is also an example of assonance. Therefore, these two exemplify the use of assonance. In conclusion, when we talk about the repetitive use of consonant sounds, we talk about alliteration and consonants. When we talk about the repetitive use of vowel sound, we talk about assonance. Again, alliteration is usually at the beginning of the words, while consonance is usually in the middle or at the end of the words. And we said also that we can also refer to consonants as internal alliteration, while assonance could be at the beginning or in the middle or at the end of the words. On this note, we round it off here. As usual, I'll put some drills on the board, solve them, and when I come back after the timeout, we'll do justice to them. Thank you. Let's solve the questions on the board. The first one says, Papa Peter planted plantain in a plantation. The above exemplifies dash. Now, what do we have? We have consonant sound, the sound P, all right, at the beginning of each word in this line. Therefore, we have alliteration. The next one, that was a hustle-bustle situation. All right, hustle-bustle situation, this vowel. So we have it as what? Assonance. Obviously. The next one, consonants may also be called dash. Obviously, it can also be called internal alliteration. And that's option C. Number 4, in assonance, vowel sound can be repeated at any position of a word. True. Yes, I was emphatic when I said that in the case of vowel sound for assonance, it can appear at any position of the word, maybe the beginning, in the middle, or at the end. Wherever it appears is fine. That is for assonance. Okay. Number 5, we live in the same home. We live in the same home. Now we have the nasal cavity consonant sound repeatedly used in the middle of the word. Or you can even say the end, because that's the last sound you have. So at the end, last sound, the end. So what do you have there? The above expresses dash, speech sound, sound speech, assonance, consonance. Consonance. Same consonant sound at the end of the words. So with respect to this, we have come to the end of the lesson on alliteration, assonance, and consonance. So we'll meet again and we'll treat other interesting topics in literature in English. Until then, keep succeeding. Thank you.
Welcome to Government at Your Study Part. In today's class, we'll be looking at the topic pressure group, the meaning of pressure group. We'll also be looking at the functions of pressure groups. Then we also look at types of the pressure groups that we have. Then we also be looking at how we can describe the techniques used by pressure groups to achieve their objectives. And the last subtopic there is we're going to look at the dangers posed by activities of pressure group. As you join the class, it's promising to be interesting and fun. Thank you. Good day. Welcome to another government class. Today, we're having a topic which is pressure groups on the board. In today's class, we'll be looking at the meaning of pressure groups. We'll be looking at the types of pressure groups that we have. And we also look at functions of the pressure groups in a democratic society. Then we'll be evaluating ourselves on questions that pertains pressure groups. So, before we continue, I would like you to understand that pressure groups are also known as interest group, okay? Now, why they are called interest group is this. Because they are aimed towards protecting the interests of their members. Also, to influence government decisions to their own favor. So that is why they are called interest groups, okay? So they're otherwise known as what? Interest groups. Okay, if you don't want to call it pressure group, you can call it what? Interest group, okay? So our first subtopic under this topic is the meaning of pressure group, okay? Like I mentioned the other time, said pressure group is also known as what? Interest group, okay? Literary meaning. If you ask to define pressure group, you can just define this way, that pressure groups can be defined as organized group. That word organized is very, very important because it's structured, okay? Pressure group can be defined as what? Organized group that is aimed towards influencing government decisions. Aimed towards what? Influencing government decisions. And also protecting the interests of their members. With this, you have literally defined what? Pressure groups, okay? This on the board is a comprehensive definition and precise definition of pressure groups. We have it defined as pressure group can be defined as an organized groups which influence government decisions economically or socially without necessarily entering into election activities to control the government. Okay? Now look at the second way you can define pressure group. Pressure group can also be defined as an organized groups which is aimed towards protecting the interests of their members and also primarily involved in influencing government decisions. So any of these two ways you are correct in defining pressure groups, okay? The next we want to look at is the types of pressure groups that we have. So I'm going to list the types on the board and we'll take it one after the other, okay? Okay, these are the 7 important types of pressure group that we have, okay? So on the board, we have economic pressure group, professional, educational, Nigerian Labour Congress, promotional, social, and religion pressure group, okay? Now we'll look at it one after the other, okay, by using their examples to explain, okay, their aim towards protecting the interests of their members and influencing government decisions, okay. Now, if you look at the first one, economic pressure group. That is what? The first one, okay? Now, this economic pressure group, a major example, okay, of this pressure group, or examples of this pressure group, we have chambers of commerce, okay? We have cocoa farmers union. We have cotton producers union. Now, this one major attribute of these economic pressure groups is that is the pressure group for all producers. Pressure groups for all producers, manufacturers of certain goods or commodities. Pressure groups for what? Manufacturers or producers of certain goods or commodities. Let me just write it there for your understanding, okay? Now look at this first one, which is what? Economic pressure group, okay? A brief explanation on this is that producers or manufacturers of certain goods or commodities belong to this pressure group with the aim of mounting pressure on government policies to their members' interests, okay? So why mounting pressure on what? Government policies? They want it to their own what? Favor, to protect their own what? Interest, okay? That is what we have as what? Economic pressure group, okay? I've given us the major examples here. From past question, you can see something like this. So you should know that it's what? Economic pressure group. Cocoa Farmers Union, Cotton Producers Union, okay? These are the major powerful examples of economic pressure group, okay? Now we'll take the next one, which is professional pressure group, okay? Now, this interest group, okay, we have all professional bodies belong to this what? Pressure group. Just like producers, manufacturers belongs to economic pressure group, so this also all professional bodies belongs to what? This pressure group, okay? Professional body in the sense that, like, for example, medical now, okay? The medical line, we have NMA. Now, what's the full meaning of what? NMA. That is Nigerian Medical Association. You can see the word medical. So the medical as what? A professional body belongs to this word? Professional pressure group. Okay? We have another one, journalist. Okay? Journalist also belongs to what? Okay, we can describe journalism under what? Professional what? Body. We have Nigerian Union of what? Journalists. Okay? We have also in law, okay? We have Nigerian Bar Association and some other words, powerful words, examples. So let me just give you a brief analysis of what this pressure group is all about. So 3 examples mentioned here. We have Nigerian Medical Association, NMA, Nigerian Union of Teachers, NUT. We have Nigerian Bar Association, that is NBA, Nigerian Union of what? Journalists, that is what? NUJ, okay? These are few examples of professional pressure group, okay? from the explanation, I mentioned that this pressure group comprises of professional bodies, okay? We can see it in the relation of medical, this one, teaching, that is education, this one, law, while this one in what? Journalism, okay? So it comprises of what? Professional bodies. The next one we're going to look at is number 3. Now, the way these professional bodies achieve their aim, sometimes they use this popular technique to achieve their objective. One of the techniques is what? Demonstrations and going on strike. Demonstrations and what? Going on strike. So with this, and they are very important towards our sector in the country. So going on strike will affect majority of the world's citizen. So government, at the end of the day, will actually attend to their needs. Okay, so this is how they go. This is how they pressurize government. One, going on strike and demonstrations. Okay, now the next one, which is educational pressure group. This educational pressure groups, okay, we have it comprises of lecturers of higher institutions of learning. We have lecturers of higher institutions of what? Learning. Colleges of education, okay, teaching and non-teaching academic staff. Falls under what? Educational pressure groups, okay? They also use techniques like strike, okay, lobbying, okay, to achieve their major what? Objective, to protect the interests of their members. Now, there's a popular one for the universities, okay? We have a major example, ASU. Now, what's the meaning of this ASU? We have it as Academic Staff Union of Universities, okay? Academic Staff Union of what? Universities. That this is one powerful what? Example of this educational pressure group. It comprises of union of lecturers of higher institution of what? Learning. Mount pressure on government to achieve their major aims and objectives for the development of their members' interests, okay? So this pressure group comprises of lecturers of higher institution of learning, like universities, polytechnic, colleges, and so on, okay? Now, what is their strike action? Their strike action is refusal to work. They refuse to work, to attend lectures, to teach students, okay? So with that, just like a way of telling government to dance to their tune. And at the end of the day, you see them also going for demonstrations with a lot of what? Consultations and dialogue with their representative, with government representatives, so as to achieve common what? Understanding, okay? So that is what educational pressure group is all about. Comprises of lecturers of higher institution of learning, like universities, polytechnic, colleges, and so on, okay? And the major example here is what? Academic Staff Union of Universities, okay? We have other examples, but this one is just the major ones, okay? Number 4, that is NLC. Now, this NLC is the parent body of all trade unions. Again, NLC is what? The parent body of all trade unions. Now, trade unions, that is workers under what? Governmental parastatals. So NLC fight for the world, the interests of all what? Labors. Working for the what? Government. There's representative of NLC at what? At state level, okay? Representative of what? NLC at what? At state level, okay? So that is the aim of what? Nigerian Labour Congress, okay? Now, the next one is what? Number 5, which is what? Promotional interest group. That is number 5. Now, this type of pressure group, as the name implies, promotional interest group, okay? This is the pressure group that is aimed towards assisting or rendering surplus services to the less privileged. The pressure group that is aimed towards rendering surplus services to the less privileged. Now, their major goal is to what? To provide welfare, basic welfare to the need of the public. So that is what promotional interest group is all about. We see sometimes, you see some criminals, okay, or some suspects that are not yet what pronounced under the law as criminal, because they are less privileged. They don't have money to get what? A qualified and competent what? Lawyer. Okay, so you see NBA, Nigeria Bar Association. So we have the NGOs among them. Now their aim is to what? Assist people like that. People that are referred to as what? Less privileged. And give them what? A helping what? And that's what promotional interest group is what? All about. Okay? Example is Nigerian Bar Association, NBA. Okay, so that is what promotional interest group is all about. Now, this pressure group, this type of pressure group that's aimed towards rendering social services to the public, okay? We can see examples of this social pressure group as the Boy Scouts organization, Girls Guide, Man O War, Boys Brigade, and some other words examples, okay? They also render selfless world service, okay, and fights for the interest of their world members to be what? Recognized by the country or by the government of the country, okay? So they provide what? Social services. Sometimes you see them on the road controlling what? Traffic. Sometimes you see them in some important functions, governmental what? Functions. You see the Red Cross assisting people that are what? Weak, okay? Or another word, strong. Red Cross organization. We see Rotary Club giving out welfare care to what? To the less what? Privilege, okay? So we have them like that, okay? These are a few examples of what? Social pressure group, okay? Now, number 7, which is the last one. Now, a major example of this, we have CAN and we have what? MAN. What is CAN? Christian Association of what? Nigeria. And we have MAN, Muslim Association of what? Nigeria, okay? Now, these are just the types of pressure groups that we have. We've looked at the first one, which is what? Economic pressure group. We cited examples given chambers of what? Commerce, Cocoa Farmers Union, Cotton Producers Union, okay? We look at professional pressure group. We also cited example We talk about the NMA, Nigerian Medical Association. We'll mention a few examples like NUT, Nigerian Union of Teachers, and the likes like that, okay? Then we look at another powerful one, which is what? Educational pressure group, okay? We cited ASU as a major word example. We look at promotional interest group, talking about Nigerian Labour Congress as the parent body of all trade unions in the country, okay? We also look at the social and what? Religious pressure group as the last types of what? Pressure group. The next subtopic under this topic will be functions of pressure groups. So far we have been able to look at the meaning of pressure group, types of pressure group. So the next subtopic on the board will be what? The functions of pressure group. Now, two of these functions, we are in the examination hall, we have to list functions of what? Pressure groups, okay? Two of these functions, we have it in your definition. Two of these functions, we have it what? In your definition. The first one is that protecting what? The interest of what? Members. Can you see as simple as that? Protecting the interest of what? Members. That's the first one, okay? The second function that you have in your definition is this, okay? Influence government's decisions. They influence government decisions. So without stress, you can just what? Just get two from your definition as functions of what? Pressure groups, okay? So let me just write the two on the board. Then I'll give you other what? Functions, okay? The first one, like I mentioned, they protect the interest of their members, okay? The second one from that definition, which is what? Number two, is that what? They influence government decisions. So you can see as simple as that. So number three now, we can now relate it as they serve or they act as a link between the people and the government. They act as what? A link between the people and the government, okay? Now, a powerful example of this, okay? We can see this as what? NLC. Look at the NLC. I said it's the what? Parent body of all world trade unions. Parent body of all world trade unions, okay? The goal of what? NLC is what? Serve or act as what? A major link between the people and the government. As simple as that, okay? Now, that is another what? Important function of what? Pressure group. They act as a watchdog, like they monitor, okay, to checkmate all the activities of what? Government, to see if it's in the best interest of the world citizen. They checkmate the activities of what? Government, public policies, to see if it's the what? In the direct what? Interest of the world citizen, okay? And the next one, which is what? Number what? Number 5, okay? Sometimes they also what? Help governments. They help governments in formulation and what? Implementation of what? Policies. Now, I'll give you one of the examples of where they help government doing that. One of the techniques used by pressure groups to achieve their objective is what? Consultation. So, leaders of these pressure groups, sometimes government consults them and get what? Positive what? Feedback from them. And this positive feedback will be in return used to form what? Government what? Policies. So you can see, indirectly or directly, they've assisted the government in what? Implementation and what? Formulation of what? Policies. Now, these 5 functions on the board are the major what? Functions of what's the role played by what? Pressure groups in a democratic society. The first one on the board they protect the interest of their what? Their members. Second one on the board, they influence government decisions, okay? Third one, they serve or act as a major link between the people and the government. I gave us a powerful example of that pressure group to be what? Nigeria Labour Congress. Number 4, they act as a watchdog in checking the public policies over the rights of the citizen. Okay, to tell you that they are interested to ensure that what? Governments are doing things that will be in favor of the citizen. Okay. Number 5, which is the last one, they play a vital role in formulating and implementing government policies. You can say through consultation. Okay, very important. Okay, through what? Consultation. Through what? Consultation. These are the major functions. And the last subtopic under this topic, which is what? Pressure groups, will be techniques used by pressure groups to achieve their objectives. Techniques used by pressure groups to achieve their objectives, okay? They're like the mode of operations. The mode of what? Operations of pressure groups, okay? To get their objectives satisfied, okay? Number 1, okay, I'm just going to list all the what? Techniques used by what? Pressure groups. Okay, I have it up to like 5, okay? If not 6. We have mass media, okay? The use of what? Mass media, okay? Number 2, strike actions. Strike actions. Number 3, lobbying. Lobbying. Number 4, dialogue. Dialogue. Number 5, demonstrations. Demonstrations. And the last one, 6, consultation. Class, this is just what? The major what? Techniques employed by pressure groups to achieve their what? Objectives, okay? Now, past Jamb and wire question, they asked this question. They said the major pressure groups and political what? Parties differs in, they gave us a lot of what? Options. Pressure groups and political parties differs in. Now the right answer is what? Objective. The right answer there is what? Objective. Why is objective the right answer? Okay. Now the objective is that the aim of the two topics is not the same. Now the aim of pressure groups is what? Influence government decision, while the objective of political party is to control the government. You can see they differ in what? Their objective. The objective of pressure groups is what? Influence government decision, while the objective of political party is to what? Control the government. So that is why objective is the what? Right answer. Okay. Now let's go back to the last subtopic, which is what? Techniques used or employed by pressure groups to achieve their objectives. Okay. Now number 1 is what? Mass media. Now mass media play a vital what? Roles through the use of what? Our television, radio, newspapers, and the likes. Okay. Pressure groups use that as what? Agent of what? Instruments. Okay. To press home their demand known to the what? Government. Like I see some of their demonstrations, you see them videoing it so that governments can what? Can see it and know what they want. Okay. So those are ways they what? This is what a major what? Technique through the use of what? Mass media. Sometimes their representative, talking about the chairman or the president of that NLC, can go to what? Interviews on radio station, television station, to talk on behalf of what? Other what? Members. On what is affecting them in what? In general. Okay. The other one is what? Strike action. Now, strike action in the sense that workers will what? Refuse to what? Work. They will what? Boycott their what? Their duties. They will not want to what? Work. Okay, that is what a signal to tell the government that we want our requests to be what? Attended to. Okay. Now, the next one is what? Lobbying. Lobbying is one of the features of a democratic world society. You see representatives of what? Pressure groups trying to what? Gain attention in the parliament, so that lawmakers can what? Include their objectives to what? Lawmaking process. Example of this is what? Issue of what? Minimum wage. Okay, there was a time in Nigeria whereby minimum wage was increased to what? 18,000 naira. After some time, through lobbying again, pressure groups also what? Push government, and also what? From 18,000 naira increase it to what? 30,000 naira as what? Minimum wage. You can see that is the process of what? Lobbying. Lobbying with who? The parliament, the legislature, so that it can be what? Part of what? The lawmaking process. Now, the next one is what? Dialogue. What do you call dialogue? Dialogue is just like what? A formal discussion. A formal what? Discussion with the representative of what? Government. Channeling what is bothering the pressure groups to the government. There is this popular saying that if dialogue fails, confrontation is what? Inevitable. So that means from dialogue, it can lead to what? Confrontation. If that dialogue, there's no what? What we call a mutual what? Understanding in the conversation. So like I mentioned, if dialogue what? Fails, confrontation is what? Inevitable. Now that confrontation is what? Is the what? Demonstrations. You see them protesting, okay? Telling government what is what? Bothering them, okay? That is what we call what? Demonstrations. Now from demonstrations, we go to what? The last aspect, which is what? Consultation. So after a series of events, activities, the government now what? Consult them. What do you really want? How are we going to what? Help you? So these are what? Techniques in which what? Pressure groups employ to achieve their what? Objectives. Now a recall of what we have for today's class. We've looked at the meaning of pressure groups. We've looked at the types and details of what? Pressure groups. I've looked at the functions of what? Pressure groups, and also concluded the class with the techniques used by pressure groups to achieve their objective. And don't forget, notes, very important. Pressure groups differ from political party in terms of what? Objectives. Let me just state it here. It's very important. Now don't forget, the objective of pressure group is to what? Influence government decision, while the objective of political party is to control the government. And we're going to have 5 questions on the board to evaluate us on this topic, pressure groups, okay? So when I come back, we take the corrections to the 5 objective questions from the past question. Okay, welcome back to class. On the board, we have 5 questions to examine and to evaluate us on the topic pressure groups. The first question on the board, pressure groups harmonize different individual concerns through, look at the first option, interest formulation, B, interest manipulation, C, interest mobilization, D, interest aggregation. The right answer is what? Interest aggregation, okay? Now, number 2, the major objectives of a pressure group is to A, influence policies of government, B, contest elections, C, control the machinery of government, D, provide political education. What's the answer? Influence policies of what? Government, okay? Number 3, promotional pressure groups usually cater for the interest of A, all workers, B, the general public, C, non-members, D, all professional bodies. The right answer here is what? The general public, okay? Number 4, pressure groups are also known as A, social clubs, B, cultural organization, C, interest groups, D, secular groups. Answer is what? Interest group, okay? And the last question on the board, we have one of the functions of pressure groups is to A, nominate the president, no. B, prepare the budget, no. C, articulate the opinion of their members. D, contest election to serve the people. So D is not correct. The right answer is what? C. So these are the 5 questions we have under pressure group. So see you in our next class. Thank you.
Now today we're going to talk about one part everybody used to be happy about to get happy about when they're about to tell you that what class is this? Is reproduction. Reproduction is reproduction. We're going to be talking about reproduction in flying plants. Under the reproduction in flying plants, that means we're going to talk about the part of flowers, you know, like the petals, the sepal, the androecium and the gynoecium, you know. So we're going to be talking about the sexual reproduction itself. So in reproduction, what we want to talk about is we're going to be talking about the sexual reproduction in flowering plant, sexual reproduction in man, sexual reproduction in unicellular whatnot organisms, okay? And then we'll talk about asexual reproduction, where we're talking about the budding, the fragmentation, the sporulation, the vegetative propagation. Those aspects that people really don't want to hear about that, but they're simple to understand, you know. And then, so that's why you need to not miss any aspect of this that class. And then we'll talk about that main one you want to hear about, which is the reproduction in man. It's good to know about yourself, about your reproductive whatnot system. You ready to see you in class, right? I'll see you in class then. Okay, good student. Now, welcome to study part. So today we're going to be looking at reproduction, just like I told you in the introductory class of this topic, reproduction. Now, reproduction is going to be in parts. There's a part for animals, there's a part for what? For plants. You know, the top in terms of plant is what we're going to be dealing today, and that's when you're going to talk about flowering plants. You understand? Back then, when I was telling you about classification of living things, remember I told you angiosperm? Angiosperm breaks down to give you monocotyledon and dicotyledon, remember? And then we told you those are not the plants that have what now? They're like, that's where we find most of the plants we have today, the flowering plants. So that's what we want to talk about today. So when you hear reproduction in plants, they're actually talking about flowers. Now I want you to look at this thing I wrote on the board here. I say flower down to pollination, pollination to fertilization, fertilization to formation of what? Seeds and fruits, all right? So now one thing is to get it, get the point, get what you need to know. Do we get? Now, one thing is this, you see, a flower will always have like a ring structure, all right? Like a ring structure. And that ring structure is what we call what? The WHORL, all right? It has 4 floral parts, and they call it a ring structure. It has a 4 floral part, okay, which is in a ring structure. And that ring structure is called what? Heart. 4 floral part, which is in the ring structure, we call it what? Heart. WHORL. Now, one thing is this. What is the four floral part? Very simple. We got the petals, we got the sepals, okay? We got the androecium, and the gynoecium. Do we get? We got the sepal, we got the petals, we got the androecium, and we got the gynoecium. Are we together now? You see, now one thing you need to get the dichotomy in this is that whenever a flower, I've told you times without number in class, that whenever you hear that this part is an outer part in biology, the job is actually going to do is to carry out what we known as what? Protection. Okay? So, now listen. The sepal job is very simple. The sepal is greenish in color, okay? So if it is greenish in color, it means it will carry out what? Photo-word sentences, okay? And then, because it is the outer layer of the heart, the major thing you must try to understand there is that it would have be doing what they call protection, all right? Now, one other thing is that all these things has what they call, like the petals now, you hear the name corolla, androecium can also be called stamen, okay? Why this guy is also called what now? Carpel. Why this guy is called calyx, all right? Calyx, corolla, stamen, carpel. Sometimes you see it, they call it, some even people call it pistil, all right? Pistil. So please, don't get confused when those names come. Just know the normal ones: sepal, petals, androecium, and what? Gynoecium. And so the petals will find the corolla like that, like that. Do we understand what I'm trying to say? So, in the main sense now, in the main sense is this: sepal, I've told you, what is the function? The same function it does is what? Protection, carry out for toward the sentences. Now, you say the petal is the conspicuous part of a flower. When I mean conspicuous, it means it's the beautiful part of that flower. Very, very, very beautiful plant, and that is what attract pollination. Okay? Now, pollination. Now, you will have heard about the word gamosepalous, and gematocephalous. Yeah, gamosepalous from the word gametophyte. Gamosepalous. Okay, gamosepalous. Same thing you have heard. Gamopetalous. All these things are just saying when the ovary is free in the sepal, or when it is what? Free in the word petals. I'm just have to say that, chip that in, but you don't have to put that in your mind. Just know what I need to tell you, that the petals carry out the function of what we call what? Now, pollination. Okay? Now, so when you talk about the sepal and the petal, then I didn't say anything about, remember we're talking about reproduction. I didn't even say anything about whether it's the reproductive part or none of that. That makes you to understand that in this flying plant, there are what they call essential parts, okay, and non-essential parts. So the non-essential part is what we discuss first: sepal and what? Petals. Now note, when the sepal resemble the petals, we call it what? Petaloid. When the sepal resemble the petals, it is called petaloids. 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 Okay? When the sepal resemble the petal, it's called what? Sepaloids. Petaloids, sorry. And then there was a point whereby the petals will be looking like the what? The sepal now. We call that perianth what now? Segment. Perianth segment. Again, when sepal resemble the petals, petaloids, perianth segment is when there is a resemblance of the petal like the what? The sepal. And then when they ask you the non-essential part, the answer is your sepal and your what? Your petals. Now, at that point, you now need to understand what I say. Let's now move to what they say, the essential part. When we say the essential part, these are the two essential parts. Why are they called the essential part?
because that's where we have the male and the what? And the female. The male is the what? Is the androecium. The female is the what? Is the gynoecium. So the male is where we find our anther, and inside the anther is where we find where you get your anther. Is also in the male you find your what? Your filament. Do you get? And then you also hear your what you know, that's where you get to talk about pulling what? Pulling greens. So in the male stamen we got filament, we got anther. Okay, while in the female we got your style, we got stigma, and we have pistil. Okay. Now let's talk about the part in humans. The last time we were talking about flying plants. Now let's go to the human part. I know, because I'm a male, I like to start with the male reproductive system. Ain't no gender issue there, but let's start with the male reproductive system. Let's try to get some nitty-gritty about this guy here. Now, look at something. In the male, one thing I need to know is that there's an external part, right? And there's a what? Internal part, okay? Now, one thing you must tend to understand is that you see this testis. You see the testis itself is your what? There are two, okay? Found in the scrotal what now? Sac. Do you understand? The testis is found in the what? In the scrotal what now? Sac. Now, this testis is what you use your mouth to call balls. Your two balls. That's what you use your mouth to cover. It's naturally called the testis, and it's located into the what? The scrotum sac. That's your scrotum. Now, what you see outside is the external part, and why, which is called the what? Now, the penis. All these are the internal part of it that you're just talking about. Okay, the penis. Now, what is the reason why the penis is located outside? Is due to the what? The regulation of what? Temperature. All right, due to the regulation of what? Temperature. That's why the penis is located what? Outside. For the regulation of temperature, your sperm count, your sperm production, which you know that it takes place where? Is it here? No. Now, there's what we call seminiferous what now? Tubules. Let me write that. Seminiferous what? Tubules, which is found inside this what now? The testis. Do we understand? And that's where we get the mass production of what? Of sperm. The mass production of what? Of sperm. The mass production of sperm is found in your seminiferous what now? Tubules. Okay? So when they ask why is the penis located outside, is so that it can regulate the body what now? The temperature of the what? Of the sperm. Not to regulate the body temperature. It's due to the what? Production of the what? Of the sperm. When there is high temperature, then the sperm cell would tend to what? To die. And that's why you've always been told to be not put your gadget on your laps, because if you put your gadget on your laps, then that means that you're increasing the temperature within your private region. And what will happen? Then you begin to have inadequate what now? Production of sperm, or you begin to have, people will say infertility may what now might occur, watery sperm. Do you get me? So that's why you're being told to not put hot gadget on your what? On your laps. And because that's why this thing called what now? The penis was located what now? Outside. Now, you know, the erector tissues is what is responsible for urge. Do you get it? That's what is responsible for urge or for arousal, just to make sure that the person becomes in the mood for sexual what? Intercourse. Now, in the testis, you must remember that that's where we find our hormones, and that's the testosterone hormones for the what? For the males. Are we together now? The testosterone for the what? For the males. Now, in that same sense, I've talked about the seminiferous tubules. I've talked about this penis. Now, we hear epididymis. Epididymis is just the temporary storage of what? Sperm. The lead gets what? Matured. Okay? It is the temporary storage of what now? Sperm. till it gets what now? Matured. So it's not a permanent place. Where sperm will go is in your seminal water, the seminal water vesicle. That's where it will go before ejaculation will occur. Do you understand what I'm saying? Yeah, before ejaculation will occur. So you must try to understand that epididymis is just a temporary storage, so that it's just that the sperm should get matured. Then they will not go store it in the vesicle till there's a point for ejaculation. Are we good now? Now, one thing I need you to get here again is this. This one is just a connection, a passage of your of your sperm. Can you see it? Can you see? Look at it. This is the testes. It's a passage of the of the sperm. Do we get it now? Now, passage, so that they can go take it back. Do you get what I'm saying now? See the passage. Look at it. It passes. It's obvious. You can see the passage to the seminal vesicle. Are we together now? Now, one thing I need you to get here is this. This thing called prostate gland. Now, before I go on, if you are asked that, what is the name of the sugar found in the sperm? The answer is called fructose. Yeah, it's called what now? Fructose. That's the name of the sugar found in in the sperm. Don't think anything. And that is what gives the sperm energy to be able to swim. Do you understand? That's what gives the sperm energy to be able to swim. And remember, it is the penis that links to to the vagina, and that's where it will pass the sperm into the vagina of the lady. Do we get it now? So obviously, I'm going to put a summary of what I've said now on the board, just for you to get the picture. But now that I've said one last thing, I said something. I said that the penis is the one that transfers the now. After ejaculation, the whole sperm will go into where? The vagina. And now at that point, we now start the female part. And what I need you to just know under this female is very simple. You see all these things I'm writing, the perimeterium, the meioterium, all these are all found within your your uterus. Do you get? Found within your your uterus. So basically, the epithelium is the outside wall of your vagina. Do you get? So now when ejaculation comes in here, you must try to understand that the vagina is acidic. So not all sperm cells get to enter to fertilize the egg in the in the oval. Do you understand? I just had to link. I had to link the two together for you so that you can get a point. It's just going to be summary. Now, so when it gets there, I need to understand something. Look at it. I said two ovaries on each side of the uterus. It's two. Where female hormones are, which is the estrogen and the progesterone. And that is where they do their ovulation. Fallopian tube is not where your menstruation occurs. The job of the fallopian tube is just to ensure that there is a connection between the ovary to the uterus. Very simple. They allow eggs to travel. That's it. Now, this is where menstruation will take place. Now, you see, when sperm gets in and the egg becomes fertilized, do you understand? And when the egg becomes fertilized, a zygote is formed. And that zygote is formed, that means an embryo. We have an embryo. And that embryo, when it is placed into the uterus, then a fetus is formed. That one is what we call pregnancy. Pregnancy. But the point whereby an embryo is not formed here, do you get? Egg is not fertilized. Then what that is what they call menstruation. And its takes place within the uterus. Okay? It takes place here in the uterus. Do we get now? So if we get it to this point, and an embryo is placed, pregnancy will be formed in the womb. Womb is also the same thing as what? Uterus. Birth, if the egg is not what now fertilized, then in the next 28 days, that egg that is being formed there will have to lead in form of blood clot. And since it have to lead in form of blood clot, then what is happening is what? Menstruation. You understand? That's the two different. Pregnancy, uterus. Menstruation is also uterus. Are we good? Now, move on. And I say cervix. Lower part of the uterus that connect the uterus to the vagina. Yeah. And that's where you find your cervical canal. And then the vagina connects the cervix to the outside part of the body, obviously. And it's the outside part of your body, they tend to have what they call clitoris. Do you understand? And that's where their own arousal tissue come from, the clitoris. That's where their own arousal tissue would come from, clitoris. Do you get? That's where their own arousal tissues come from. It's called the clitoris. So, in the real sense, we just need to understand a little bit that it's not as if the two system works hand in what? In hand. Are we together? And I must tell you, everything a woman need and everything a man need for sexual reproduction or for intercourse to occur can be produced by the what? By the body. There was no means for external what? Now head, you know. So my point is, the two works hand in what? Hand in hand. Do you understand now? They work hand in hand. I'm going to show you some certain things now from the male side and then in the female side, so that we can juxtapose between the what? The two. Now here, so if you would juxtapose between them, like if you do a difference between them, you will understand that and hormones, they would have different hormones. The external part are different, you know. And then you know the external part in the female is what you see is the vagina part. While for male, you obviously the external part is the penis, you know. You get, but there are also some other external parts, which is the testis, you know. You get to see that. Then the internal part is where the differences come. Then I told you something. I said, you see, everything you damn need for that sexual intercourse to occur is already provided. Like I said before, I said the prostate gland, majorly they will secrete some fluid for you to lubricate the walls. Therefore, lubrication. You also have the Cowper gland too, that helps you to minimize. It produces all those pH to help you minimize the when the sperm is going to the vagina. Do you understand? So everything you gams to need is already available. Do you get me? So the point is, these two guys must work hand in hand. That's the whole summary. They must have to work hand in hand in hand. Are we together now? Good job. So whatever question they want to ask you on all this is just for you to understand, okay, where does menstruation take place? Uterus. Well, all this prematorium, myotherm, I've told you, they're all part of the walls of the uterus. Do we understand? So that is the basic need or the basic summary of this part in female, part in males. Do we get? And the question they can ask you here is what I've said: the ovary, the hormones, the external part, temporary storage of the sperm for male epididymis. Where's the place it will be stored before the ejaculation? Now, you know ejaculation will only occur when there is a sexual intercourse or sexual arousal. Do you understand? So it is going to be in the seminal the vesicle, where it's a matured sperm is what you see there. In the epididymis, it's going to be temporarily stored so that it can get matured. We get. So that's it. And that's it. Let's get a little bit of some short drills on it. Okay, so let's see what you've done. Just like a little bit. There are more questions on this, but you see a lot of other questions on it. But these are just small questions. And everything I've said in that class is very momentous, which you also get. Now look at this. See, that's just the temporary storage of sperm in males. They didn't tell you that where is the matured sperm before ejaculation. They didn't tell you that. They only said the temporary storage of sperm before. The temporary storage of what? Of sperm. So let's stop there. So invariably, remember I said the epididymis is the temporary storage of sperm. Why? Here, so that it could get what? Matured. This is where they store it. And then the seminiferous tuberous is where there is mass production of what? Or that's where it does the production of what? Of sperm. Now, why is the penis located outside the body of a male? I've told you it's because of the word temperature. When you have high temperature, what happens? High temperature kills the what? Kills the sperm cell. So the reason why the penis is located outside the body of a what? Of a male gender is because of what? The temperature. So the body can be able to regulate the what now? The temperature. And it's because the production of what? Sperm does not require high what? Heat. Are we together now? Good. Now, let's say the hormone found in females is called what? This is very simple. You have estrogen and progesterone. The 28 days I told you is going to take place in the what? Uterus. So you could still take your time to still go look for more other ways, more questions to solve, and then to beat it. And then more of the informations are being embedded in the note again. Do you understand? This is just the data summary of all this, and I've also embedded all you need into your word. It's up note. I'll see you here in the next class. Bye.
Hello guys, welcome to your chemistry study part. In today's session, we'll be considering oxides of carbon. The chemistry of oxide of carbon is an interesting one. One occurs naturally and the other does not. One supports combustion and the other does not. One is consumable and the other is not. Join me in class, let's consider oxides of carbon. Let's consider the preparation, their uses, their general properties, physical and chemical properties, oxides of carbon in nature and everyday life, as well as greenhouse effects. See you in class. Good day, class. Today we'll be talking about oxides of carbon. Oxides of carbon. Oxide is a compound that contains two elements. Oxide is a compound that contains two elements, one of which would be oxygen because it's an oxide. And so today we'll be considering oxide of carbon. That means oxide of carbon will contain two elements, oxygen and carbon. Oxygen and carbon. Generally, when carbon are heated in the presence of air or oxygen, they form two oxides. We have carbon monoxide and carbon dioxide. So those are the two types of oxides of carbon. Carbon monoxide, carbon monoxide, and carbon dioxide. This is denoted as CO, carbon and oxygen. This is denoted as CO2, carbon and oxygen. So the difference between carbon monoxide and carbon dioxide is the availability of oxygen. This has 2 and this has 1. And so that's the major difference between carbon monoxide and carbon dioxide. Naturally, they can be found in several places. So let's examine some of the places you can get carbon dioxide and carbon monoxide. For carbon monoxide, exhausts from vehicles emit carbon monoxide. Volcanoes also emit carbon monoxide. Clothes dryers definitely emit carbon monoxide, and also water heaters emit carbon monoxide. Bushfires also emit carbon monoxide. Whereas carbon dioxide, you have your fire extinguishers, they contain carbon dioxide because carbon dioxide do not support combustion. So it's used in what? Fire extinguishers. Your carbonated drinks contain carbon dioxide. Deforestation, when the activity of burning of bush occurs, the gas that comes out, the smoke that comes out contain CO2, which is carbon dioxide. And also respiration, when we take in things and we breathe out carbon dioxide and we breathe in oxygen. So that way, as we breathe out, that means we exhale, we release carbon dioxide into the environment. Now we'll be considering the properties of carbon dioxide, carbon monoxide, their uses, and their tests. So we'll begin with carbon dioxide. Okay, so solid CO2. We now know that carbon dioxide can be called CO2. CO2. While carbon monoxide can be called CO. So during the class, I'll be using CO2 and CO. You know that carbon monoxide is CO and carbon dioxide is CO2. The first property of carbon dioxide, which is CO2, solid CO2 are also called dry ice. Dry ice. It is a colorless and odorless gas. Carbon dioxide is a colorless and odorless gas and slightly soluble in water. It's denser than air and is weakly acidic. If we react with water to form trioxocarbonate 4, the equation of reaction is CO2 plus H2O to give H2CO3, and this is trioxocarbonate 4. CO2 also reacts with alkalis to yield trioxocarbonate 4, and the equation of reaction is Na2CO3 plus CO2 plus water. And so when CO2 reacts with sodium, when CO2 reacts with sodium hydroxide, you get sodium trioxocarbonate 4, CO2 and H2. So these are the basic properties of CO2 gas. Now let's move on to the preparation of carbon dioxide. 1. Reaction of dilute acid and trioxocarbonate 4. Dilute acid here would be your hydrochloric acid, trioxocarbonate 4 here will be your calcium carbonate. And so you would get from here calcium chloride plus CO2 plus water. And so your CO2 gas can be gotten from this solution. You can extract your pure CO2 from this solution. And Gibbs apparatus is used to get the pure CO2 gas. Another way to prepare carbon dioxide is what? The combustion of hydrocarbons, the complete combustion of hydrocarbons. That means your methane will react with oxygen to give CO2 and water. And so to balance this reaction, 1, 1, 4, 4, 4, 4. And so this is a balanced reaction for the complete combustion of hydrocarbon. And we also have the alcoholic fermentation of glucose, where your glucose will be fermented to give an alcohol and CO2 gas. So these are the basic preparation of CO2 gas. Now let's consider the uses of CO2 gas. 1 is used as fire extinguisher because it does not support combustion. 2, it is used in the manufacture of soda drink because it gives soda drinks this refreshing taste. Dry ice is used as a cooling agent. I made mention that solid CO2 gas is called dry ice and it is used as a cooling agent. Let's move on to test for CO2 gas. When you bubble an unknown gas through a solution of lime water is calcium hydroxide. When you bubble an unknown gas through a solution of lime water and you notice that the solution turns milky, that means that unknown gas is CO2 gas because CO2 reacts with calcium hydroxide, which is lime water, to give calcium carbonate, and this indicates that milky color. This indicates that milky color. This is the equation of reaction. So when you bubble an unknown gas through a solution of lime water and it turns milky, that means that gas you bubbled through lime water is actually CO2 gas. Now let's move on to the next oxide of carbon, which is called carbon monoxide, which is represented as CO. The properties of carbon monoxide: number one, it is poisonous. It is an odorless and colorless gas. It is insoluble in water and it is less dense than air. For carbon dioxide is what? Is slightly soluble in water and is denser than air. But carbon monoxide is insoluble in water and it is less dense than air. It's neutral to litmus. It is neutral to litmus. 4. It is a strong reducing agent. Carbon monoxide is a strong reducing agent. Let's consider this equation of reaction. This is lead oxide plus CO. Since CO is a reducing agent, that means it will reduce this compound to lead. It will reduce this lead oxide to lead and itself would be oxidized. So the CO is then being oxidized to CO2. So this equation of reaction proves that CO is a strong reducing agent. Now let's move on to the preparation of carbon monoxide. 1. By passing CO2 through red hot carbon. I made mention that the difference between CO and CO2 is the availability of oxygen. So when CO2 is passed through red hot carbon, that means you introduce additional carbon. Definitely, the CO2 would then be converted to CO because the proportion oxygen and carbon would then reduce, and so your CO2 plus carbon would give you CO. 2. The dehydration of methanoic acid, which is called formic acid, or ethanoic acid, which is called oxalic acid, using concentrated tetraoxosulfate 6 acid would give CO. Let's consider this equation. This is methanoic acid, this is methanoic acid, which is called formic acid. Dehydrating using H2SO4 will give you CO, whereas that of ethanoic acid, which is oxalic acid, dehydrating using concentrated H2SO4 will give you CO2 and CO, and you can actually get your pure CO from this solution. In preparation of carbon monoxide, there's usually a caution in which that when you want to prepare carbon monoxide, you always prepare it in a fume cupboard, and this is because carbon monoxide is a poisonous gas. Now let's talk about uses of carbon monoxide. 1. Used in the extraction of metals from their ores. 2. It is an important constituent of gaseous fuel. That's your producer gas and your water gas. Now let's consider the test for carbon monoxide. When a lighted spleen is inserted into a test tube containing an unknown gas and some lime water is added to it and shaken, if that gas burns with pale blue color and turns lime water milky, that means that unknown gas is carbon monoxide because it burns with pale blue flame. Now let's talk about greenhouse effect. Greenhouse effect. I'm sure you're familiar with the term greenhouse effect. It's basically the process through which it is trapped near Earth's surface by substances known as greenhouse gases. Some of these gases are abundant in the surface and they are called greenhouse gases. They include methane, CO2, water, N2O. These gases are on the Earth's surface. They trap infrared radiation from the sun and then they re-emit it to the Earth's surface. They trap infrared radiation in form of heat from the sun and they re-emit it, and this process is called greenhouse effect. And what it basically helps the planet Earth is what? Is that it regulates the temperature for life. It regulates the temperature for life. Without greenhouse effect, the average temperature would read around -18 degrees Celsius. But because these gases absorb infrared radiation from the sun and then they re-emit it to the lower Earth's surface, it helps to regulate the temperature, and the average temperature is around 15 degrees Celsius, and which is suitable for life, where living organisms can strive in it, both animals and plants. Moving on. Now let's consider processes that releases carbon monoxide into the atmosphere. You have volcanic eruption, bushfires, incomplete combustion, and motor exhaust. These are basic ones, and there are several processes by which carbon monoxide is being released into the atmosphere. Generally, processes that remove carbon monoxide from the environment is that carbon monoxide will be oxidized to carbon dioxide, and then it will be removed from the environment as carbon dioxide, and we'll consider that in a minute. Before then, let's consider processes that release carbon dioxide into the environment, and then we'll consider processes that remove carbon dioxide from the environment. Processes that release carbon dioxide, we have respiration. Human beings exhale CO2 gas. We have combustion, we have decomposition. Organisms, when they die, they get decomposed by bacteria, and during this process, CO2 gas is released. There is also fermentation of sugar. This process releases carbon dioxide. Now let's consider processes that remove carbon dioxide from the environment. The first one would be photosynthesis by plants. Plants taking CO2 gas. So during photosynthesis, plants make use of these CO2 gas. Also absorption by oceans. Organisms that live in the ocean, that's aquatic organisms, some of them use CO2 for their shell and for their skin. And we also have ocean fertilization. This is a deliberate process to removing CO2 gas from the water body. And there's also dissolve in rainwater. It dissolves in rainwater and then it will flow into the water bodies. And so these are the processes of release and removal of carbon dioxide from and into the atmosphere. Now let's go on to dangers of inhaling oxide of carbon. We have two oxides. We have carbon monoxide, carbon dioxide. The dangers are more pronounced for carbon monoxide because carbon monoxide is a poisonous gas. And some of the dangers of inhaling the oxide of carbon are headache, dizziness, weakness, vomit, rapid heartbeat, shortness of breath, chest pain, elevated blood pressure, convulsion, and ultimately death by suffocation. And with this, we'll come to the end of today's class. I'm sure you enjoyed today's class. We talked basically about oxide of carbon, the two oxides, the carbon monoxide and the carbon dioxide, their preparation, their uses, their tests, their properties. We moved on to talking about greenhouse effect, and I also made mention of processes that releases carbon monoxide, processes that releases and remove carbon dioxide, and we concluded with it dangers of inhaling oxide of carbon. Now let's take drill questions to evaluate what we've learned. I'm sure you've attempted the drill questions. Now let's take the solution together. Question number 1. Which of the following statements is not true of carbon monoxide? A. Carbon monoxide is insoluble in water. B. Carbon monoxide is readily oxidized by air to form carbon dioxide. C. Carbon monoxide turns blue litmus red. D. Carbon monoxide is a good reducing agent. Option A. Carbon monoxide is insoluble in water. Yes, it's one of the difference. Carbon dioxide is slightly soluble. Carbon monoxide is insoluble. Option D. Carbon monoxide is a good reducing agent. Yes, it works as a reducing agent whereby it is itself oxidized. B, it is readily oxidized by air to form CO2 gas. True. C, carbon monoxide turns blue litmus red. It doesn't. In the real sense, carbon monoxide is neutral to litmus. So for question number 1, option C is the correct option. Now let's move on to question number 2. Dash is a poisonous gas. A, carbon monoxide. B, carbon dioxide. One of the caution in preparing carbon monoxide is that you prepare carbon monoxide in a fume cupboard because it is a poisonous gas. So option A is the correct answer because it is a poisonous gas. That's why it is prepared in a fume cupboard. A. Question number 3. Dry ice is A, solid carbon monoxide. B, solid carbon dioxide. C, gaseous carbon dioxide. D, gaseous carbon monoxide. Solid carbon dioxide can also be called dry ice. So the correct answer is option B. Now let's move on to question number 4. Dash does not support combustion. A, carbon monoxide. B, carbon dioxide. Carbon dioxide does not support combustion. That is why it is present in fire extinguisher. So the correct answer to question number 4 is option B. Now let's move on to question 5. Which of the following is not a greenhouse gas? A, CO2. B, CH4. C, H2O. D, H2SO4. CO2 is a greenhouse gas. Methane is a... Option B is a greenhouse gas. Methane. C, water vapor is a greenhouse gas. But option D, H2SO4, that's sulfuric acid. It is not a greenhouse gas because it's not present on the Earth's surface. So the correct answer to question number 5 is option D. Now we've come to the final end of today's class. I'm sure you gained a lot from today's class. Thank you for watching. I'll see you in the next class.
Welcome to your physics study part. Today we get to look at the concluding part of simple harmonic motion, where we get to study and understand energy stored in a simple harmonic motion. Further, we get to understand forced vibration, as well as understanding the concept behind resonance. See you in class. We'll be looking at energy of a simple harmonic motion. First, we consider the simple pendulum. Imagine a simple pendulum attached to a fixed point here. It is expected that the swinging effect of this pendulum will be such that the potential energy here, mgh, is maximum. We have the kinetic energy equal to 0. At this point, the kinetic energy, half mv square, is maximum, while the potential energy here is equal to 0. Similarly, potential energy here is equal to mgh, with the kinetic energy here being equal to 0. Having said this, it is stipulated that the total energy stored under a simple pendulum can be expressed by saying the total energy is equal to the kinetic energy plus the potential energy. Remember, kinetic energy is half mv square and the potential energy is mgh. But you must understand that we can always determine the maximum height attained and the maximum speed or velocity of the simple pendulum. And we can do this by saying that what? The potential energy here being equal to the kinetic energy will translate to mgh maximum
being equal to half mv maximum. As such, with this, m will cancel out m, bringing across the value of the 2, you are going to have cross multiplying v square, v max square will be equal to 2g h max. As such, the maximum velocity of a simple pendulum can be obtained by using the square root of 2g times the maximum height. Having this been said, it's now easy to say that the total energy can be gotten, total energy in a simple pendulum would usually be equal to half mv square plus mgh, addition of the kinetic and potential energy, or you are saying half mv max with respect to the maximum velocity, or you compare it with respect to mgh max, talking about the maximum height covered. On the other hand, for an elastic material, talking about a spring, in the case of a spring, this is for simple pendulum. In the case of a spring, an elastic material now, such as a spring now, we have that considering a specific displacement from its usual rest position such that it moves a distance y from the original position. We expect that for this, the force is always given by the force constant times the extension. In this case, the extension is equal to y, is denoted by y here. As such, we say that the force in the elastic material will be given as minus ky. Or in the case where y, the extension is equal to amplitude, you can easily say that F will be equal to minus Ka with respect to the amplitude, the highest displacement that can be obtained. But recall that we can relate this value to the work done in the simple elastic material, talking about the spring. So we can say work done in elastic material W is equal to half Fe. Putting in the value for E now, we are replacing E with A. We say that the total work done W total will simply be equal to half into bracket of K and A together multiplied by A. So W total will be equal to half Ka square. Half Ka square. However, if we are to consider with respect to the potential energy and the kinetic energy under an elastic material, we'll simply say that total energy or total work done will be equal to half Ky square with respect to the potential energy plus half mv square with respect to the kinetic energy would be equal to half Ka square, which is the maximum displacement, the amplitude covered. So with this now, equating these two sides, we are going to have that half will cancel out. We have that half ky square plus half mv square should be equal to half ka square. Half will cancel out all through. So we have ky square plus mv square to be equal to ka square. Collecting like terms, you have mv square will be equal to ka square minus ky square. So easily we can say that v square will be equal to ka square. K is common to both sides of the value. So k into brackets a square minus y square over m is what you have. So considering this, we can say that the velocity in a simple elastic material, talking about the spring, can actually be derived, given as square root of k over m with respect to a square minus y square. When you compare asterisk with the formula for velocity given by v equals to w square root of a square minus x square, you see that there are similarities here such that we can easily say that this value for w is equally expressed by k over m. That is, v equal to square root of k over m into bracket of square root of a square minus y square can easily be compared with w into bracket of square root of a square minus x square. So looking at it, we can easily say, therefore, w is equal to square root of k over m. Relative to this, we can now determine that the period of oscillation subject to the value of the angular velocity can be determined. Recall that we said frequency is equal to, first we say w is equal to 2 pi f, and we have that f becomes 2 pi w over 2 pi easily. We can also say the same thing for the value of t, having that t, this will be 1 over 2 pi square root of k over m. Here, talking about w being equal to 2 pi over t. When you tend to cross multiply, you are going to have that t will be equal to period t will be equal to 2 pi over w. When you compare this with the formula which we have, you are going to have that 2 pi would be multiplying square root of m over k this time around. Why? You are having the inverse of w, and inverse of w will mean m up and k down, which is expressed by this value. So have this at the back of your mind that whenever you're asked to calculate the period, you can always be given the force constant and the mass in relation to the angular velocity. Let's get to look at questions in relation to all the formulas we have expressed on the board. Starting first with the energy of a simple harmonic motion with respect to a simple pendulum, where we consider the maximum velocity in a simple harmonic motion, as well as talking about the elastic material, a spring, where we consider the extension in relation to the work done, where we are able to now show the relationship between the angular velocity, W, and the elastic constant or force constant, K, with respect to the mass of the given elastic material. Let's get to the examples quickly. Let's consider this example to better understand what we've been talking about so far. In this question, we are told that a spiral spring with force constant 0.4 Newton per meter, alphabet K equals 0.4 Newton per meter, has a mass of 20 grams suspended from its end. The mass being 20 grams can be converted to give 0.02 kilogram. We are told that the amplitude A is given by 0.2 meters. So first of all, we are to calculate the period. Period in this sense can be gotten, C can be gotten using 2 pi over W. But recall that W is equal to square root of K over M. So putting it here, we have that C will be equal to 2 pi square root of M over K. So we have 2 times 22 over 7 times square root of the mass value 0.02 divided by 0.4. So this will give us, this is giving us 1.41 seconds approximately. So this is the value for the period. The second part of the question is making reference to the frequency of motion. Recall that frequency F is equal to 1 over period. As such, 1 over 1.41 should give us what we are looking for. So 1 divided by this value should be 0.71 hertz as the value. So 1 over period should give us 1 over frequency, the value for the frequency. The next part is asking us to calculate the total energy stored in the spring. So talking about the total energy stored, we say total energy will be equal to half Ka squared, because the maximum displacement will be with respect to the amplitude. As such, we have half of the first constant, which is 0.4, times amplitude square 0.2 square, giving us, so this we have 8 times 10 raised to power minus 3 joules. So that will be the value of the total energy stored in the spring. Lastly, we asked to find the maximum acceleration of the motion. So talking about maximum acceleration, it is expected that under maximum acceleration, the value of x should be equal to the amplitude. The value of x should be equal to the amplitude, that is 0.2. So as such, we have that A max will be equal to minus w square x, which is the same thing as minus w square a. Let's get the value. We're going to say 2 pi f all squared multiplied by the amplitude. So this is 2 times 22 over 7 times the frequency value which we calculated, 0.71, everything squared, multiplied by 0.2. So we get, so the value is 3.98 meter per second square. So there you have it in terms of the solution. So let's get to look at another interesting part under energy stored, which is with respect to forced vibration. So the forced vibration helps to spell out what happens under the circumstances of oscillation. Now, ideally, when a body is oscillating to and fro, it is expected to continue that way continually. But what happens is, after some time, you get to see a reduction in the amplitude as such until the body stops moving. As such, we can say that air resistance has rendered what? The effectiveness of the oscillation towards an halt. It has rendered it, it has brought it to an halt. In this instance, when air resistance tends to affect the oscillation of a body, we define such type of oscillation as damped oscillation. Damped oscillation. So, whenever a body is moving, it is expected that as a result of air resistance, the oscillation at a point reduces till it gets to a stop. So, this type of oscillation which occurs as a result of which is brought to a stop as a result of air resistance is known as damped oscillation. You can always illustrate it by saying you have the oscillation like this. So there's a reduction till there's a final halt in the motion. So this is defined as a damped oscillation. An oscillation, a simple harmonic motion in which air resistance affects the movement of the oscillation, bringing it to rest, is defined as damped oscillation. The second one will be the free oscillation, which is expected ideally in a vacuum, such that there is continuous motion of a simple harmonic motion which occurs without any effect of air resistance on the oscillation is what we tag free oscillation. So the body continues swinging at its maximum length without any hindrance caused by air resistance. So free oscillation. Now you must understand that ideally, talking about air resistance around us, we want to ensure that there's continued motion of this simple pendulum. As such, we introduce an external force to the oscillating body. When this is done, we define this process as being a forced vibration, in the sense that an introduction of force vibration occurs when an external force is introduced to an oscillating body to reduce the damping effect of air resistance. As such, ideally, this is meant to come to a halt, but an external force is introduced continually at intervals to keep it oscillating about. Having said this, you should now know that when this external force is introduced, and we now have the frequency of the external force introduced to be the same as the natural frequency of the oscillating body, then a process is achieved known as resonance. A process is achieved known as resonance, a process in which a body vibrates as a result of vibration of another body. Then we are making reference to resonance. So ideally, you expect that when you are seated in a car, the body of the car is vibrating relative to the vibration of the engine of the car. So we say that there's resonance between the body of the car and the engine. So here we go. You have that the glass windows will be set into vibration as a result of vibrations coming from the music player placed close to it. Now understand this. We just said that resonance is going to occur when an external force introduced to an oscillating body creates a frequency which is actually equal to the natural frequency of the oscillating body. Resonance is said to occur. With this, I'll get to leave you with some few drill questions which you can attempt on your own. Then we call it a wrap-up on this topic. All right, I'm sure you were able to attempt the drill questions. Let's look at the solutions together. First, we're told to state the two types of oscillation. There are majorly two types of oscillations. We have free oscillation and the damped oscillation. For damped, you have something of this. So having this said, for question 2, we are told that a spiral spring of mass 0.6 kg is suspended from its ends if the force constant K is given by 30 Newton per meter. We are told to determine the extension in the spring. Also, we are to determine the period t, the frequency f, and the w value, the angular velocity, alphabet w. So looking at this here for a spiral spring, it's easy to say that comparing the force in terms of the weight with respect to the elastic force, we are going to say that mg should be equal to ke, having that g will be equal to 10 meter per second square. So easily we can say 0.6 multiplied by 10 should be equal to 30 times the extension. Dividing through by 30, 0 cancelling 0, this cancelling this. Extension can easily be said to be 0.2. The unit will be meters. There you have the extension. So we compared the weight with the force, elastic force. Having that being said, for the second part, calculating the period, remember that we said period t is equal to 2 pi square root of m over k. And as such, 2 times 22 over 7 times square root of the mass 0.6 divided by 30 will be equal to 0.89 seconds. Approximately, we have that. The frequency is inverse of the period. Frequency f is equal to 1 over t. So taking 1 over 0.89, frequency will be equal to 1.12 Hz. Lastly, we consider the angular velocity. For angular velocity W, we have square root of k over m. The angular velocity will be square root of k over m. So from here, W will be equal to square root of k value being 30 over m value being 0.6. So W will be equal to 7.07 rad per second. Remember, you measure the angular velocity in radian per second. I'll ensure you and appeal to you to go over all that we have done so as to ensure that you have a clear understanding of all the questions we have solved, ranging from the energy derivations of the simple pendulum to the elastic material, talking about our spring, and looking at all the formulas we have under it, up to the point whereby we talk about the force vibration. See you in the next class.
Demand and supply is a very popular topic in economics. I'll be looking into the definition of demand as well as the definition of supply. We'll also look into the factors that affect demand and the factors that affect supply. We'll also look at the types of demand as well as the types of supply. We don't stop there. We also move into the graphs and the schedules that can be used to explain demand and supply respectively. Let's get to class. Welcome back to class. As today we'll be talking about demand and supply. I'm sure you're wondering, demand and supply? Yes, demand and supply. Demand and supply actually has various arms and various sectors. I want to talk about one. We've discussed one aspect in our previous module, and today we'll be discussing another aspect of demand and supply. So the aspect we'll be discussing today is what we call the changes in demand. We're talking about changes in demand and quantity demanded.
Then we also talk about the supply side as well. That is changes in supply and quantity supplied. So let's take a look at changes in demand and quantity demanded. Now, changes in demand or change in demand is actually a stage whereby your demand changes or your quantity demand changes, but it is not the price that causes the change. There are actually many variations or many factors that determines demand, for which number one is the price, number two, consumer taste, number three, the preference and habit, number four, the habit, the weather, the climate. Number next, we have the consumer income. And the next one again, we can also have consumer population. So we have a lot of variations that, a lot of variables that causes your demand to what? To change. Now, when your demand is changing, that is, your quantity demand is changing, but it is changing because the price is constant. It means the factor that leads to the change is not the price, but it is all other factors affecting demand. Now, let me have something like this. Demand equals some certain factors. Is that not it? Which is price plus weather plus taste plus habit. 1, 2, 3, 4. Let's add one more for it to be 5. Plus, we also have our income. Now, these are the 5 things that can affect this demand. Now, when all these things that we have here, 1, 2, 3, 4, when these are the things that is affecting your demand, where this is what? Is, let's say, 0, is a constant. So what it means is that the change here, it is what? Change in demand. But when it is a change in quantity demanded, what we will have here is all these ones here, they are now 0. While this one is now what? Is now active. Now we are going to draw some few graphs, just few, and very, very simple, so that we can actually understand this thing better. Now for change in demand, let's draw that first. This will be our main prerequisite to explain. So our graph comes here like this. Then we'll have a demand curve like this, which is my D, and I have my D. Now, what I'm having here is price is constant at all levels. So it means that my price, because my price is constant, this is it. My price is here. It's constant. Now, my demand is going to change here. So it means an outward shift in my demand. That is the outward. So this outward shift here will come here. So I can call this one, because it's an increase, I can call it D2. I'll call this D2. Because this is my initial, right? Let me call it DO. Is that not it? Then, so we can actually do an arrow like this and signify by saying increase or expansion. Okay. Now, from here, we'll notice that from this quantity, okay, this is my quantity axis. Please, let's keep that in mind. Then, from this quantity here, let's say QO, my quantity has moved to what? Q2. That means that because of this factor, maybe I have an increase in income. Now, the price actually is not causing my increase in demand here, because my income has increased. So therefore, I can increase my demand. Okay? Or maybe my taste and preference or my habits for a particular, for the consumption of a particular goods has actually increased. So as a result of that, my demand will also what? Increase. It will follow suit. Are we there? So it means that from what we have here is, from QO, my demand, my quantity has actually been increased to Q2. Why? Because of maybe increase in income, or increase in habits, or increase in taste, or some suitable weather or unsuitable. For example, weather conditions like rainy season actually increases demand for umbrella. Irrespective of the fact that umbrella is expensive or not, you will buy. Are we there now? So it means that when we have increase here, then a decrease will be an inward shift. So it means that I'll be having one more here. So from DO, we can actually call this one D1. So this is what I call decrease. So this is my decrease, or we can call it contraction. So it means here, demand has decreased. Okay? So if my income decrease, demand will decrease. So it means this is the quantity. Q1. Now, all what I've done here, the major thing is in change in demand, price is constant, while other factors affecting demand plays a dominant or an active role. Very simple. So with this, price is constant, while other factors affecting demand play a dominant role. Very simple. So it means that it is those other factors like this, and this that is shifting your demand either to the right or to the left. So this is my rightward shift and this is my leftward shift. Then we go to change in quantity demanded. Now, my change in quantity demanded, it is the vice versa of my change in demand. You know, in this case, price is constant. So therefore, in this place, price will not be constant. Price will be moving up and down. So I will have my normal demand curve as usual, which is D. But in this case, this is the only demand curve we are going to have. Then here, I'll have a price, 1. So where this is my PO, my initial price, and QO, my initial quantity. Then, if there's an increase in price, so let's say P2, there's an increase in price to P2. What is the quantity demanded? Let's trace it. We trace it to the demand curve and we bring it down so that we will know whether the quantity demanded actually increased or decreased. So when we trace this P2 to this side and we trace it down, we can see that an increase in price has reduced my quantity demanded. So it means the actual note to take note here is that it is the price that is changing. But here, the price is not changing. Whereas here, the price is changing. So here we have, so we can have here to be Q, let's call this one Q1. Then, so if my price decreased, you can see my quantity demand will also increase. So at P, let me call this one P1 and let me call this one Q2. So we can see that this is what we call change in quantity demanded because it is my price that is changing. So therefore, this line, we can call it movement along the demand curve. So this is actually another name we can call change in quantity demanded. We can call it change in quantity demanded, or we can call it movement along the demand curve. So from here, point to note is that price play an active role while other factors affecting demand are fixed or constant. So we can have it like that. Then we'll move on to the supply side. That is change in supply. Now, just like we decided for demand, so supply, what are the variables that causes changes in supply or that determine supply? we have the first one, which is price as well, plus level of capital, or we can just say capital. You can say raw material or human resources. Let's just say raw materials. I say raw material or resources. Plus, we can also say technology. Then we can also say suppliers population. So these are the factors, among other factors, these are the factors that affect supply. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 5. Now, we all know that all these things in place affect supply. Now, if the price is constant, that is, price is 0 or constant at a particular level, it means that when all these things is affecting your supply, what we are going to have is a behavior like this. And don't forget, our supply curve is not shifting downward, rather it is shifting upward. So we are going to have a diagram like this, where our supply curve will be upward, which is, so let me draw my initial supply. This is my supply, initial supply. Okay, so my initial supply, SO, initial. Okay, so don't forget our price is constant, right? So we do this, constant price. This is my quantity. So since we have constant price, so let us increase our supply and see what will happen. So at this constant price, this is our quantity. So we have this initial quantity. So let's increase the supply. By increasing supply to this level, you can see what we have. So here, I can call this one S2. S2. I will call this Q2. So it means that from this level, it means that what we have here is that our supply has actually what? Increased. So when the supply has increased, it is not the price that causes the increase. It is actually other factors affecting what? Supply. Then, so we can do an arrow like this and signify by writing increase. Then, if we should decrease the supply, decreasing supply at the same level of price, which is our PO, we will have something like this. So this is our S1, S1. So at this level, we can actually do something like this and call it decrease. So at this level, we can say supply is decreasing. That means it comes back to Q1. So we can see this is what we call change in supply. Just with the same notion, price is fixed while other factors affecting supply is dominant, or they play the active role. So we move on to change in quantity supplied. For change in quantity supplied, we draw the same graph. Then our curve is upward, like that. So we have our S. Because the price is changing here, is that not it? So due to the changing or variations in price, our supply curve will be just 1. So we'll be having this. So let's have our initial price. Initial price will be PO, QO. So an increase in price. So when we increase the price to, let's say, P2, this is what we have. This is our quantity supplied. So it means there will be an increase in quantity supplied. Okay. Now, when there's a decrease in price, so let's say P1, it means there will be a decrease in quantity supplied. So we can see that from here, it is the price that is what? That is enabling us to supply. But here it is not the price. It is other factors affecting what? The supply. So the same notion goes as it goes for demand. Here, price plays a dominant role while other factors affecting supply remains constant. So this line here, just like it can be called movement along the demand curve, it can also be called movement along the supply curve. So this is what we refer to as change in demand and change in quantity demanded, change in supply and change in quantity supplied. So now, let's see what an equilibrium economy really means. Now, when we talk about the equilibrium, an effect of an increase, when we have this increase in demand, okay, or increase in supply, what happens when there's an increase on an equilibrium state or in an equilibrium economy? So we want to see the effect of an increase and decrease in demand on equilibrium. So the first thing we do is I'm going to draw two equilibrium states here. So I'll call this one A. Okay, going to the next one, I'll call this one B. Okay, now let's name them. This is my demand, this is my supply. This is my demand, this is my supply. So we all know that the state at which demand meets supply, that is my equilibrium. So it means I'll be having this. So this is my demand, okay? This is my equilibrium. So since we have this, the first thing we want to treat is what? Increase in demand. So increase. So let me call this my increase. Let me call this my decrease. So when there's an increase in demand, what happens? An increase in demand, the demand curve shifts upward. Is that not it? So let's see what will happen here. So let me shift my demand upward. And let's see what will happen in the economy. So here I'll be having D2. So see, let's call this one DO, and this is my D2. Now, what has happened in the economy? Now, this is the initial. Now, the demand has shifted upward. So because the demand has shifted upward, what is there's a new equilibrium. Is that not it? So my new equilibrium is here. So let me trace it. Let's use broken lines so that we know that that's the new thing we got. Now, let me call this my POQO. POQO. Now, we can see that the increase in equilibrium is good here. So it means the effect of an increase in demand on equilibrium, okay, or in an equilibrium state is that there is an increase in equilibrium price and quantity. It's feasible. We can see, so it means that when we increase demand with a constant supply, what it means is that there's going to be what? An increase in what? In the equilibrium price and increase in the equilibrium quantity. Very, very what? Simple. Now, what do we have here? Still the same equilibrium, but let us have a decrease in demand when supply is constant. It means that the supply is not increased. Supply is still at the same level. So when demand decrease, when supply is at the same level, what happens in the economy? So when we decrease demand, we have something here. Is that not it? So here will be, if this here is DODO, SOSO, showing out that's our initial supply, initial demand. So when the demand decrease, we can call it D1. D1. Now look at what has happened here. It means there will be a decrease in equilibrium price and so what has happened here? So it means that this is my new equilibrium. We can see here. So it means from here, this is my decrease. So it means something is happening here. This is my new equilibrium. So it means when supply is constant, okay, and demand decreases, it means that equilibrium price and quantity will also decrease. And it is very, very practicable, because when suppliers when suppliers are still supplying the same amount and demand, for some reason, either price or anything, demand just reduces. Okay, if demand reduces, okay, here since it's a decrease in demand, so price is not actually the dominant factor. So if demand should decrease as a result of these factors, it means that equilibrium will also change. So the equilibrium price, there will be a decrease in equilibrium price and quantity. There will be a decrease in equilibrium price and quantity. Very, very simple. And now, since we've talked about an effect of increase and decrease in demand on equilibrium, now we also need to talk about an effect of what? An effect of increase and decrease in supply as well. Okay, so since we have discussed about the demand, we now need to discuss about the what? The supply. All right, so now we want to see the effect of the increase and decrease in supply on equilibrium state. Now, so the first thing is we need to draw the equilibrium state. So let me tag this as a decrease. So what we do first is we need to signify a decrease in supply. So we have to draw the equilibrium first, which I have my demand, supply. So demand, supply. So now, if supply decreases, what happens? Is it outward or inward? When supply decreases, it's always inward. So let me signify my equilibrium here. 1, 2. So this is my PO equilibrium, QO equilibrium quantity. So now, when supply decreases, it means my supply comes above here. Now, this is what we have. So here I'll be having S, let's say this SO, and this is my S1, S1. Let me call this DO. That is initial demand. Now, what is happening to the equilibrium? It means that when demand is constant and supply has decreased, demand level is the same, but supply has what? Has decreased. What will happen to the equilibrium? It means this is the new equilibrium level. We trace this. 1, we trace this. 2. So it means that with demand constant and a decrease in supply, it means there will be an increase in equilibrium price and a decrease in equilibrium quantity. So this is the effect. There will be an increase in equilibrium price and increase and decrease in equilibrium quantity. Now, let's go to our B part now. So for our B part, we'll be having increase. So for our B part, which is the increase, so let's have our demand, supply. So this is my demand here, supply. Now in this case, supply is increasing. So my supply increasing is coming here. But before I do that, let me trace up my equilibrium levels first. So I'll be having here PO, QO, initial equilibriums. So increase in supply will be here. Good. So now, since my supply is increasing and my demand is constant, so here I'll be having S2, S2. Now, what is happening here? When demand is at a constant level and my supply is increasing, what will happen to the new equilibrium? So it means that this is my new equilibrium. So let's trace it. If this is my equilibrium price, it means the equilibrium price is what? Decreasing. Then broken lines there. So it means that I have a new equilibrium. Is that not it? So this is my new equilibrium now. So that means that an effect of an increase in supply on a constant demand, it means that there will be a decrease in equilibrium price and increase in equilibrium quantity. That's what it means. So it means that whenever there is a constant demand while supply increases, there will be a decrease in the equilibrium price and an increase in the equilibrium quantity. Now, this is what we refer to as equilibrium and demand, the changes in demand and changes in quantity demanded, while we refer to the change in supply and change in quantity supply. Thank you very much as I give you some drill questions so you can practice your hand on them to see whether you really understand the topic. Welcome back as we provide solutions to the drill. Hope you've solved them and see how interesting the questions are. Number 1, explain the effect of a simultaneous increase in demand and supply on an equilibrium state. Number 2, with the aid of a diagram, explain the changes in demand and supply. Now, I'm sure number 1 will really get you thinking. Look at the number 1. Explain the effect of a simultaneous increase in demand and supply. So what we are trying to do here is demand increasing and supply increasing. So it means that we just have the equilibrium and nothing is constant. You know, from our previous examples that we did, we've seen that either demand is constant while supply is constant. So we can see some changes. But in this case, nothing is constant. Okay, the only things that are constant is my initial equilibrium. So now we are going to draw. We are going to draw our initial equilibrium, which is 1, 2. So we actually have to make this one DO, SO, SO, signifying my initial supply. Then if demand, so let me trace my initial equilibrium. I'll be having this. Now, if my demand increases, my demand increasing comes here. So I'll be having D2, D2. Now, if my supply increases, this is what I'll be having. My supply, increase in supply, okay, increase in supply is coming downward. So my increase in supply will come downwards, going like this. So I will also call this one S2, S2. Now, you need to be very careful with the equilibrium here. Now, what is my equilibrium at this level? We are considering DOD, you see, DOSO. This is the equilibrium. So now, your new equilibrium will not be DOS2. No. Your new equilibrium will be what? D2S2. So let us look for it. So where's my D2, where's my S2? This is D2, and I think this is my S2. So it means my equilibrium is here. So let's trace. So we can see. So it means that at this level, where there is a simultaneous increase in demand and increase in supply, what we are going to be having is, let me give my initial equilibrium here. So it means what we are going to be having is, there will be a slight decrease in the equilibrium price, while there will be what? An increase in the equilibrium quantity. You can see the margin of decrease here. See the decrease here. Because of this small decrease, look at the increase in quantity. What? The increase in what? In the new equilibrium quantity. So this is just the effect. That's all. Don't mind any other equilibrium. Don't mind any others. You are only looking for the old one. You are considering this is the old one. The old one is here. So this is the new one. That's all. D2, D2. Forget about S1, SO, S2. No. You are considering DOSO, D2, S2. That's all. Okay? So it means that my effect here is going to be a slight decrease in equilibrium price and a wide increase in equilibrium quantity. Now, in economics, whenever you've been asked to explain anything that relates to change in demand or change in quantity demanded or anything that we have, something like this, it's best, especially your exams like school exam, WAEC or GC or any other forms of examination for which is theory. Whenever you've been asked a question like this, the best thing to do is draw the graph and explain the graph. That's the best thing so that you can be accorded your full marks. So we move on to question 2. Question 2 says that with the aid of a diagram, explain the changes in demand and supply. So the first thing is changes in demand. It means I have to draw first. You can see that in this question, they say with the aid of a diagram. Sometimes a question might not come as with the aid of a diagram. They will just say explain changes in demand and explain changes in quantity demanded. The best bet for a student is to what? Is to draw the graph as well and explain, because that is when your full marks will be awarded. So we need to draw the graph. So for my change in demand, so I will target change. So let me draw give it a tag, change in demand. All right, so we want to explain now with the aid of a diagram the changes in demand and supply. So changes in demand, how do we do that? Our demand curve is sloping downward. So having this is going to be my D. Now, since it is change in demand, have it in mind that price is constant. So if price is constant, it means I won't have one demand curve. I will have another one signifying D2, which is my increase. Then I'll have another one down here, which is signifying a decrease. Now, so if I have a decrease here, so I'll call this one D1. So this is my variations in quantity. So this is what I'm having. So here is my PO, that's my initial price, and this is my quantity. I'll have here Q3, let's make this one. See this D2, let's make it Q2, this QO, then this Q1. So with this, don't forget that price is constant while all other factors affecting demand plays a dominant or an active role. Then we'll move to the next one, which is change in supply. So for my change in supply, same graph, and my supply is going to be like this. That's my SO. So because it's a change in supply, I'll be having a constant price, PO. Then I'll have one supply here, another supply here. So having this one, this will be my increase, S2, S1. 1, 2, 3. So this is Q1, QO, Q2. So with this, we can now see, this will be an increase, where this will be a decrease. So this shows that decrease, increase. So what this is trying to tell us is that the price is fixed while all other factors affecting demand are playing the dominant role. Thank you very much as we come to the end of this class. See you in our next class.
Welcome to your physics study part. Today we get to look at the derivation of linear equation. I'm sure you're familiar with the name Newton. The scientist Newton came about certain equations that make it possible to easily calculate terminologies like your speed, initial speed, your final speed, your acceleration, and time covered whenever you engage in motion. Also, interestingly, we get to look at motion under gravity. Have you wondered how suddenly a fruit gets to fall off a tree without anybody going near it? This is actually possible as a result of understanding that motion can always occur under gravity. So, we look at calculations involving motion in straight lines, linear motion, as well as calculations involving motion under gravity. Join me in class. Welcome to today's topic. Looking at derivation of equations of linear motion, as well as motion under gravity today. First, you need to understand that we've always mentioned equations of motion, Newton's equations of motion. There are ways with which we're able to derive these equations, which you are going to get familiar with today. Now, remember that under the Newton's law of motion, talking about the second equation, it's easy to say that acceleration remains the change in velocity with respect to time, the rate of change of velocity with time. As such, we said that acceleration A is equal to v minus u over t. From here, when we get to make the v value subject of the formula, we have that v minus u will be equal to at. Get to move your u to the other side. We have v will be equal to u plus at. This serves as the first equation of motion. Recall that your equations of motion get to express 5 different terms. The first being the acceleration. It helps you to calculate the acceleration of a body. The second being the initial velocity, u. The next being the final velocity, while the fourth being the time taken, and s being the distance covered. Linear motion would always work on the principles of these 5 physical quantities. Now, having understood how we came about the first equation, you ask yourself, the second equation, how did we come about it? Remember, we have that, to derive the second equation now, we have that distance is equal to average speed or average velocity times time. But what is the formula for the average velocity? We have that average velocity is actually equal to u plus v over 2. U plus v over 2. When we get to put this value in, we get an equation. But ideally, if we are to substitute what v represents from here into this expression,
you have that average velocity will be equal to u plus at everything over 2. You can see that this value can be simplified saying 2u plus at over 2. You can split up the two values. You have that average velocity will be equal to 2u over 2 plus at over 2, giving us u plus half at as our value for the average velocity. Easily, we can bring this into the context of distance. As such, we say that our distance s now, distance being average velocity, times time will be equal to s here with respect to u plus half at multiplied by t. And when you use this to multiply, you get to see that s will be equal to ut plus half at squared. So we have half at squared here. So this serves as the second equation. Talking about the third equation, it's for us to consider what we have in equation 1 and you square the value. So this is what I mean. For equation 3, we square the value of equation 1. So this is what we mean. V being equal to u plus at. Having us square it, we have this. From here, v square will be equal to u plus at multiplied by u plus at. You get to see that v square will be equal to u square plus 2 u aut then plus a square t square. From here now, you can see that this value here has something similar to what our s value is. Bringing it out, you are going to have v square will be equal to u square, then plus 2 being brought out, then a also being brought out. You are going to have ut being left plus half at square, because 2 multiplied by half will give you 1 here. 2 multiplied by 1 will give you this value here. So this here now represents what we have for our distance. So since s is equal to ut plus half at square, easily you can say v square will be equal to u square plus 2as. There you have it for the third equation. For the fourth equation, we simply consider what we have there already. Distance is equal to average velocity times time. So we have that s will be equal to, using equation from asterisk, u plus v over 2 multiplied by t. And that gives us s as being half u plus v t, being the fourth equation. This is how we got to derive the 4 equations of motion. First equation being v equals u plus at. Second equation being s equal to ut plus half at squared. The third equation being v squared equal to u squared plus 2as. And the fourth being s equal to half u plus v multiplied by t. With this, we can get to now understand that the four equations of motion actually have ways with which they were generated. Now, it's easy to now consider the equations peculiar to motions in vertical plane, that is, vertical motions, upward or downwards. I'll give you what they represent. Let's look at it. It is expected to note that whenever you throw a body up, it is going to come down. And this is as a result of the influence of gravity on such body. Now, when a body is thrown up, there's a specific height it attains at which it has to stop before coming down. So, that height known as maximum height. We are expected to note that first, at maximum height, the final velocity v of a body is 0. That is, v equals 0 at maximum height. Have that at the back of your mind. V is equal to 0 at maximum height. Secondly, that is for a body moving upwards. For a body released from a specific height, we believe that the object is at rest initially. As such, we tag that the initial speed is actually what? 0. So, for a body at a given height above the ground, the initial velocity u is 0. So, we're making reference to u being 0 at height above ground. Furthermore, the distance s we are considering, which we use for our horizontal motion on horizontal surface, we change to h since we are considering a given height above the ground. As such, it's easy for us to say that what? The distance covered is the height above the ground. Full stop. Therefore, S becomes equal to H. So we'll be using H in our calculations. Furthermore, when a body is moving upwards, we say it is acting against gravity. As such, the velocity reduces going upwards. But when a body is dropped down, we say it is acting in the direction of gravity. Hence, it carries what? A positive acceleration due to gravity. In the sense that the acceleration of the body in vertical motion A is equal to positive or negative g, where positive is used to represent the body moving downwards. and negative to represent the body moving upward. So having that said, we can now create a modification to these equations of motion with the exception of the fourth one. Here now we are not going to make any modification to this fourth formula because we are not using it at all. Reason is there's absence of the alphabet A, acceleration, in it. Remember, any body moving vertically, upwards or downwards, acceleration due to gravity will act on it. Since there is absence of G here, we cannot use this formula. As such, the three formulas adopted whenever you are dealing with vertical motions would be V is equal to U plus or minus GT. The second will be SH in this case now. H equal to UT plus or minus half GT square. Then the third V square would be equal to U square plus or minus 2GH. So there you have it for the equations of motion under the influence of gravity. Let's get to look at some examples to buttress our point. The examples before us here now would be showing us how to apply the equations of motion which we have actually derived. First, we have that a bus accelerates uniformly at a rate of 5 meters per second square from an initial velocity of 18 meters per second for 10 seconds. We have to derive and determine what the distance covered would be. So first and foremost, we are given the acceleration as 5 meters per second square. We have the initial velocity u as 18 meters per second. Then we are given the time value as 10 seconds. We have to determine what our s value would be. The best formula to adopt will certainly be s equals to ut plus half at squared. So we say s equal to ut plus half at squared. S becomes 18 multiplied by 10 plus half into the bracket of 5 and 10 square. So from here, S equals to 180 plus 100 from here, then 500 to 50. Easily, S is equal to 430 meters. That being settled, we can get to look at the second question, talking about calculating the velocity. Here, we are given the initial velocity as being 60 meters per second. U equals 60 meters per second. While we are given the value for what? The acceleration as 10 meters per second square. Furthermore, we are given the final velocity, 60. We are given the time value as 20 seconds. We are asked to determine what the velocity v is going to be. Based on this, we can easily say v is equal to u plus at. From here, v is equal to 60 plus 10 multiplied by 20. And from here, v is equal to 60 plus 200, which gives us 260 meters per second. So there you have the value for the velocity for the second question. The third question here, we are told that a body with a velocity of 10 meters per second and it actually accelerates to 5 meters per second square. So for this here, we have the initial velocity as 10 meters per second. We have that the acceleration is 5 meters per second square. Then we have the final velocity v as being 20 meters per second. We're asked to determine the value for S covered. So based on this here, you see that having initial and final velocity, the formula that comes to mind would be v square equal to u square plus 2as. So 20 square would be equal to, or better still, making the value of S subject, we have that v square minus u square will be equal to 2as. Dividing both sides by 2a, easily we can say that S is equal to v square minus u square over 2a. So putting in our values, we have that 20 square minus 10 square over 2 multiplied by 5. So S equals 400 minus 100 over 10. That leaves us with 300 over 10, and the distance is 30 meters. That's sorted out. We look at the question 4 and question 5, making emphasis on motions under gravity. Why? We are told in question 4 that a ball is thrown vertically upwards. Vertically upwards. So, for question 4 now, being thrown vertically upward with an initial velocity of 40 meters per second. That means u is equal to 40 meters per second. We are told to calculate its velocity after 3 seconds. So t being 3 seconds for the first part, we are told to find v. So we are going to have that the best formula would be going upward now. Do we use a positive or a negative g? Certainly we use what? A negative g, since it's acting against gravity. As such, v will be equal to u minus gt. As such, v is equal to 40 minus, we know the value for g as being 10 meters per second square. 10 multiplied by 3 here. So v would be equal to 40 minus 30. And that gives us v as 10 meters per second. So that will be the velocity after 3 seconds. The next question would be to determine what the maximum height reached will be. What is the value for the maximum height reached? To get that, we simply use the formula that says that at maximum height, the final velocity is expected to be 0. So we say at maximum height, v is equal to 0. As such, we can use the formula considering the fact that we have the initial velocity given to us as 40. U being 40 meters per second. And g equals to 10 meters per second square. We can say that v square will be equal to u square minus 2gs. Having that v will be equal to 0 here, since we're having it move against gravity. Easily we can say 0 is equal to u square minus 2gs. Bringing this here, 2gs is equal to u square. From here, dividing through by 2g. S, in this case, we are using h, sorry. H value here, since we are considering vertical. So our h here in this case now would be u square over 2g. Easily we say h is equal to 40 square over 2 multiplied by 10. 1,600 divided by 20. So we have 1,600 divided by 20. H is equal to 80 meters. H becomes equal to 80 meters. For the second part, third part of the question, talking about the total time taken for the ball to return to the ground again. So we are expecting the ball to move from the earth, from the ground to a specific maximum height, then return downwards. To do that, we expect that the time taken to move to the maximum height will be equal also to the time taken for it to return to the ground. So determine the time to reach the maximum height. From there, you can easily get what the total time will be. So to do that, for question 3, we are going to use the formula V is equal to U minus GT. And remember that the value we have for this guy is 0. So we say 0 is equal to 40 minus 10t. Move the value here. 10t is equal to 40. So t is equal to 4 seconds. Having this now, this is time to reach the maximum height. We can now say that what? Total time is equal to 2 times the time to reach the maximum height, which is 2 times 4, and that gives us 8 seconds. So you have 8 seconds as the total time required to move from the ground to the highest point, then from the highest point back to the ground as well. So the total time taken will be 8 seconds. Lastly, for question 5, we are told that a fruit is dropped from a tree at a level 20 meters high. We are told to determine its velocity and time on hitting the ground. So we are to determine the velocity and time on hitting the ground. So based on this here now, you observe that the height was given, h. So easily we can say that for the question 5, h is equal to 20 meters. We said it that at a given height above the ground, a body that is actually being dropped would have an initial velocity of 0. So as such, we have that u value here is 0. G equals 10 meters per second square. Then we can get to determine what the value for V would be. So we say V square will be equal to U square coming down, positive or negative? Certainly positive, since it's acting in the direction of gravity. So we have plus 2gh. The value of U being 0 here, we have V square equal to 2gh. Easily we can say V square will be equal to 2 multiplied by 10 multiplied by 20. V is square root of 400. We have that V will be equal to 20 meter per second. So that serves as the value for the final velocity on hitting the ground. What about the time taken? The time value, just at the moment it strikes the ground. So we can always adopt the formula that says V is equal to U plus GT, knowing that the initial velocity is 0. So we have V equals to GT from here. 20 would be equal to 10 multiplied by T. Divide both sides by 10. We have that T, the time taken will be what? 2 seconds. There you have it. With regards to the examples under horizontal linear motion and motion under the influence of gravity, I'll get to leave you with drill questions which you can attempt, after which we look at the solutions together. The solution to our drill questions. First, an object is fired vertically upwards with a velocity of 100 meters per second. We are told to first calculate the maximum height reached. To do this, we extract our values. We are given the velocity as being the initial velocity, in this case, u, has been 100 meters per second. Here you see that at maximum height, we expect the final velocity to be equal to 0. Also, we can easily say that g value would be equal to 10 meters per second square. So we have to determine what our h would be at maximum height and also the time to reach the maximum height. So to go about this, we say that the best formula to use, having u, v, g, and h to consider, would be v square equals u square plus or minus, since it is moving vertically upwards. So we have minus 2gh. The final v value has been 0. So 0 here, we have u square minus 2gh. Moving this here now, we have 2gh to be equal to u square. Dividing both sides by 2g, we have that h is equal to u square over 2g. When we put in the value for this, we have 100 square over 2 multiplied by 10. So we have h being 10,000 divided by 20. So this cancels out. We have 500 meters. So there you have the first question. The first part of the question, rather. The second part of the question, asking us to determine exactly what the time to reach this maximum height would be. So we understand that v would be equal to u minus gt. So as such, here we have v as being 0. So 0 equal to u minus gt. Moving this here, gt is equal to u value. Divide through by g. So t value should be u over g. The value for u being 100 and the value for g being 10. So it means that the time to reach the maximum height would be 10 seconds. I'm sure that was easy for you to solve. Let's go to question 2. For question 2, we are told that a train decelerates uniformly from 40 meters per second to 30 meters per second while covering a distance of 100 meters. We're asked to determine what its retardation will be, then how much farther it will travel before coming to rest, assuming the same retardation. So for question 2 now, we have the initial velocity as being 40 meters per second. The final velocity considered here for the A part would be 30 meters per second. We are considering a distance of 100 meters. So let's get to work. For the first part here now, we're going to say, to determine its retardation, which is A, we have the parameter u, v, and s. The best form of formula to use will be v square equal to u square plus 2as. Putting in our values, we have 30 square will be equal to 40 square plus 2a, then multiply by 100. So from here, we have 900 equal to 1,600 plus 200a. So moving this here, 900 minus 1,600 will be equal to 200a. When we get to subtract, 900 subtracted from 1,000 minus 1,600 will give us 700. Negative. So dividing by 200. So we have the value as minus 3.5 meters per second square. Now, the minus shows that what? It's a deceleration. So, retardation is actually what? The opposite of acceleration. Acceleration being a positive value, deceleration being a negative value. So, the deceleration is indicated by the minus answer, the minus sign in the answer gotten. So, we can say that the retardation equals 3.5 meters per second. On a second note, to now determine how much further it will travel before coming to rest, assuming the same retardation. Then what comes to mind is we are told to find its specific distance. We are looking for S. It is going to cover now. But you know that it's decelerated from 40 meters per second to 30 meters per second. As such, in this case here now, we'll assume the 30 meters per second as the initial velocity for this question here, while the final velocity is going to be equal to 0. Why? They are saying that what? This train actually came to rest. When a body is coming to rest, it means the final velocity is 0. Remember, it's initiated retardation from a specific initial velocity, which was actually given to us as 30 meters per second. So from 30 meters per second per second, it is reducing its speed till the final speed becomes 0. So from 30 we consider to 0. We are told that we should pick the same retardation value. So A value still being minus 3.5 meter per second square. So considering all this now, to get the value for S, what formula comes to mind? Certainly, we'll still be using V square equal to U square plus 2AS. This part being 0. We have that 0 will be equal to U value here now plus 2AS. Transferring this to the other side, we have 2AS will be equal to U square. So from here, putting in the value, we are going to have our retardation now. The value here as 2 into bracket, so we're having 3.5 here. So multiply by S equal to the initial velocity. The initial velocity being 30 square. So this will give us 7S equal to 900. Divide both sides by 7. S will be equal to 128.57 meter. So that marks the value for what? The distance covered. So what we said was we are still using the same deceleration, which is 3.5. Remember, I told you the retardation will be 3.5. The minus already indicating that it's a retardation. Putting it here now, we see that the final velocity is 0, initial velocity here being 30 meters per second, which we adopted here, and from there we're able to what? Arrive at the final answer. So with this here now, we can go to the last question, number 3. A ball was thrown vertically upwards from ground level. It gets to hit the ground afterwards 4 seconds. So for question 3, we have the body moving up. Then after getting it to a specific height, it went down again. So we are told that the total time to cover this distance is actually 4 seconds. From here, we can easily say that what? Half of the time was spent going up, half of the time was spent going down. So as such, time to reach the maximum height will be equal to the total time divided by 2. So T max, which we want to consider now, will be 4 divided by 2, which is equal to 2 seconds. So 2 seconds was spent moving up, another 2 seconds spent moving downwards. So to determine the maximum height reached during this journey, then we are expected to consider the fact that at maximum height, the final velocity is 0. So easily we can say that V will be equal to U minus GT. From here, 0 equals to U minus 10 multiplied by 2. 0 equals to U minus 20. Move it here. 20 is equal to u. So u is equal to 20 meters per second. So having this as the final answer, we can easily say that h equals ut minus half gt square. H is equal to 20 multiplied by 2 minus so from here, H is 40 minus half of this value here, 20. H is equal to 20 meters. With this, we've come to the end of today's topic. I'm sure you are now able to derive the equations of motion as well as using the equations to actually solve questions in relation to linear motion as well as motion under gravity. See you in the next class.
Hello, and welcome to your mathematics study part. One of the major problems facing mathematicians, whether advanced or entry level, is always the problem of understanding what exactly the question or problem is actually seeking to accomplish. In fact, you'd find out that the moment you are able to translate the question correctly, you are almost more than 60% done with actually answering the question. Now, the core values or the core concepts that actually guides the understanding or the translation of these mathematical problems into understandable forms is what we term as logic, right? So just as we have in English language where we have simple concepts, simple sentences, and then we piece them together to form conversations, we have the same as far as mathematics is concerned. We also structure mathematical problems bit by bit, sentence by sentence, statement by statement. So in this lesson, you will learn about the core concept of logic, the meaning of logic, as well as the meaning of the statements that form logic. You would know what we call true statements, you know what we call false statements. You would also know the term of simple statements and then the compound statement, which is just a combination of all or two or more simple statements. You would also be able to use logic to apply in cases of conditional statements, right? So these are statements that will come with their own set of rules and their own set of instructions, and we'll look at them bit by bit, right? The core concept is to split out the various questions you might have in mathematics and explain them using the concept of logic, using the rules of logic, and using the syntax of logic, just as you might have it in other branches of science and other branches of learning itself. So join me for this exciting lecture in class. Welcome to class. As mentioned earlier, our topic today will be the concept of logic. Logic just simply means the systematic use of principles and mathematical techniques to represent or deduce various mathematical scenarios or situations, right? And we do all this using guided and strict principles or instructions that guide our calculations or conversions via logic. Now, the basic principle that serves for any single logic process is always the principle that guides the mathematical statements themselves. These statements would look at very, very basic or very, very simple. However, these statements provide the foundation for any other mathematical analysis we might have. So logic starts from those basics. Logic starts from those statements, and that's exactly where we are going to start from in this class as well. So what do we term as logic and what do we term as statements? We have said that logic is just the systematic ways in which we just translate these statements, right? A bunch of statements put together gives you forms in mathematics that you can translate depending on what kind of logical connectives it has. Now, for these statements, not all statements will be easy for us to tackle, right? So let's start from simple to complex. The basic fashion of statements that you have is what we term as simple statements. Now, think of it as if you are talking about English language. In English language, for any statement you have, there's always going to be a subject, there will be an object, and there will be a predicate. The same thing also applies for simple statements as well. For simple statements, there will be a subject and there would be a predicate. This would not change in any given scenario, right? Now, if having a subject and a predicate qualifies it to be a statement, under mathematical principles, for it to now be a logical statement, it must now satisfy one more condition, and that's the condition of validity, right? So for any other statement that would exist in mathematics, we would only call it logical statements if it's a valid statement. Now, what do we mean by valid statement? The validity of a statement is the extent of truthfulness or falsity of that statement. Right? And this is true for any and every logical statement you have in mathematics. Right? So for the statement to be considered a logical statement, you must be able to verify if it is true or false. A statement in mathematics cannot be both of them at the same time. It is either true or false. This sets it out apart from just having an ordinary sentence and then having a logical statement. So let's see how it works. For instance, let's say you have that my uncle is a mathematician. For all intents and purposes, this statement is a correct statement as far as English language is concerned. However, in mathematics, this is not a logical statement. Let's look at it. This, of course, is our subject, and this is our predicate right here. Now, for this subject, you are saying my uncle. There is no reference to which of your uncles you are talking about. Number one, we don't even know if you have an uncle in the first place. Okay, if we assume that you have an uncle, we don't even know which of the uncles you are talking about in the other case, right? So our inability to point out specificness or the specific nature of your uncle in this sentence translates in it not being a logical statement, right? It's a statement in which you cannot verify the validity of what it's talking about. My uncle is a mathematician. Which of your uncles? Who is your uncle? Is it your uncle Ade or your uncle Timi or your uncle Toby? We have no idea which of these uncles you are talking about, right? So it's just a blank form of statement here, so it's not logical, right? So it cannot be verified if true or false, which is the basics of mathematical logic, right? Let's have another statement and let's see if we can verify this. We have that Ade is a student of maths department. Now, this is a statement as well, and then this is a logical statement, right? Because we have that Ade is a student of maths department. We have the subject in question, which is Ade, and we have the predicate, which is the maths department. In fact, we can always verify if it is true or not that Ade is actually a student of that maths department, right? We have our sample space, so to speak. So in this maths department, you can easily verify if Ade is actually a student of that department or not. In this case, we have a logical statement, right? So this is a valid statement, right? Because we can test for the validity of the statement. We can test whether it is true, that is Ade is a student, or it is false, so Ade is not a student, right? This is how simple statements stand for. Statements in which you can determine the subject and the predicate of those statements. Now, it doesn't do us any favor to write out mathematical logic in simple sentences or in English language forms. Up next is the various symbols or connectives, as we will call them, that can be used to translate all these sentences into their mathematical forms. So we have started with the basic framework of what logic stands for and the concept of simple statements. Now, for every simple statement you have, there is always bound to be an opposite fraction. In fact, you'll find out that in physics, there is a particular popular law that says for every action there is equal and opposite reaction. Similarly, for every simple statement, there is also an opposite statement. That opposite statement is what we term as the negative of that statement or the negation of the statement. So how does it work? Let's look at it first in terms of English language. Let's say we have this particular example. Jimmy is the best student in town. This, of course, is a statement. Jimmy is the best student in town. You have the subject, you have the object, you have the predicate as well, which are the key factors you have to look out for. Now, you now want to negate this statement, right? You are now going to say, you are trying to make sure that instead of you now saying Jimmy is the best student, you don't want to say this, you want to say the opposite of it. Now, if Jimmy is the best student, the opposite will simply be that Jimmy is no longer the best student in town, right? So, the negation will simply be Jimmy is not the best student in town. And that negates it, right? So if the original statement is saying Jimmy is the best student in town, the negation is saying Jimmy is not the best student in town. Let's look at the other one. You have that 2, 4, 6 is a set of integers, right? This is a statement, this is a valid statement, right? Because you have the subject, which is 2, 4, 6, in curly brackets, and then you have this predicate, which is a set of integers, right? You know what integers are? Integers are simply the set that contains the positive counting numbers, the negative counting numbers, and then the value of 0, right? Or the digit of 0. So you know that these values are in fact counting numbers, so definitely they are integers. Now you want to negate this statement. So you are trying to say that this statement is not in fact what it is, right? If this statement is true, as we have found out, then you are not trying to say that it's false. That's what the negation does, the opposite of that statement. So in that case, the negation will simply be that 2, 4, 6 is not a set of integers. And we have negated the statement. Right now, notice the similarity between these two statements. In both cases, the major thing we have added into it is this particular term here, not, right? Which is the easiest way for us to negate a statement. So when we have these two statements and we want to negate them, it suffices for us to just add the not value to the object of that statement, right? So we are saying that Jimmy is the best student in town. If it's no longer the best student, it means that Jimmy is not the best student in town. Or you say Jimmy isn't the best student in town. Similarly, if you come here and you say 2, 4, 6 is a set of integers, and you negate that, then it just means that 2, 4, 6 is not a set of integers, right? So this is how it looks like when you look at it linguistically. Back to mathematics where we are talking about, and in fact, mathematical logic, which is our concern. Similarly, you would have that for all simple statements, you can also represent their negatives or their negations in terms of math. So let's get to that. First off is we represent sentences or simple statements in terms of letters. So let's say, let P be a simple statement. So if P is a simple statement, what do we have? We have that. Then the negation of P, this is the symbol here. So this particular symbol we are bringing in refers to as the negation of P. So this means that we are taking P and we are translating it into its opposite. The negation of P is also a simple statement. And of course, you can agree with this because if you look at these negations, this negation is exactly also a statement as well, right? So there is no change. The only change is in the meaning carried in those sentences themselves. So if P is a simple statement, then the negation of P can be written as this sign and P, and it's also a simple statement, right? Now, these two things we have written now does not still make a lot of sense let's now talk about how to bring all these sentences down into mathematical sense. Now, the translation of logic into its basic mathematical form is through the use of what we call the truth table. Right? So the truth table, as the name implies, table, is just a tabular representation of the values of a simple statement. Now, if we remember from our definition of what a statement is, right, must be valid. Right? A statement must be valid, right? Is the extent of truthfulness or falsity of the statement, right? So a statement in which we can test for the validity is called a valid statement, right? And is either it's true or false. Similarly, there are two kinds of truth values. In the same vein, so for your truth values, your values can either be true or false. So for any simple statement you have, the truth value is either true or false. It cannot be both at the same time. It can only be one of them at the same time, right? If you look at this statement, you are saying Jimmy is the best student in town, right? If you look at this one, you are saying 246 is a set of integers. Now, if you look at this one, Jimmy is the best student in town. We have no idea what the town is, right? We only have the subject in clear terms, right? So, of course, we cannot test for the validity of this statement. It is a statement, yes, just like this one, but we cannot test the validity of the statement. Remember that even though we cannot test the validity of the statement, we can also still negate it. That is where English language comes in. However, for mathematical statements, they are statements in which you must be able to test their validity at all times, which is what this number 2 represents. This is a standard mathematical statement. In this case, you have 246 is a set of integers. Or in this case, where we said Ade is a student of the math department, right? So specifics are given. So in this case, 246 is a set of integers. This statement is tested to be valid, and in fact, it is a true statement, right? It's not just valid. We in fact can verify that it's a true statement because all these elements of this set here are in fact integers, which ensures that the entire set itself is a set of integers as stated. So it's a true value. And then if you look at the negation where you say 246 is not a set of integers, then if you look at this, this is obviously a false statement, right? Because if you say 246 is not a set of integers, the elements of this set are in fact integers. So if you are saying it is not a set of integers, then you're obviously telling a lie. So this is a false statement. What does that tell us? It tells us that if the original statement is true, then the negation is false. If the original statement is false, then the negation is true. So how do we translate this into truth value? Right? Remember that we are just dealing with a standard definition or a standard statement, which is P. P can only have the truth value true or false. So if P is true, the negation of P is false. If P is false, the negation of P is true. This is the truth value for the negation of P, right? And this is true for every single case. You can test it out for different math statements that you have and then write out their truth value to see if in fact the statement and the negation have opposite truth values. This brings us into the concept of truth table. Next, we'll now look at different other symbols, not just the negation symbol, but different other symbols and connectives that we use in terms of logic. So far, we have started with the concept of logic. We have also looked at the concept of simple statements, the negatives of simple statements, and how to translate them into truth tables, right? Let's now go a step further into connectives that we can use to attach or combine two or more simple statements together, right? So for the first connective we'll be starting with, we'll start with the disjunction. Sometimes you can just call them disjunction or call them disjunction statements. Either one is fine. Now what the disjunction does is that you are combining two simple statements, right? The combination of two simple statements with the disjunction symbol. And what's that disjunction symbol? It's called the logical OR, right? So this is the symbol that represents the logical OR. logical OR, right? So the disjunction statements use the logical OR to combine two statements together, right? So now we have more than one statement to deal with now. How will the truth values now look like? Remember that we have said that for a simple statement, there are two possible truth values, either it's true or it's false, right? But now we have two or more statements being combined together. What happens to the truth values? To calculate the truth values, we can use what we refer to as the family tree, right? So the family tree, or the logical tree in this sense, can be used to generate how many truth values you'd have when you have two or more statements being combined together. So let's do a simple sample. So for our logical tree, the very first thing to know is that the number of truth values runs by the formula 2 raised to the power of n, right? And 2 raised to the power n, where n is the number of statements, right? That's what we have, the number of statements. In fact, if you look at when n equal to 1, then this value will be 2, right? So number of truth value is equal to 2, right? Because that's 2 raised to the power 1, and you have just two values. That's true or false, which is what we showed when we did the truth table for the statement and its negation, right? We had just two values, true or false, and then the negation also had two values, right? We can translate this as head or tail, right? But in this case, head or tail is changed as true or false, right? So it's a two scenario situation, right? You can only have truth or false, head or tail, a simple scenario. There is no other side. It's just those two values or factors. So you have true or false for when you have n equal to 1, which we have seen with the simple statement. Now what happens when you combine two statements together? Now if you combine two statements together, it means that the number of truth values you're supposed to have is 2 raised to the power of 2, which is equal to 4. Right? So you have 4 truth values. So how do we do that? Think of it as when you are doing the family tree for coins as well. In this case, you now have true, false, true, false. Right? So these values will translate into 4 of them. And then if you read that, of course, these values will read as true, 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 false, false, true, and then false, false. Similar pattern, right? What have we done? This is what happens when you combine two statements together, which is what we are going to be doing for the disjunction statement. What if you have an elite scenario where you have, for instance, 3 statements combined together simultaneously? If you have that, that means you are having a scenario of n equal to 3. That's fine. In that case, the number of truth value will simply increase to 2 raised to the power 3, which gives you 8. And in this case, your values increase. So you have true, false, true, false, true, false, and then true, false. And then if you read all of this together, what would you have? From the beginning, true, 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 then true, true, false, then true, false, true, then true, false, false, then you have false, true, false, false, true, true, false, true, false, 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 true, and then false, 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 which gives you 8 exact truth value combinations. This will hold true for when you have a combination of 3 statements simultaneously. However, for disjunction statements where we are looking at the combination of 2 statements, n equal to 2 suffices for us. So now let's translate how it looks like in the table. Now, to do this, we must first and foremost get a very good definition of what disjunction statements are. Now, in this case, we are saying we have 2 statements, so let's P and Q be 2 simple statements. right? So now we have our statements. Then P logical or Q, in this case we refer to it as P or Q, is true if at least one of the two statements is true. This is the condition for disjunction statement, right? So the disjunction statement P or Q is true if at least one of the two statements, that is, if at least one of P or Q is true. So if one of them is true, then the disjunction is true. So in truth table terms, what does that translate into? We have P, we have Q, and then we are looking for P or Q. Remember that now we are combining two statements together, so our sample space comes here. Our logical space in this case comes here. So we have true, 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 false. This is how you read it. False, true, and then false, false. This is how you read the values from the logical tree. True, 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 false, false, true, false, false. This gives us our logical values. Now, P or Q is true if one of them is true. So in this case, both of them are true. That's beautiful. So we have a true case here. In this case, P is true. So this is true immediately, right? Because we need at least one of them to be true. So since P is true, doesn't really matter if Q is false, the disjunction statement is true. In this case, we have that what? Q is true, P is false. So this is true as well. But in the last case, P is false, Q is false. Both of them are false. So it means that the disjunction is false, right? The disjunction is true if at least one of them is true. This, this, this. But when both of them is true, then of course, when both of them is false, then the disjunction returns false. So this is the truth value for the disjunction statement. Now, let's look at another kind of combination statement we can have, and that's the conjunction statement. Now, the conjunction statement is represented by the logical AND, which looks like a caret. So, and of course, the logical AND, just like the logical OR, picks combinations of two simple statements, right? So in this case, it means that for the conjunction statements, we are combining two statements, so their truth value will be equal to 4. That is, the number of truth values they will have will be equal to 4. Now, what exactly is the conjunction statement talking about? First off, let's have two simple statements. And then P and Q, that's P logical and Q, so we just read it as P and Q, is true if both statements are true. So P and Q is true if both statements are true. This is the condition that backs the conjunction statement. So for its truth table, you have P, you have Q, you have P and Q, right? Don't forget the logical space, true, 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 false, false, true, and then false, false. Now, P and Q is true if both statements are true. Both of them are true in this case, so it is true here. In this case, P is true, but Q is false. So it is false there. In this case, P is false, Q is false, Q is true. One of them is already false, so it spoils the statement, becomes false. In this case, both of them are false, so obviously the conjunction is false as well. So, right? So the conjunction statement will only return a true value if both of the original individual statements are true in themselves, right? So this is how the disjunction looks like, this is how the conjunction looks like in terms of truth tables, right? And of course, you have a lot of basic definitions or basic sentences that exist that follow the patterns of connectives and the patterns of disjunction and conjunction, right? All these values remain true if you look at them logically. For instance, you say that he or she will win the grand prize at the relay event. Right? So we are just taking a blank definition. Okay, to make it a little bit relatable, let's use nouns in this case. So let's have Tolu or Funke will win the grand prize at the relay event, right? So we are picking two subjects now, Tolu or Funke, and we are saying that one of them, that's all he's saying, one of them will win the grand prize at the relay event. What does it mean? It means that if Tolu wins the grand prize, then we are good, because we have said that Tolu or Funke would win the grand prize in the first place. So if Tolu wins the event, that's beautiful for us. So it means that we have returned a true value for the entire statement. If Funke wins the event, then obviously Tolu cannot win the event anymore. So if Funke wins the event, then of course one of them is true already. So it means that the entire statement is true. So what now happens if Bola wins the event? Bola is the third person. You will find out that Bola is not Tolu, of course, and Bola is not Funke, of course. So since Tolu and Funke did not win the event because Bola won it, then this entire statement will return a false value, which is exactly what happens in this case. So if Tolu wins the event, beautiful, it returns true. If Funke wins the event, beautiful, it returns true as well. We have no problem with that. If we say Tolu or Funke will win the event, then we are assured that regardless of who amongst them wins it, it will return a true value. But if we now have an outsider, let's say Bolu, that now comes to win the event, then of course it will return a false value, right? So this is an example of how the disjunction statements works. Let's now tweak this sentence a little bit. Let's say we now talk about Tolu and Funke will win the grand prize at the relay event. Now we are saying that both of them, as a matter of compulsion, must win that grand prize at that relay event. That is a standard. So if Tolu wins the prize but Funke does not win the prize, then this statement automatically becomes false, because we are saying both of them must win it. Tolu and Funke will win the grand prize. So it is not enough for us to just say that, okay, Tolu actually won the grand prize at the relay event. Funke must also win it. It's not also enough for us to say Funke will win the grand prize. Tolu must also win that same event, right? So for this statement to return true, both Tolu and Funke must win that particular relay event itself, right? And this is what is exemplified by this truth table for the conjunction of statements. Now that we have looked at the concept of disjunction and conjunction, let's now move further into what we term as conditional statements. So we have looked at our first set of connectives, right? Connectives are simply symbols that combine two statements together. We have looked at the disjunction, we have looked at the conjunction. Let's now go on to the conditional statement, right? Now for the conditional statement, of course, we will still be combining two statements together. However, the position and order of those statements bear much more significance than before. Now let's look at what we are talking about. For the conditional statement, we can also call it the implication statement, right? And the symbol that guides this conditional or implication statement is the imply sign, right? Which is called the implies, right? Of course, this symbol is one of the most common symbols that exist in elementary or secondary school level maths. In fact, it's a symbol you would have seen before in this class or in this journey, and this is a symbol you will still encounter for much more time to come. Now, the conditional statement, which uses the implies symbol, has some significance of the statement as I mentioned. Now, first and foremost, let's define our two simple statements. They will say P implies Q, right? So P implies Q is what we term as the conditional statement. Now, before we write out the definition of the conditional statement, right, which just as we did it for the disjunction and the conjunction, in the disjunction we said that P or Q is true if at least one of the statements is true. In the conjunction case, we said that P and Q is true if both of the statements is true. Now, for the connective or for the conditional statement case, before we write out its own condition, let's first and foremost define the two statements in terms of their position. Now, P is the statement before the implication sign or before the implied symbol. Now, P is called the antecedent, or you can also call it the hypothesis, while Q is called the consequence, or you can also call it the conclusion, right? So the position of the simple statement is very, very important in the case of the conditional statement. The statement before the implication sign is called the antecedent or the hypothesis. The statement after the implication sign is called the consequence or the conclusion. So let's now go forward to define what the conditional statement in itself is. So P implies Q is true if the following conditions are satisfied, or if one of the following conditions are satisfied. So P implies Q is true if one of the following is satisfied, right? So whenever we are testing for the truthfulness of a conditional statement, we just have to pick each of these conditions one after the other. If it satisfies the first one, then it's true already. If it doesn't satisfy the first one, but it satisfies the second one, then it's true as well. So let's look at what these conditions are saying. The first condition is saying that both statements are true. The second condition is saying that both statements are false. Okay, so if it doesn't satisfy these first two conditions, there's a third condition which says the conclusion is true. Right? So the conditional statement is true if both statements are true, or both statements are false, or the conclusion or the consequence of the conditional statement is true. This is what is meant by a conditional statement being true. Let's now go further to explain or to show this by using our truth table. Do not forget that we are still working in line with two statements, right? So we are using the number of truth table to be 4. So we have P, we have Q, true, 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 false, false, true, false, false. These are values we have generated from our logical tree, and then P implies Q. Now, P implies Q is true if one of the following is satisfied. So let's look at the first row, true, true. Which of the following conditions does it satisfy? It satisfies the first condition. Both statements are true. So this is true. Let's look at the second row, true, false. Does it satisfy the first condition? It does not. Does it satisfy the second condition? It does not, because this is true and this is false. Does it satisfy the third condition? It does not, because P implies Q, so Q is the conclusion, and Q in this case is false. But for it to be true, the conclusion must be true, right? So in that case, this returns false. We move on to the third row, false, true. Does it satisfy the first condition? It does not. One of them is true, one of them is false. We can't move with that. Does it satisfy the second condition? It does not, because one is false, one is true. Does it satisfy the third condition? Yes, it does, because the conclusion, which is Q, is true. So this returns as true. We move on to the fourth rule. False, false. Does it satisfy the first condition? No, it does not. The first condition says both statements are true. It does not satisfy this condition because they are returning false, false values here. Does it satisfy the second condition? Yes, it does, because both statements are in fact false. So if both statements are false, then the conditional statement returns a value of true. This is what the conditional statement stands to offer. So the conditional statement is true if either both statements are true, or both statements are false, or the conclusion or the consequence is true. This has been represented in the truth table, right? So this is how the conditional statement works with the use of the implication statement, the implication symbol itself, which is this imply sign. Now, of course, the conditional statement that moves from P to Q is not just read as P implies Q, right? So if we say P implies Q, of course, we are just using the literal meaning of the sign. We can also read it in different ways. What this means in English is that P is sufficient for Q, right? So we can read this as P is sufficient for Q. It gets better. We can also read this as if P, then Q. If P, then Q. So if we don't read it as P is sufficient for Q, we can also read it as if P, then Q. Of course, we can read it as P implies Q. Or we read it as Q is necessary for P. Right? So these are different ways in which you can read the P implies Q symbol. P is sufficient for Q. If P, then Q. P implies Q, and then Q is necessary for P. This is our conditional statement. Let's now go a step further again and look at what we term the biconditional statement. So, we have looked at the concept of connectives. Connectives are simply symbols that connect or combine two statements together. We have looked at the disjunction, we have looked at the conjunction, we have also looked at the conditional statement, which we can also call the implication statement. Now let's look at another kind of statement, and that is the biconditional statement. The biconditional statement, right? And just as the name implies, it simply means we are going to be having two conditional statements being combined, right? So unlike the disjunction, the conjunction, or the implication, where we are simply combining two simple statements, for the biconditional statement, we can think of it more than just the combination of two simple statements. We can even go further to combine two conditional statements in themselves, right? And so let's see how the biconditional statement works. The first thing is the fact that the symbol it uses is this, right? So it's not just the imply, it also has the curve on the other side as well. This symbol is read as the if and only if symbol, right? IFF, or you read it in full as if and only if, right? So this is a complete mathematical symbol here, and it is used to simply express the relationship between two, of course, between two statements themselves. So, of course, let's look at it. The very first thing is that we must first have two simple statements. right? And of course, at this point, it's necessary to note that, of course, by the time you combine two simple statements together, your result will simply be a compound statement, right? Because in this case, we are just combining two statements. So in the case of the disjunction, in the case of the conjunction, in the case of the conditional statement, and in the case of the biconditional statement, we simply combine two simple statements together, and our result will obviously be a compound statement, right? So let's have P and Q as our simple statements. Then, in this case, P if and only if Q, right? So if I write this in English, what it means is P if and only if Q, right? P if and only if Q is true if one of the following is satisfied. Right? Just as in the conditional statement case. Now, in the first place, we are saying that for this to be true, both statements must be true. If it doesn't meet this criteria, then the second criteria is this: both statements must be false. These are the only two criteria that can be satisfied in order for P if and only if Q to be true, right? So if P if and only if Q would be true, then both statements must be true or both statements must be false, right? Now, this is just one way of verifying if the biconditional statement is true. Alternatively, P if and only if Q is true if P implies Q and Q implies P are both true, right? So P if and only if Q is true if P implies Q and Q implies P are both true, right? And let's try to combine this into mathematical logic. In essence, we are saying that P if and only if Q is exactly the same thing as me saying P implies Q, logical and Q implies P. This is true. Now, do not forget that this is essentially very, very correct. Remember that for the logical and connective is true if both statements are true. Those are the only conditions for the truthfulness of the logical and. So if you are saying the logical and is true, then both of the conditions must be true. If the logical and is true, then we are saying that the P if and only if Q statement is true. Now, the biconditional statement is also called the logical equivalence, right? P if and only if Q. Now, what exactly are we trying to talk about? This last line gives us a very, very clear and concise definition into the roles of P and Q. In this case, notice that when we started biconditional statements, we didn't go into analyzing P and Q as either antecedent or consequence. In that reason, the greatest reason for this is because P serves as the antecedent here and also serves as the consequence here. Q serves as the consequence here and also serves as the hypothesis here, right? So for the biconditional statement, the position of P and Q will swap, right? So P must satisfy his role as both hypothesis and conclusion. Q must also satisfy his role as both hypothesis and conclusion. This is why it's a biconditional statement. This is why we call it the logical equivalence, because whatever exists or is that holds true from left to right must also hold true from right to left, right? So left to right would be this way, and then from right to left would be this way. So if left to right is true, then right to left must also be very, very true. In essence, Q implies P is termed the converse of P implies Q, right? So we are simply moving the other way around. Instead of going from left to right, we have gone from left to right, we have verified that it's true. Let's now verify from right to left and see if it is true. If it is true, then it means that in fact we have a logical equivalence, which means that P if and only if Q is true. Let's now try to represent it in terms of our truth table. Now, don't forget that in all these cases, we are still talking about just two simple statements, P and Q, right? So if this is the case, then P will be true, 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 false, false, true, false, false. That's our first starting point, right? Now, what do we have? The very first thing we have is if we use this set of criteria, then P if and only if Q will be true if both statements are true or both statements are false. So let's look at the first row. Both statements are true, so this is true. Second row, one is true, one is false, so this is false here. One is false, one is true, so this is false here. Both of them are false, so this is true here, right? Following our conditions. Now let's try to use the second criteria. For this second criteria, which I'll represent by the red marker here, we are saying that it is going to be true if what? Both P implies Q and Q implies P are true. So let's do what P implies Q would be itself. Now if you look at P implies Q, what would you have? P implies Q is true. Remember the conditions. If one of the three conditions given is satisfied. The first condition for P implies Q is that both statements are true. If that is not satisfied, the second condition is the fact that both statements are false. If that is not satisfied as well, then the third condition is the fact that the conclusion is true. Now, for P implies Q, let's look at the first rule. True, true. We are good to go. So this is true. If you look at the second rule, we have true, false. From this statement, Q is the conclusion in this case, and Q is false. So obviously this is false. If you look at this, we have false, true. It doesn't satisfy the both statements. So both of them is not true, both of them is not false. Let's look at the conclusion. The conclusion is Q. Q is true. So this is true here. Right? Let's go to the last line. Both of them are false. So this is true here as well. Let's go for Q implies P. Follow the same pattern. Both of them are true. So we have true here. Both of them are not true. Both of them are not false. But true, false is what you have here. P in this case now becomes your conclusion. And P is true. So this means that this is true here. Now, false, true. P is your conclusion, don't forget. And P is false. So this is false here. Then false, false, both of them are false. So this is true. Now, the alternate definition tells you that what? This and this must both be true. So if both of them are true, then you have true returned. If one of them is false, one of them is true, then you have false. If one of them is true, one of them is false, then you have false again. If both of them are true, you have true. Right? So you see that whether you follow the first pattern or you follow the alternate pattern, your logical equivalence values will remain true so long as the conditions are satisfied. If you use in terms of the simple statements, then both of them must be true, both of them must be false. If you follow the statements of the conditional parts, for both conditional statements, both of them must be true. Once this is satisfied, then you have the values for your logical equivalence or for your biconditional statement. This represents how the biconditional statement works. And this is, in fact, values or statements that hold a lot of relevance in mathematics. Not just basic mathematics, but mathematical analysis, logic, as well as calculations of values, truth values, statement values, and other kinds of values that exist. This rounds up what we know as biconditional statements. Let's now move on to the next kind of statements we can have and how to calculate the values for that statement as well. So, as it stands, we have looked at the concept of logic as well as the concept of simple statements. We have also verified what the negation of a simple statement looks like, as well as how to represent this statement within a truth table. Now we have used that truth table to represent different kinds of combination of simple statements which we call connectives, and then we have used it to look at concepts like disjunction, conjunction, conditional statements, as well as biconditional statements or logical equivalence. Now let's look at the concept of contrapositive statements. Now, what exactly is the usefulness of the contrapositive statement? What exactly is the meaning of the contrapositive statement itself? Now, to generate the contrapositive statement, the very first thing, and is what holds true for all the other kinds of connective, is the fact that you must first and foremost still have two simple statements, right? So those two simple statements, the next goal would now be to negate those simple statements. So let's see how it works exactly. Now, do not forget that for conditional statements or implication statements, we have said that we can represent this as P implies Q, right? This holds true for any simple kind of case, right? For any given kind of simple statements you would have, the conditional statement is just represented that P implies Q. If P, then Q, or P is sufficient for Q, or Q is necessary for P, right? This is true in that scenario. Now, what happens in case of mathematics when the conditional statement is now proving difficult for us to work with? Of course, in terms of the truth value, you won't have that issue. All you just have to do is translate the values from the logical tree, get their truth, false values, and then work on them. However, it's not so simple when you look at the mathematical analysis themselves. This is analysis that is done at advanced level. So it now becomes important to represent this conditional statement in an alternate form, right? What alternate form can we have for the conditional statement that will still give us the same result we would have gotten had we solved the conditional statement itself? This is where we have the concept of the contrapositive statement, right? Now, the contrapositive statement works by first and foremost negating the values of the conditional statement, right? So, if we negate the values of the conditional statement, what would we have? We will have that, of course, what we are trying to do now is, so take that part again. So to get the conditional, to get the contrapositive statement, the approach we use is to first and foremost consider the basic statement. Now, if you look at the alignment in this conditional statement, we are simply saying that P is, of course, the hypothesis, right? And then Q is what? The conclusion. This is true for the conditional statement. Now, for the contrapositive statement, the very first thing we do is to negate the positions of these two simple statements, right? If P was the hypothesis, if we negate P, then it means that we have negated the position of P. So P would swap from being the hypothesis, and the negation of P would now become the conclusion. So what exactly are we saying? We are saying that the negation of P now will be the conclusion, and then the negation of Q will now be the hypothesis. This is the first big change we would have, right? The negation of P swaps position of P from hypothesis into its negative position, which is the conclusion, and then the negation of Q swaps the conclusion position into its opposite, which is the hypothesis conclusion. So the contrapositive statement is now denoted as negation of Q implies negation of P. This is exactly what we know as the contrapositive statement. In fact, P implies Q is exactly equivalent to not P implies not Q implies not P, right? P implies Q is exactly equivalent to not Q implies not P, right? So the conditional statement P implies Q, if it's proven hard enough for you to solve with this, is exactly the same thing as the contrapositive statement not P implies not Q implies not P. So what we're talking about, we are simply saying that to get the contrapositive statement, the individual statements are negated and the positions of the individual statements are swapped. negate the individual statements, and swap the position. This is exactly how we get the contrapositive statement. Now we are saying that both of them are equivalent. In essence, what it simply means is that the truth value of P implies Q is exactly the same truth value of not Q implies not P. So let's figure and see if that's exactly the case. Now, for P implies Q, remember the conditions. If both of them are true, then the implication is true. If both of them are false, then the implication is true. And if the conclusion is true, then both of them are also true. So let's write out the truth values. You have TT, TF, FT, and then FF. Then the implication statements will be true here because both of them are true. To be false here, of course, because the conclusion is false. It will be true here because the conclusion is true here. And then it will be true here because both of them are false. Now let's look at the contrapositive statements. Now for the contrapositive statement, the very first thing is, of course, we are still combining two statements together. So it means that the number of truth values we have is 4, right? But each of these ones are also individual statements in themselves. All right, so we'll start from P and Q and then find their negations. And then we will now move on to find the implication statement of the negation, which is the contrapositive statement. So for P and Q, don't forget this is TT, TF, FT, FF. The negation of Q means go to the Q column and negate the values you have there. Negation of T is F, negation of F is T, negation of T is F, negation of F is T. Do the same thing for not P. You have this as F, F, T, T. Right? Now that we have negated the values, let's now find the implication statements. Remember, both of them must be true for it to be true. Both of them must be false for the implication to be true as well. And then the conclusion must be true for the implication to be true. So both of them are false here, so this is true. The conclusion in this case is false, so this is false. The conclusion is true here, so this is true. Then both of them are true here, so you have true. Now if you compare this set of values here and here, you see that these values are exactly the same, right? So since these two values are the same, it simply means that the conditional statement is directly equivalent to the contrapositive statement, right? And this is a very, very important tool in mathematical analysis. Whenever mathematicians at higher level are trying to prove statements whereby using the conditional statement as it has is proving complicated, they can simply resort into using the contrapositive statement. In other words, they will take the conclusion and negate the conclusion and use it as the hypothesis, then see if that hypothesis, that new hypothesis, is now sufficient to get the negation of the former hypothesis as the conclusion. This is what mathematicians at higher level work with, and this is a very, very important tool in mathematical logic at high level as well. Now that we have looked at the concept of contrapositive statements, right, it's now essential for us to drop a simple trivia on how to read out the biconditional statements in full English language. Remember that what we have simply said about P if and only if Q is that we can read this as P if and only if Q, right? Or we read it as P if and only if Q, right? But this is seeming strenuous to read. In full English language, you can read the biconditional statements as P is necessary and sufficient for Q. This is the full English read of the biconditional statement P if and only if Q. P is necessary and sufficient for Q. And this holds true because you remember, as we said, that P if and only if Q is exactly the same as P implies Q, logical, and Q implies P, which means that P is serving the position as hypothesis and conclusion. Q is also serving the position of conclusion and hypothesis. They are swapping their positions. So if we say P is necessary and sufficient for Q, don't forget that if P was simply the hypothesis, they would have said P is sufficient for Q. If P becomes the conclusion, then we'll say P is necessary for Q. Since P is satisfying both conditions, then we can simply combine them and say that P is necessary and sufficient for Q. This is the full English read of the logical equivalence statement, right? And of course, you can translate it right from here. This means P is sufficient for Q and P is necessary for Q. This is just following the definitions, the English language read we had for the implication or conditional statements a while back. Right? So if P is sufficient for Q and then P is also necessary for Q, you can combine these two statements and say that P is necessary and sufficient for Q. In advanced maths, you would see situations where they will ask you what is the necessary and sufficient condition for so quantity to hold. Simply, they just ask you what is that logical equivalence that is satisfied for these conditions to simply hold. Now that we have gone through all the theory questions and how logic and their statements can be written and how to convert all these statements into truth values, let's now take the real questions on how to translate basic English language words into their logic forms, how to extract those logic forms, and then pick out what kind of statements are used and what kind of logical equivalence, if any, are working for those statements. We looked at the concept of logic, simple statements, the negation of those simple statements, as well as truth tables that we can use to represent the truth values of those statements, as well as the concept of connectives that combine two simple statements together to form compound statements, connectives which include the disjunction, conjunction, conditional statement, biconditional statement, as well as contrapositive statements. Let's now take drill questions that emphasize on these statements and how we can translate or solve these statements one after the other. Now, for our first drill question, we have to obtain the negation of the statement she scored more than 70%. So this is our statement right here, and our goal is to negate this statement. So let's first and foremost write it out. Let's give it a name. P is such that she scored more than 70%. Right? We can do something much more fun here. Right? We can convert this into set theory notation. Right? By converting this into set builder, we can have it as X. So we are representing her by X such that she scored more than 70%. Right? This works as set builder form, which is exactly what we have just said in English. Now, it makes it very, very easy for us to work with now. Right? So if we want to find the negation of P, it suffices for us to look at this set and then negate it. Right? If we want to negate this set, we can simply just multiply it by the negative. Right? So if we negate this set is saying that X is a value that is greater than 70%. If we negate this sign, don't forget that the core sign that guides this operation is the greater than sign, right? So just negate this. So we can write this as X such that X, if we negate the greater than sign, is less or equal to 70%, right? So what we have just done is, if she scored more than 70%, that means we are saying she scored maybe 71% or 70.5% or 80% or 85%. If we negate that statement, then we are simply saying that, okay, our value will no longer be more than 70%. If our value is no longer more than 70%, then our values would either be less than 70% or will be exactly 70%. She scored more than it in the first place. So if she scored more than 70%, then our negation values will not be up to 70% again, or at the very max, exactly 70%. Right? So the negation of P is such that X is less or equal to 70%. Now, let's translate this back in English. We have that negation of P is such that she scored less or equal to 70%. Right? Now, this is a better way of writing it in mathematics. Right? And of course, that does not mean that you cannot always start your reasoning by taking a blank negation of the original statement. If she scored more than 70%, English-wise, you can always negate this statement as you saying that she did not score more than 70%. Right? So this is a blank negation right here. English-wise, she scored more than 70%. So if you negate that, then you are simply saying that she did not score more than 70%. That's the opposite. Now, mathematics-wise, if she did not score more than 70%, what exactly did she score? If her score is not more than 70%, then it means her score is either less or equal to 70%, which is the answer we have gotten at this point. This solves our first two questions here. So all we just have to do is understand the question, which is she scored more than 70%, understand the parameters within that question, which is the fact that it is more than means that greater than, and then the mark itself. Right? So if we negate the greater than, then it means we are taking the less than. Right? So if we take the less than or equal to, then we simply have that she scored less or equal to 70%. Now let's move on to the secondary question. In this case, we have that we have two statements, or we have three statements in fact. The first one is saying a teacher is humorous. Q statement is saying a teacher is brilliant. R statement is saying a teacher is neat. Right? So a teacher is the subject there. A teacher. We are taking a specific teacher. So P is saying a teacher is humorous. Q is saying that specific teacher is brilliant. R is saying that specific teacher is neat. Now, we have to write this statement, no neat teacher is brilliant, as an implication statement, right? No neat teacher is brilliant. There's not a lot of things for us to work with here. However, the very first thing we can do is let's look at the statement and piece out the very big facts we have inside. If the statement is saying no neat teacher is brilliant, then you agree with me that if no neat teacher is brilliant, then it means that all the neat teachers we have are not brilliant, right? If none of them is brilliant, right? If none of the neat teachers are brilliant, it means that all of them are not brilliant, right? So we can simply say that neat teachers are not brilliant, right? So we have extended it now. So we see that, okay, fine, there's a negation coming somewhere, right? Neat teachers are not brilliant. Okay, so this is where the negation is coming from, right? So they are neat teachers, quite all right. However, they are not brilliant. Okay, we can still split this statement. What are the key concepts? The very first key concept we have is that we are taking teachers. Teachers are subject, right? The teachers are the subject part of the sentence here now. And what are the adjectives we are using to quantify or qualify these teachers? We are taking the fact that these teachers are neat, and then the fact that these teachers are brilliant, right? So how do we now expand using that concept? The very first thing we have is that we are saying that a teacher is neat, right? Because we are saying that they are neat teachers in the first place. So a teacher is neat implies that a teacher is not brilliant, right? So if we are saying neat teachers are not brilliant, then we are saying that the moment that teacher is neat, then it is not brilliant. The moment the teacher is neat, is not brilliant, because we are saying that neat teachers are not brilliant. So if the teacher is neat, then there is no way the teacher will be brilliant, right? So neat teachers implies that the teacher itself is not brilliant, right? So in essence, we can write this as if a teacher is neat, then a teacher is not brilliant. Simple and short, right? If a teacher is neat, then a teacher is not brilliant, because we have simply said that no neat teacher is brilliant, which means that neat teachers are not brilliant, right? So if that teacher identifies as neat, then that teacher cannot be brilliant. That is what we have gotten from our statement, right? So let's now piece it in terms of the statements we have. If a teacher is neat, look at this part in the first place. This part in the first place is exactly this, R, right? So we can write this as if R, then we have this part now. So how do we work with that? A teacher is not brilliant. Now remember that what we have here is a teacher is brilliant. So if we are saying that a teacher is not brilliant, it means that we are taking the negation of this statement that tells us that a teacher is brilliant. Right? So if a teacher is not brilliant, we are simply negating the Q statement. So this says that if R, then not Q, right? If R, that means if a teacher is neat, then not Q, a teacher is not brilliant. So if R, then not Q, the if then statement here is the sign for the conditional statement. So if this is the conditional statement, if then, if R, so it means that R is the hypothesis, and then not Q here is the conclusion. So it means that I can write this as R implies not Q as my final result, which is the implication statement that I have been required to write. So first and foremost, the very first thing is I've tried to pick the definition and expand it. No neat teacher is brilliant. Logically, if we are saying that no neat teacher is brilliant, it means that if we pick 1,000 teachers, so long as they are neat, they can be brilliant. That's what we are talking about. So no neat teacher is brilliant, which means that regardless of our sample size of neat teachers we have, none of them will be brilliant. So if we are saying none of them will be brilliant, then it means that all the neat teachers are not brilliant. So if the neat teachers are not brilliant, then we are saying that even if we pick one of those teachers and we say, okay, that teacher is neat, then that teacher in itself cannot be brilliant, right? So neat teachers are not brilliant. If we pick one of those neat teachers and, okay, yes, let's say in all these teachers we have Mr. Taiwo. Mr. Taiwo is neat, but then we have said that neat teachers are not brilliant. So definitely it means that Mr. Taiwo is not brilliant. So that's what we are talking about here now. So if a teacher is neat implies that a teacher is not brilliant, it means that if we even pick any of them, if a teacher is neat, if Mr. Taiwo is neat, then Mr. Taiwo is not brilliant, right? So if a teacher is neat, then a teacher is not brilliant. And then we take all of this and translate it back into our statement, which has the fact that a teacher is neat is the R statement, and then a teacher is not brilliant is exactly the negation of the Q statement. And this leads us to our implication statement here. Now, for our third question, we have given the converse. No, we have to give the converse of x plus 8 is less than minus 3 implies x is less than minus 5, right? So we have to give the converse of this statement, right? So let's first and foremost write the statement. X plus 8 is less than minus 3 implies x is less than minus 5, right? This is the implication sign here. So it means that this part here is the hypothesis and this part here is the conclusion. So let's name it as P, x plus 8 is less than minus 3, and then Q as x is less than minus 5, right? So we have P to be the hypothesis, Q to be the conclusion. So if we want to take the converse, don't forget that the converse of P implies Q is simply Q implies P, right? So if we say P implies Q as the original conditional statement, then the converse of that statement is simply the swapping of the positions of the hypothesis and conclusion, right? So Q implies P is the converse of P implies Q. If that's the case, then it means that If P was originally the hypothesis, make it the conclusion. If Q was originally the conclusion, make it the hypothesis, right? So in that case, the converse is then x is less than minus 5 implies x plus 8 is less than minus 3. And that solves the question. So the major key to do in this number 3 is to first and foremost identify the hypothesis and the conclusion, and then swap their positions to get the converse. That solves our third drill question. Now, for our fourth drill question, we have given the set of positive natural numbers. Let P be such that x is exactly divisible by 2. So this is the P statement. And then Q is such that x is an even number. Find the relationship between P and Q, right? So P is a statement that says that x is exactly divisible by 2, and then Q is a statement that says x is an even number. So let's see the relationship between P and Q. First and foremost, let's write what P is. X is exactly divisible by 2, and then Q is saying that x is an even number, right? So let's verify first and foremost. If we are talking about relationship between them, the easiest thing to verify first is the conditionality between the two statements, right? That is the first thing we'll check, right? So is there a case where one of them is an implication of the other? Is one of them an antecedent of the other? Is one of them as a consequence of the first one? Let's now check that out. If we say P implies Q, would we be talking about something very, very sensible if we say P implies Q? P in itself is this, which says x is exactly divisible by 2, and then Q in itself says x is an even number. So if we say P implies Q, it means that we are saying that x is exactly divisible by 2 implies that x is an even number, right? X is exactly divisible by 2 implies that x is an even number. In fact, if you read it out in maths or in English, it simply means that a number divisible by 2, a number exactly divisible by 2 is even. That's what P implies Q is saying, right? X is exactly divisible by 2 implies x is an even number. So a number is exactly divisible by 2 is even, right? Now, remember that for a mathematical statement, it must be valid, right? We can test the validity of this statement. We can pick any number, and we can check that if that number is exactly divisible by 2, would it also be an even number? We exactly know what we can call even numbers. Even numbers are simple numbers such that they are multiples of 2, first and foremost, and are also divisible by 2. So if we have a number exactly divisible by 2, then obviously it is even. So it means that P implies Q is true. Okay, that's the first part. What now happens when we take Q implies P? Now, Q implies P is now saying that x is an even number, implies that x is exactly divisible by 2. X is an even number implies that x is exactly divisible by 2. In basic English, what we are simply saying is that an even number is a number that is exactly divisible by 2. And then if we look at this, this is exactly the standard definition of what even numbers are. Remember that even numbers are, of course, in one dimension, numbers that are multiples of 2. But in the standard dimension, even numbers are numbers that can exactly be divisible by 2. So Q implies P is simply talking about the standard definition of what an even number is, which is that an even number is a number that is exactly divisible by 2. This simply means that Q implies P as well is true. So, if P implies Q is true, and Q implies P is true, what does that tell us about these two statements, right? So P implies Q is true, Q implies P is true. That means that the logical and that connects them is also true. And if that is true, we will look at this as converses of each other. Q implies P is the converse of P implies Q, right? If you remember from our logical equivalence, the logical equivalence is true if P implies Q and its converse are both true. That is, P implies Q and Q implies P are both true, right? So in essence, we are saying that P if and only if Q is true if P implies Q and Q implies P are both true, right? And this has been gotten from our analogy here. So both of these sets are true. Remember that for the logical and statement is true if both of the individual statements are true. So if this is true and this is true, then the logical and is true. Obviously, the logical equivalence is true. So if the logical equivalence is true, then we are simply saying that P is necessary and sufficient for Q. In essence, we are saying that P and Q are equivalent, right? P and Q are equivalent. So if we say P and Q are equivalent, is also the same thing as saying P is necessary and sufficient for Q. It's also the same thing as saying P if and only if Q. And what we are simply saying is that the conditional statement and the converse of that conditional statement are both true. If that is satisfied, then the equivalent statement, the logical equivalent statement will also be true. And then the simple statements themselves are equivalent. So it means that if you say a number, if you say x is exactly divisible by 2, it's the same thing as you saying x is an even number. They are both equivalent statements. This solves our final drill question. As it stands, we have looked at the concepts of logic. We have defined logic as the steps and procedures of trying to translate mathematical identities or situations into logically valid statements, right? And these statements are simple statements or compound statements. Compound statements are simply the combination of two or more statements or two or more simple statements, right? And all these statements are verified or validated with standard procedures and rules, right? A statement can only have the values of true or false. It cannot have the value of both of them. For those statements, you can also represent the values in those statements on a truth table. You can also combine two of these statements together to form compound statements by either finding the disjunction of those statements, the conjunction of those statements, the conditional statements that bind those statements together, the biconditional statements that bind both of them together as well, but while taking them as both hypotheses and conclusions, or the contrapositive statement that offers an alternate means of checking out conditional statements without passing out the roots of P and Q being stable values of antecedents and consequence. We have now gone through drill questions to try to explain and clarify the concept of logic and how to convert simple English statements into logical forms in mathematics. Now that we have done that, it's now left for you to go over this concept, read, reread, and resolve this concept till understanding is well and truly achieved. Thank you for the class and see you in the next lesson.
Hello there. I welcome you once again to your study path platform, where we look at a series in literature in English. In this topic, allusion, students will be exposed to different areas, one of which is the meaning of allusion. Another one has to do with the applications of allusion. Then, of course, we'll look at the types of allusion, talking about classical allusion, historical allusion, biblical or Quranic allusion, that's talking about religious allusion, and literary allusion. So each of these types will be discussed in details. At the end of it all, you'll be able to have confidence when you talk or speak about allusion. So join me in class as we dig deep into the innards of allusion. Thank you. Okay, welcome to class. In this lesson, we shall treat the topic allusion. Now, what is an allusion? What do we mean by the term allusion? Now, in a very simple term, an allusion is a casual or indirect or implied reference made from a particular person or thing or text to another person, thing, text, or place. I take it again. A casual or implied reference made from one text to another text. That is the simple definition of an allusion. Now, if that is the definition of an allusion, what then is the importance of making allusion? Why do we need to make allusion? The whole essence of alluding is one. And what is that? It is to foster a good understanding or a better understanding of the immediate subject matter or the immediate point of discussion. In other words, we are saying that the whole essence of making allusions is so that the immediate point of discussion would be better understood. That is the major reason we do allusion. In other words, we are saying that if I intend to understand a particular thing better, then I need to allude to something else that had talked about that thing in a simpler form or having a better presentation. That is an allusion. You see, where teachers teach a particular topic and they give examples. Examples too sometimes can be referred to as components of what? Of allusion. Why? Because the essence of giving examples during lessons is for the students to understand the content of the course better. So the whole essence of alluding or making allusions is to make the subject understand the point of discussion well enough. Hence, the need for making an allusion. So what are the characteristics of allusion? What are the features of allusion? Number one, it is an implied reference. Number two, it is majorly aimed at bringing about a better understanding of the immediate point of discussion. Number three, it is aimed at exposing your target audience or the learners to a different manner of approach to what now? To the main subject of discussion. So these are the predominant features of allusion. Having said this, we move on to the next subheading, and that's talking about types of allusion. Types of allusion. Types of allusion. So we shall take a look at four different types of allusion. So in no particular order, the first one we look at in this lesson talks about literary allusion. Literary allusion. Now, what do we mean by literary allusion? This is a type of allusion in which references are drawn from or made to different works of literature. Now, when we say works of literature or works of art, we mean these three branches of literature, which are drama, prose, and poetry. So if a writer makes an allusion to any work of art, whether a drama work of art or a prose work of art or a poetry work of art, we refer to such casual reference as what now? As a literary allusion. Now, we can break this into three different subtypes. So under literary allusion, we can also have A, dramatic literary allusion, prosaic literary allusion, and poetic. Now, dramatic LA means that writers make reference to or from works of art with respect to drama. Strictly drama. Strictly what now? Drama. But when you make reference to or from a prose work of art, it's called prosaic literary allusion. In the same vein, making casual reference from or to a poem is called poetic literary allusion. So putting these three together, we call them all together literary allusion. Why? Because it involves making casual or implied reference from or to a work of art in literature. Hence, we call it literary allusion. All right. The next type of allusion talks about religious allusion. Now, religious allusion, from the name religious, means we make implied reference from or to religious works of art, religious stories, religious texts, religious images, religious concepts, religious ideas, religious beliefs, and the rest of that. As far as it is based on a religion, you make allusion to it or from it, it becomes a religious allusion. And it can stem into different religions. All right? It could be making an allusion or making a reference from something that happened in the Bible days, or from the Islamic Quran, or from what we call the 7 books of Moses, or from different books by maybe those who practice Judaism or Buddhism and the rest of all of these. So the moment an implied reference is made from or to any religious work of art, or the religious books, or religious actions, or religious figures, or religious belief system, we call such allusion religious allusion. Okay. Number 3 type of allusion we take a look at says historical, or before that, let's look at mythological first. Mythological allusion. Now, what does this mean? From the word myth, we get mythological. So this is a type of allusion that involves making indirect reference from or to ancient works of art, such as the ancient Roman works or the Greek works of art, or events, happenings, characters, behaviors, belief system, norms of the ancient Roman work or the ancient Greek works. So when allusion is made to any of these works, the ancient Roman or the ancient Greek, we refer to such as a mythological allusion. He ran
as fast as Hermes, or he ran even more than Hermes. Hermes used to be one of the servants of the ancient Roman gods, now which of course extends into the Greek gods too. So when you use such an allusion, such an indirect reference, we talk about mythological allusion. Based on this, we can also refer to this kind of allusion as classical allusion. So you may refer to it as mythological allusion, or you want to refer to it as classical allusion, whichever way, whichever one, you are just on track. But the bottom line is it is mythological or classical if you make reference, you make indirect reference to or from various classical works of art with respect to the ancient Roman works or the ancient Greek works. It could be you're trying to make reference to one of their images, or one of their gods or goddesses, or one of their stories, or one of their characters, one of their actions, as the case may be. Any of these, provided it has a stem into ancient Greek or ancient Romance, then we call it what now? Mythological allusion or classical allusion. Now, the next type of allusion, which of course is last, talks about historical allusion. Historical allusion. Now, personally, I refer to this type of allusion as the hinge allusion. I'll explain why I said so. I usually refer to this type of allusion as the hinge allusion. Hinge because it is the only type of allusion that covers, all right, the other types of allusion. In other words, those other types of allusion tend to hinge on it, tend to depend on it, tend to have it as their support. Historical means you make indirect references from or to works of art that had long taken place or that had long happened from history, 1,000 years ago, 2,000 years ago, 5,000 years ago, gone by centuries and the rest of that. And because of that, it could either be literary, you could make an allusion to a work of art, maybe drama, prose, or poetry based on things that happened very long time ago, or you could make an indirect reference to a religious body, maybe something happened some years back, you make allusion to it for people to understand the present, or you make allusion to a classical work of art, ancient Greek works and ancient Roman works. So all these still talk about one thing, past events, and that brings under historical allusion. So you begin to discover that you will always find elements of history in each of the type of allusions. Hence, we refer to this one as the hinge allusion. In other words, all other types of allusion tend to find themselves in it. In other words, you cannot completely separate literary allusion, religious allusion, and mythological allusion from historical allusion. They all work together. In fact, some literati have claimed that there is only one main type of allusion, and that is historical allusion. And they go further by saying that this type of allusion, which is the main one, can be broken into subtypes, giving birth to literary, religious, and mythological or classical. And the truth is, in some way, they are correct, because you cannot fail to find the elements of literary,
religious, and mythological or classical allusion, you cannot fail to find them in historical allusion. But as I always say, for the purpose of the lesson of this class, we'll still refer to them as 4 types of allusion. In summary, we have been able to establish that allusion simply means making references. Now, what kind of reference do you make? You make casual or implied or indirect reference. Now, you can make reference from something, a text, a message, or you can make reference to something. But the most important thing is that when you make reference, ensure that it aids a better understanding of the immediate point of discussion by the target audience. They need to, in fact, they must understand that particular thing you are trying to explain the moment you make an allusion to that thing or from that thing, as the case may be. So that's the essence of making an allusion. Then from there, we moved into looking at the features or characteristics of making allusion. What are the things involved in making an allusion? We said, number one, it is meant most importantly to foster a better understanding of the immediate point of discourse. Yes, the moment that first purpose is defeated, there's no point. It is no longer an allusion. It is no longer an allusion. Then the next feature we mentioned, we said it must be a reference. It must be a reference. It could be direct, so it could be indirect reference, but when you call it casual reference, but it must be a reference drawn from or made to. Okay, so that's talking about the features of allusion. Then we moved into looking at the different types of allusion, where we mentioned 4 types. We talked about the literary allusion, which says that you make reference, you make casual reference from or to different works of art in literature. Now, these works of art may be drama. There we'll talk about dramatic literary allusion, or prose, prosaic literary allusion, or poems, talking about poetic literary allusion. Then from there, we moved into looking at the next type of allusion, which we referred to as religious allusion. We said it is religious because you make casual reference from or to different happenings in the days of the Bible, or you can pick some from the Islamic Quran, or you can pick some from some books they call 7 books of Moses, or from other religious, Judaism, Buddhism, and the rest of all of these. So when you make reference to any of these, provided it's a type of religion, it becomes a religious allusion. Then from there, we moved into looking at the next type of allusion, which we referred to as mythological or classical allusion. Here we said that you make reference, casual reference actually, to different classical works of literature, most especially talking about works of art as concerning the ancient Roman or as concerning the ancient Greek works. So when you make allusion to any of these 2 works, you have made a kind of allusion we call mythological or classical allusion. Then lastly, we moved into looking at the 4th type of allusion, which we referred to as historical allusion. Now, I said that this type of allusion can also be called hinge allusion. Hinge because it's more like a stronghold that holds the other 3 allusions. In other words, we said that each of the other types of allusion, talking about literary, talking about religious, and talking about mythological, tend to have their different elements contained in the historical allusion. In what sense? When you talk about literary allusion, you make allusion to different works of art, either poem, either prose, or either drama. These talk about events that had long happened, not happening at the moment. So there's a trace of history, a trace of past events in it. Another one can be talking about religious, past events. Days of Bible, there's this what they call my book of Bible story. These are past events. You make allusion to them, it is still talking about what? A trace of history. Another one could be mythological. All of these acts, gods, goddesses, as pertaining to the ancient Roman people and the Greek people, all of these still talk about a trace of what? Past events. So you see that each type of allusion has a trace of history in it. Hence, we call the historical allusion hinge allusion. Once again, it serves as a stronghold or as a hold for each of the other types of allusion. At this juncture, we call it a day for this lesson. So after this timeout, I'll give you, as usual, some drills to work on. As I always say, they are not to test, but they are to prove your understanding of the content of the lesson. Until then, keep studying. Thank you. Okay, so we are welcome to the next session, and that's the drills on allusion session. Now we have the following questions. It says select the most suitable answer from the options lettered A to D for each question. Number 1, dash is the implied reference made to or from another work of art. A, reference. B, allusion. C, exemplification. D, illustration. So the answer here is B, allusion. So we said that allusion is the implied reference made to or drawn from another work of art. So our answer there is allusion. Number 2, which of these types of allusion has its elements in the other types? A, religious allusion. B, literary allusion. C, historical allusion. D, mythological allusion. So of course the answer here is C, historical allusion. Then we'll move to the next one, and that's question number 4. When an indirect reference is made to events in the Bible or a Quran, such is called dash allusion. A, Bible. B, Quran. C, religious. And D, holy book. So the answer is C. It's called religious allusion. The last question here says, allusion can also be called an implied reference. True? False? I cannot tell. Partially true. It's of course true. We can also refer to an allusion as an implied or casual or indirect reference. So score yourself individually and let's see how well you have fared in the drills on allusion. So we'll round it off here at this point and we'll move on to our next lesson. So see you in the next lesson. Thank you.
Welcome to another government class at your study path. In today's class, we'll be looking at Public Administration 1, which is Civil Service. In today's class, we want to know the meaning and how to define the term civil service. We'll be looking at the features of civil service. Also look at the functions of civil service. We'll also look at some of the factors that can hinder the effectiveness of civil service in Nigeria. Then we'll also look at Civil Service Commission. Look at the functions of Civil Service Commission. All this will be discussed in today's class under Public Administration 1. Join me in the class for more information. Thank you. Welcome to today's government class. The topic we're having today is Public Administration 1. Okay, under Public Administration 1, we'll be looking at the civil service. So it means that we have Public Administration 1, Public Administration 2, and Public Administration 3. So under Public Administration 1, we'll focus on civil service. Once we get to Public Administration 2, we'll focus on public corporation. And the last one, Public Administration 3, our focus will be on local government administration. But for today's class, our focus is mainly on civil service. So in this teaching today, we'll be looking at what civil service is all about, talking about the meaning of civil service, talking about the features, the functions, and how it's being controlled, and those things that hinder the effectiveness of civil service in Nigeria. So the first on the board is for us to know the meaning of what? Civil service. Civil service can be defined as a body or department of the executive arm of government, which is vested with the responsibility of planning and implementing government policies. So that's just the definition of what? Civil service. Let's write on the board. So civil service can be defined as a body or department of the executive arm of government vested with the responsibility of planning and implementing government policies. Now, if we look at the beginning of our government, we mentioned executive arm of government. When we talk about government as an institution of the state, that is an organ that formulate and implement government policies. So this civil service is just like what? A department or a body under the executive arm of government. So all this body or department that are under the executive arm of government that we call the civil service, those bodies there are called what? The departments are called what? Ministries. Okay, the ministries we're talking about, just like the way we have the Ministry of Finance, the way we have Ministry of Education, the way we have the Ministry of Health, the Ministry of Aviation, and so on and so forth. Okay, so we're talking about ministries. This body or department are referred to as what? Ministries. Okay, I'm giving you some example of the what? Ministries that we're talking about. It is important to know that in Nigeria, okay, we have 44 ministries, and each ministry is headed by a minister. For example, do we have the Ministry of Education? So the head will be what? A Minister of Education. The way we have the Ministry of Agriculture, the head will be what? A Minister of Agriculture. The political head of the civil service is the minister. Okay? The way we have the political head, we also have what? The administrative head. Okay? So the political head of the civil service is what? The minister. At state level, we can also have what? The commissioner. I'm going to explain. We also have what? The commissioner. We can have the minister, we can have what? The commissioner. Why do we have these two on the board? Okay, the civil service as a whole can be subdivided into what? Federal civil service and what? State civil service. So if you are looking at the political head for the federal civil service, we are mentioning minister. And if we look at the political head when it comes to what? The states, then our focus is on what? The commissioner. We can have a lot of commissioners irrespective of what the state we are talking about, but we have only what? One minister. There's only one minister of education, but we have several commissioners of what? Education, based on the policies of each state. Now, then we can also look at, like I mentioned, we have the political head. Also, we have what? The administrative head. So the administrative head is the what? The Director General or the Permanent Secretary. Okay, some refer the administrative head as well, Director General, which is the same as well, the Permanent Secretary. So looking at the meaning of what? Civil service, we also have to understand that the worker, the personnel, don't forget, it says the department of the what? Executive arm of government vested with the what? The responsibility of planning and implementing government what? Policies. For those policies be what? Planned and what? Implemented, they should be in place of what? Personnel. I'm talking about workers that will make it what? All those policies to be what? Implemented, okay? A worker in the civil service is known as a civil servant, okay? Then, civil service and public service is not the same thing, okay? Civil service is aimed towards what? Planning and implementing government policies, while public service, that is under public operation, public service is aimed towards what? Providing essential services for the people. Okay, so we can as well say that civil service differs from public service in terms of condition of work. In terms of what? Condition of work. In terms of what? Condition of what? Work. The condition of work we're talking about here, we're looking at the area of the service they rendered, okay? The service rendered by civil service is planning and implementing government policies, while the service rendered for public service is providing essential services. After knowing all this, then the next thing we should know or we should talk about is the features of the civil service. Features of the civil service. We have 6 major features of the civil service, and these features talks about what civil service is all about. So the first we have on the board, I'll first list it. I will take it one after the other. The first feature, which is the characteristics of civil service. I can make use of features. I can also call it what? Characteristics. It's still the same thing. Okay? The first one is what? Impartiality. Impartiality, that is the first feature we should know under the civil service. Impartiality. The next one, which is what? Number 2, is permanence. Permanence. Number 3 is neutrality. Okay, let me call it anonymity first. Anonymity. Number 4, neutrality. Number 5, expertise. And number 6, merit. So all these are the 6 important characteristics or features of civil service. The first one is impartiality. The second one is permanence. Number 3 is anonymity. Number 4, neutrality. 5, expertise. And 6, merit. So these are the major features or characteristics of what? Civil service. Then we're looking at what each implies, what each is talking about. Looking at impartiality. It is the worker. Don't forget, I said a worker in the civil service is known as what? A civil servant. So as a civil servant, you must be just, loyal, and faithful to the government. Now, what do you understand by the word just, loyal, and what? Faithful? That is, as a civil servant, okay, you must be upright in your doing. You must be upright in discharging your duties and your functions as may be required. Okay? You should shun all forms of tribalism. It should shun all form of nepotism. It should shun all form of sectionalism. It should be up and doing. So that is what this first characteristic is talking about, impartiality. So we'll be looking at permanence as another important feature of civil service. So when we talk about permanence, we're looking at the length of stay in the civil service. That is, workers enjoys what we call job security. Job security in the sense that they have a fixed time to stay in office. Like according to Nigeria Constitution, the civil servant, that is the worker in the civil service, are liable for a term of 35 years in office, and they must retire at the age of what? 60 years. So that is the permanence we're talking about, what? The civil service. That is for a long time. Workers enjoy what? Job security, and because they enjoy that, they will be able to contribute their own what? Quota to the effectiveness and efficiency of the what? Administration. Now we've just looked at permanence as another feature of civil service. The next one we have is what? Anonymity. The word anonymity, we can relate it to what we call anonymous. When we say something is anonymous, or you want to remain anonymous, you are invariably talking about you don't want to reveal your identity or hide certain things about yourself. It can be your name, where you're coming from, your personality, and you don't want others to know. Also, we can relate that ideology to the feature of civil service under anonymity. Now, what is anonymity? Anonymity simply means that civil servants can be seen but must not be heard. So that's what anonymity is talking about. That civil servants, okay, you can be seen in public, but you don't have to interfere to public issues. It's not your duty to do that. All public issues are to be attended to by the minister. Okay? Then we have another one, which is what? Neutrality. Still on features of civil service. Neutrality. Neutrality, from the word neutral, it means that as a civil servant, that is a worker in the civil service, you are not expected to partake in contesting for political positions. That is, as a civil servant, you have to declare yourself non-partisan. You declare yourself non-partisan. Okay, that is, you cannot contest for election unless you want to resign from the civil service and go into what? Politics. For the meantime you are there as a civil servant, you have to adhere to the rules and regulations. So if you want to go into politics or you want to go into political activities, then you are expected to what? Resign. That is what neutrality is talking about. So we look at the next one, which is what? Expertise. Number 5, expertise. Expertise is another important feature of civil service. Expertise implies that over time, due to the number of years, okay, civil servants spend in office. I mentioned the other time that 35 years in office and retire at the age of 60 years. So civil servants becomes more professional, becomes more efficient in discharging their duties and responsibilities, which in return improve the smooth administration of the civil service. So that is what expertise is talking about. Then we look at the next one, And which is the last one? Merit. We look at merit, which is what? The last one. Merit. Merit is talking about how civil servants are recruited or employed into the what? Civil service. That's what merit is talking about. 6. Merit. So that's what the merit implies. That workers are recruited into the civil service based on what? Educational what? Qualification, which may include, that is AG, might be O level, that is ordinary level, talking about your SSC. We have the NCE, that is the Nigeria Certificate in Education. We have the Ordinary National Diploma, that is OND. We have Higher National Diploma, which is what? HND. We have Bachelor of Science, BSc, Masters of Science, MSc, and so on. All these are required qualifications, okay, that are needed in the world civil service. So now the next one, which is the next subtopic we'll be looking at under the civil service, is the structure of civil service. Structure of the civil service. So this structure is arranged in hierarchical order. That is, it is arranged based on hierarchy. That is, from the highest class to the what? To the lowest class. Okay, that is how we arrange the what? The structure. So the first one, which is the highest, that is the highest, okay, is the what? The administrative class. Is the what? Administrative class. That is the highest. Administrative class. Then follows by professional class. Professional class. Then number 3, executive class. Number 4, clerical class. Number 5, we have the managerial class. Managerial class, also known as manipulative. Manipulative, also known as auxiliary. Auxiliary class. So all these are the structure of the civil service. Don't forget that the structure is based on hierarchy, that is hierarchical order, from the highest to the what? To the smallest. The highest class is what? The administrative class, while the lowest class is what? The managerial class. Okay, the class that is responsible for the planning and implementation of government policies is the what? Administrative what? Class. Okay, why this class is meant for what? The execution of those what? Government policies. And all these are for what? Smooth running of the what? Administration. Functions of the civil service. In our class today, we're able to look at the meaning of civil service. Okay, we said civil service is a body or department of the executive arm of government vested with the responsibility of planning and implementing government policies. We also mentioned that it's subdivided into federal and state civil service. What we talk about the political head being the minister or the commissioner. If it's at the federal level, it's called the minister, and if it's at the state level, it's referred to as what? Commissioner. I mentioned that we can have many commissioners, but we can only have what? One minister. Okay, we talk about the administrative head. The administrative head being the permanent secretary, or call it director general. I also mentioned that a worker in the civil service is known as what? A civil servant. Then we'll talk about the features. So we have 6 features, which are number 1, impartiality, number 2, permanence, number 3, anonymity, number 4, neutrality, 5, expertise, and the last one, merit. And the last one, merit, suggests that or implies that workers are recruited into the civil service based on their educational qualification. It's not based on the art of favoritism. It's not based on the art of tribalism. It's not based on whether you know someone from the top. That is out of what? Favoritism. It's based on educational qualification. Now we're looking at the functions of what? The civil service. The first one there we have on the board, formulating, planning, and implementing government policies. That is the first one. Number 2, advising the government. It's the duty of the civil service as a whole to advise the government on an aspect or on the thing that will assist in the growth and development of the civil service, which will in turn promote economic growth and development. Okay, they can advise the government. Number 3, drafting of what? Bills. Okay, they can draft bills, okay, on behalf of their ministry, which will in turn be sent to the what? To the legislative house to be passed as law. So they also help in what? Drafting of bills, things that they say that is important, that they want to make it to what? To be part of what? The law. Okay, drafting of bills. And when you say bills is just like a kind of what? Motion race on things that they want to, on things that they would like to be what? To make it to what? More of constitutional. A bill has not become what? A law until it passed through all the 5 stages. Talking about the first reading, talking about the second reading, the committee stage, the third reading, and the assent stage. So a bill is not what? A law. They can draft bill, which will be in turn make law through the what? Legislative process in the country. Okay. Number 4, okay, they make bylaws. These bylaws have the backup of what? Parliamentary backup. They make bylaws which are expected to what? Be obeyed and be what? Followed. Okay, anyone that disobey or do not follow those bylaws will be punished according to what? To the law. Okay, the last one, number 5, they inform and educate the people. It's the duty of the civil service as a whole to inform and what? And educate people. Can be a form of what? Awareness. Okay. Now let me give you one example. Talking about the time when there is this pandemic called COVID-19. Okay. It's the duty of the Ministry of Health. Okay, to go to all mass media houses, talking about the television, the radio, and what? And publicize, okay? All those control and prevention of that diseases. Okay, through that, they have been what? Informing and what? Educating the people. The goal here is what? Enlightenment. Public what? Enlightenment. So all these are what? The major functions of the civil service. Factors that can hinder the effectiveness of civil service in Nigeria. I will list everything that I will be explaining one after the other. Okay, all this we have on the board are factors that can hinder the effectiveness of civil service in Nigeria. Okay, on the board we have the first one, which is what? Political interference. Okay, political interference can be as a result of what? Political instabilities in the world, in the country, whereby most of the time the military will just take over the affairs of what? Of governments, and before you know it, another government will what? Will emerge, and before you know it, another government will what? Will emerge, due to the inconsistencies, okay, in the affair of civil service, due to what? Political what? Interference, it limits the effectiveness of the civil service in Nigeria. Number 2, which is the second one, we have lukewarm attitude of what? Workers. We're looking at the lackadaisical approach of worker towards what? Work. They believe that is a government work. At the end of the day, they get paid. If they do not do it right, no one will know. All these things are what is leading to what? Ineffectiveness in the world civil service as a whole. The next one is what? Number 3, low incentives. Okay, workers are not well paid as they deserve. Okay, that can bring about laziness and unseriousness on the part of what? Workers. Number 4, bribery and corruption. Bribery and corruption. Some top officials are bribed in order to get their people into the world civil service, and which in return will lead to what? Ineffectiveness in the civil service as a whole. Red tapeism. Another name for red tapeism is bureaucracy. Bureaucracy is talking about the complexity of protocols one needs to follow in order to get things done. Now, for instance, you want to meet with the permanent secretary. You have to write letter. You have to be given a particular date. And before you know it, all these things can delay what? Decision making. Now, bureaucracy now will not in turn lead to what? Of course, slowness of what? Action. And when there is slowness of action, that means nothing like effectiveness. Okay, bureaucracy is talking about slowness of actions to the what? Due to the complexity of protocols civil servants have to what? Follow to get things done. The last one, which is number 6, tribalism, nepotism, and favoritism. All these 3 still talking about granting undue favor. Granting undue favor. You are giving out favor to someone that does not what? Deserve it. And don't forget, one of the features of civil service is what? Merit. Workers should be recruited into the organization based on educational qualification, not based on tribalism, not based on nepotism, and not based on favoritism. Control of the civil service. Number 1, Civil Service Commission control. That is the first one. Number 2, we have Ombudsman. Ombudsman, which is also known as Public Complaints Commission. Public Complaints Commission. That is Ombudsman. Public Complaints Commission. Number 3, we have hierarchical, talking about hierarchy now, hierarchical structure control. Hierarchical structure control. Number 4, we have executive control. We have executive control. Number 4, we have executive control. Okay, number 5, we have legal or judicial control. Legal or judicial control. Number 6, we have parliamentary control. Parliamentary control. All this we have on the board are the control of civil service. Okay, the first one we have here is Civil Service Commission control. Now, what is Civil Service Commission? Civil Service Commission is just like an independent body established through an act of what? Parliament to recruit workers into the civil service, to promote them when the time arises or when the need arises, to transfer them, to transfer them from one place to another, also to discipline or dismiss them when the need what arises. All these are what? The duties of what? The Civil Service Commission. So they have the control in terms of recruitment, they have the control in terms of transferring, they have the control in terms of discipline or dismissing disobedient workers. Okay. The next one is what? Ombudsman. Ombudsman is the same as Public Complaint Commission. Ombudsman is the same as what? Public Complaint Commission. Okay. Workers lodge their complaint of maladministration to the department called what? Public Complaint Commission. Any form of inefficiency or maladministration, those complaints are lodged to Ombudsman. We have the hierarchical structure control. Now, when we talk about the word hierarchy, hierarchy as used under civil service is talking about how the civil service is being what? Structured in terms of from the highest in position and to the what? To the lowest position. So don't forget, and I mentioned that the highest position we have in the civil service is the what? The administrative class. So the administrative class can what? Can summon the professional class. The professional class can summon the executive class. Executive class can summon what? The clerical class. While the clerical class can summon what? Managerial class. That is the what? The hierarchical structure control. The next one is what? Executive control. Now, executive control is the control based on implementation and formulation of what? Policies. Don't forget, the ministers, being the political what? Political head, are appointed by the president of the country, which is now what? Which all these ministers are now what? Screened by the legislative house, talking about the National Assembly. So the executive control there is what? The control the president have to appoint ministers, which will be what? Screened by the Senate. The next one is what? Legal/judicial control. Talking about courts. Courts. Now, court can have what? A control on what? The civil service. Because civil service is made through what? An act of what? Parliament. That is constitutional. And anything that is constitutional in Nigeria is not above the law. The last one is what? Parliamentary control. Talking about the legislative house. The power to screen ministers, the power to summon them, the power to interrogate them, and the power to screen and what? Remove them as well, if they are not what? Effective. So all these are what? Control of the civil service. Civil Service Commission is an independent body established by the government through an act of what? Parliament to ensure efficiency and effectiveness in the civil service. So this is seen through the functions and duties. So what I have here, talk about the meaning of what? Civil Service Commission. Okay? Civil Service Commission can be defined as an independent body established by the government to ensure effectiveness and efficiency in the smooth running of the civil service. And this is seen through the functions and duties. So that will now take us to what? The functions of Civil Service Commission. Functions of Civil Service Commission. We have recruitment. Recruitment, that is, we can use the word recruiting of workers. Recruiting of what? Workers, that is the first one. They recruit workers into the civil service based on merit. And the merit we're talking about is based on educational qualification. Okay? Number 2, retirement. That is retiring of workers. Retiring of workers. Okay, workers recruited are expected to stay in office for a period of 35 years. Okay, and don't forget, when we're taking the lesson, I mentioned that at the age of 60 years, okay, workers are going to what? Retire. Okay, to have new intake. So retiring of what? Workers. Number 3, we have discipline, disciplining of workers, disciplining of workers, disciplining of workers. Number 4, dismissal, dismissal of erring workers. The word erring here means what? Workers that are disobedient, workers that are not law abiding. Okay, workers that they have gone against the what? Rules and regulation of the civil service. So they have the power. The civil service commission have the power to what? To dismiss them, to fire them. Number 5, transferring of workers. We have transferring of workers. So due to promotion, workers can be transferred from one department to another in order to give their own quota to ensure the growth and development of the civil service. So number 6, we also have efficiency. Efficiency and integrity. So the Civil Service Commission are expected to what? Ensure that civil servants are efficient in their duties and responsibilities, and also promote the integrity of the civil service at large. Okay. Number 7 is promotion. They promote workers. Promotion, and this promoting. That means promotion of workers. Promotion of workers. So we have different levels. We have those that we place in level 1, level 2, till you get to about level 16. So they can promote what? Workers from one level to another. Also, still based on what? Merit. Workers will have worked for it through their rendering of services and through their educational qualification. So all these are what? The major functions of Civil Service Commission. We started the class by looking at the meaning of civil service. Then we move to features of the civil service. Then we talk about structures that we have in the civil service. Then we also look at functions of the civil service. Then we explain better on factors that can hinder the effectiveness of the civil service. Then we'll move towards control of the civil service. Under the control, we'll also look at another important aspect, which is what? Civil Service Commission. Then we have the functions of Civil Service Commission. So I'll be giving you class evaluation now on some important questions they can ask you in your examination. So we have objective questions on civil service. So we have 5 questions on the board to evaluate ourselves to know whether we are following or not. Okay, the first on the board, the political neutrality of civil servants implies that we have the options. Option A, are not allowed to join any organization or group. B, have no dealings with politicians. C, are not allowed to be involved in partisan politics. D, are not allowed to vote. So the right answer here, I know you have tried your best, the right answer here is are not allowed to be involved in partisan politics. So which of the features is talking about not involving in partisan politics? That is neutrality. Civil servants are expected to be what? Neutral. That is not involved in what? Partisan politics. Okay? Except they will what? Resign. Okay, if they resign, they cannot what? Go into what? Politics. The next one is what? Number 2. The idea of making the civil service permanent, neutral, and anonymous is to, yes, the right answer here is enhance efficiency in administration. That is the right answer, to enhance efficiency in administration. The goal of civil service is to ensure that there is efficiency and what effectiveness played on the part of civil servants. Number 3, the highest grade in the civil service is known as, this question you can interpret it as the highest class in the civil service. And the highest class is what? The highest class is administrative class. Number 4, a key characteristics of the civil service, that is, all these are these options now. One of it is what? The feature. So which of the following is talking about what? A feature or characteristics of what? Civil service. The right answer is what? Merit system. Talking about permanence being a feature, impartiality, we're talking about neutrality, we're talking about expertise, we're talking about anonymity. So the right answer is what? Merit system. The last one, which is number 5, the appointment, promotion, and discipline of civil servants are the responsibility of, now look up, the last topic treated there is what? Civil Service Commission. So what's the right answer? The right answer is Civil Service Commission. So with these 5 questions, we're going to bring the class to an end. So thank you and have a nice day.
Hello students, this is your English language study path and I'm pleased to have you. Now let's look at the topic, adverb and types. Now what is the definition of an adverb? And what are the different types of adverbs? How do you identify an adverb in a sentence structure? To learn more about this, I would like you to do something for me. Kindly join the class while I get to explain to you majority of what is required. I will be waiting for you. All right, let me explain in detail, class, about this particular topic, adverbs and the different types of adverbs. Now, what exactly is an adverb? Now, an adverb is a word which modify 3 things, basically. And what are those 3 things? A verb, that's the first thing, an adjective, and other adverb in a sentence. When looking at an adverb, your attention should be on an adverb modifying a verb as the first thing, an adjective, and other adverb in a sentence. 3 basic things. And there are different types of adverbs, okay? There is an adverb of time, an adverb of place, an adverb of frequency, an adverb of manner, an adverb of concession. There are many of them, and I'm going to explain each of them one after another. Now, if this is understood about the different function that an adverb performs, an adverb modify a verb, an adjective, and an adverb. And there are different ways to which you can notice an adverb in a sentence structure. And what are those different ways? Basically, adverb ends with ly, okay? So when you add an ly to an adjective, you will definitely form an adverb. In a case of where you have the word, you have smart, for instance, okay? This is an adjective, the word smart. Definitely, by the time you add ly to the word smart, you would form exactly as what? As smartly, which is what? Which is an adverb. There are other examples to that. Like you have a word like active as an adjective. The moment you add ly to active, you would form actively, which is an adverb. You can use them in a sentence. Let's look at the different types of adverb in a sentence. The first aspect is an adverb of time. What do you think that an adverb of time will indicate? An adverb of time shows the particular time or when an action is performed. An adverb of time helps to indicate at what time or when exactly did the action happen. That's an adverb of time. And before you could use that, there are certain words that are very important to occur, and which are the word like when is very important, the words like soon is very important to indicate time. You can even have whenever, you can even have after, and so on. These are examples of adverb that helps to indicate time. You can make a sentence with that. He arrived. He arrived when it was late. He arrived when it was already late. So what do you have? He arrived when it was already late. That's a full stop to that. Trying to make a sentence for you to understand better for adverb of time. He arrived when it was already late. What can you observe? There is when there, which indicates what? The time to which who arrived. The person, which is the identity or the subject. This is the subject of the sentence. And you have he. Okay, I arrived when it was already late. I arrived when it was already late. Here is the subject of the sentence, and this is the verb. Okay, and this is what? The adverb of time that indicates at what time did he arrive. It was already late when he arrived. Now, if this is clear enough, let's proceed to the next one. We have adverb of place. There's also adverb of place. Now, what exactly is adverb of place? An adverb of place helps to show the location or where exactly the particular action occurred or happened. So it indicates where an action happened or occurred. That's an adverb of place. And there are certain examples of an adverb to help you indicate or notice this. Examples can be where, for instance. You can even have wherever. Okay. Aside from that too, you could possibly have here. Okay. You could even have there, indicating a location, and so on to this. So you can have an example in sentences that's e.g. where did he go to? Meaning you're trying to seek to know the exact location of where the person actually proceeded to. So where did he go to as a question. Now where is indicating an adverb of what? Of place. It's indicating an adverb of place. Now let's proceed to the third part, which you have as adverb of manner. Adverb of manner. Now what exactly is adverb of manner? An adverb of manner helps to tell or to show you how an action is performed. Do you understand? How an action is performed, basically. If an action is performed in a particular way, the adverb of manner will reveal. And there are other examples to show the adverb of manner. Now take a look at that. You can have as if, as though. Okay, you can even have even though, and so on. You can see that. So these are examples to show an adverb of manner in a sentence. Now look at that. He acts as if he was the captain. He acts as if he was the captain. And what can you notice? As if is used here to indicate what? An adverb of manner. An adverb of manner. And what does that mean? He's not the captain. He's simply acting as if he was the captain. Meaning it is so glaring that he wasn't the captain. He was simply acting as if he was the captain. So that's why you have he acts as if he was the captain. So Now, an adverb of manner there, which shows how an action is performed, is as if. Now, if this is clear enough, then let's proceed to the next part, which is number 4, where you have an adverb of frequency. An adverb of frequency. Now, what's an adverb of frequency? Now, this helps to show the rate of an occurrence of an action. How many times, at what rate does an action happen or occur? Now, there are certain adverbs that is going to give you a guideline to those adverbs of frequency. Take a look at this. You have, for example, you have always. Now, obviously, always will tell you that such action happens frequently, okay? Now, you can also have often, for instance. Aside from often, you can also have seldomly. Seldomly simply means it doesn't happen most times. Then you can also have occasionally, for instance. You can have occasionally. You can even have sometimes, and so on. There are many more to this. These are called adverb of frequency examples. Now, you can have, in example here, you have he visits. Okay, he visits always. He visits always. And what does that tell you? Now here, always here is what? An adverb of what? Of frequency. An adverb of frequency, which tells you at what rate does he visit? Meaning he visits always. Now let's look at the 5th part. The 5th part is an adverb of reason or an adverb of purpose. And what is the function or what's the meaning of this? An adverb of reason or purpose tend to indicate why an action is performed, the reason behind an action, or what led to an action. That's an adverb of reason or purpose. An adverb of reason or purpose. So practically, both of these means the same thing. And what are examples under this? You can have why, you can have because, you can even have so, you can have so that. Do you understand? And many more. There are many more examples to this. So we can pick any one of these to illustrate a sentence for better understanding. Okay, take a look. E.g., we could pick this where you have he ate the food, all right, because he was hungry. He ate the food because he was hungry. And that's a full stop to that. Now let's analyze this together. Now, he has performed an action. He ate the food. And the writer went further to tell you why such action of eating the food was performed. And what's the function? It said, because he was hungry. Meaning that he had to eat the food. He had to eat the food because he was hungry. Okay? That means if he was already satisfied, he wouldn't have eaten the food. Now, if that is clear enough, let's proceed to the 6th part. We have the adverb of condition. The adverb of condition. Now, from the word, the adverb of condition helps to show at what condition, what could possibly necessitate an action, or under what condition should an action occur. That's an adverb of condition. And there are different adverbs that can suggest to you how to identify adverb of condition. Take a look at this now. You have if, can necessitate that. You can have provided, okay? Provided that, can necessitate that too, okay? Any of this can necessitate that. You can even have until, you can even have unless. Let me give you more. Unless. So please, class, anytime you see any of these adverbs, they help to necessitate, to show you or to tell you that this is talking about adverb of condition. I'm going to give you a very funny example, and let's see. So I can use any of this, e.g., I can use any of this. Okay, I have provide. So this could be provided that. Let me make this provided that. So you have this as provide, you have this as provided that. You know how ladies behave? This is a very funny way, actually, but just to illustrate an example, ladies will say, I will agree to go out with him, provided he foots my bills. You can see that now. So there's a condition to that particular statement, meaning if you're not ready to foot the bill, she's not ready to go with you. All right. So now take a look at that. So I will agree to go with him. All right. There you have provided. That's the conditional form of it. Provided you foot my bill. Meaning that as the man, you have to be financially capable to do that. All right, so class, here we have about 6 adverb. Let me see. Let me give you one more to make it 7. Okay? And I'm going to illustrate this here. Hope you don't get confused. This is how we go. 1, 2, 3, 4, 5, 6. And I'm going to give you one just right here because of the space. Okay? So now let's take a look. Number 7 is called an adverb of concession. An adverb of concession. All right, so now let's take a look at this part, which will be the last part, an adverb of concession. And what's an adverb of concession? It helps to show the contradictory nature, the opposite idea, okay, of a statement or an information. So that's what this helps to show. A contradictory idea or information. Now, examples of adverb of concession could be though, could also be although, okay? You can even have even though, and so on, that's etc. So we can use any of these for an adverb of concession. Now, let me give you an example, okay? Now you have although he was invited for the party, he was invited for the party, although he was invited for the party, but he didn't attend. Now look at this now, class. Now, although he was invited for the party, okay, yet he didn't attend. I purposely illustrated this. I wanted you to see this. If you construct a sentence, don't always use although with but. All right? Always use although with yet. I illustrated this to make a correction to you. And you don't say although and but. You don't say so therefore. You don't say still yet. They are tautological statements and you're not supposed to use them. Okay? You don't say should in case. No, they are very wrong. You have to apply redundancy rule, which states that out of those two, just pick one. In case he returns. Don't say should in case he returns. No, in case he returns. Okay, so don't say so therefore. No, therefore is practically applicable. Okay, they'll also use although but. So here we would replace redundancy rule with yet in this case. So although he was invited for the party, yet he didn't attend. Most appropriate. Now, class, I'm going to give you a drill, and what I need you to do is for you to identify or tell me what type of adverb, okay, that could indicate. Is it an adverb of time, or an adverb of place, or an adverb of frequency, or an adverb of manner? I need you to identify that for me. All right, so now let's take the drill. All right, class, so let's look at a drill on adverbs. And the instruction here is to identify the type of adverb in each of the following sentences, okay? Now, look at the first sentence. You have, she acts as if she were the captain. And in that case, what can you identify? As if here is present, like I explained in the class. So now, she wasn't the captain. She's possibly acting as if she were the captain. So in that case, you have an adverb of manner here. So I should expect you to also indicate same in your notebook. Now, if that is clear, now let's proceed to the next part, which is number 2. Tolu slapped Tola because she insulted him. All right. Now, Tolu performed an action of slapping Tola, and there's a reason for that. Now, you have because, which gives you an adverb of reason. while Tolu had to slap Tola was actually because she insulted him. So in that case, you should have an adverb of reason or the purpose to which the action is performed. So we have reason or purpose. Now let's proceed to the next part. You have, I know where Michael kept the book. Okay, and this is somebody talking, saying he or she is aware where the book could be found. Okay, in that case, you have where is indicating what? An adverb of place. So let's look at this. So this is an adverb of place. Now proceed to the next one. I think I like her personality, though she misbehaves sometimes. So in that case, what do you have? Though here is showing what? A concession. All right. Concession, I told you earlier, was a word to which shows a contradictory idea or an opposing idea. And what is contradictory about this? Now, someone is affirming that he thinks that he likes her personality. Okay, that's the positive aspect of that sentence. And the negative aspect here is though she misbehaves. As a negative compliment, she misbehaves sometimes. So in that case, what you have is concession. That's an adverb of concession. Okay, now if that is clear, let's proceed to the fifth part, which is the last part. Said, although she's friendly, that's a good compliment. Although she's friendly, yet everyone dislikes her disposition. All right, obviously, if someone is friendly, everyone should at least like her disposition. But in this case, you have although, which is showing a form of contrast, and you also have yet, which is showing a form of concession too. So in that case, number 5 would be an adverb of concession. Now take a look at this. I believe this should be clear as at this point. What I needed to do is, if you have any particular question, all right, quickly post that on the platform. I'll read that and I will give a feedback on that. I hope you enjoyed today's lecture. Then I hope to see you in subsequent classes. Thank you so much.
Introducing your study path. Your study path is a curriculum-based online learning platform for desktop and mobile devices that gives you access to high-quality learning materials. Our platform hosts high-quality pre-recorded videos, live classes, question banks with detailed solutions, and social learning features to ensure that you excel in your academics. We currently have content for high school students in West Africa. You can now have the entire curriculum at your fingertips, pass exams like Jamb, WAEC, and NECO easily. Here's how to use our platform. Using an internet browser, log on to www.yourstudypath.com. Click on Sign Up to create an account, fill the forms, and activate your account. Congratulations! You're now a subscriber to Africa's largest learning ecosystem. Log in with your user details. Here is your dashboard. You can select a study path to get streamlined content for a particular examination goal. To access our video content, select any subject of your choice. You can easily watch videos on any topic. You can find details about your tutor and the topic being taught by accessing the overview menu. You can also access the question and answer menu to ask questions and get answers. Discussion menu offers interactivity with other users who are taking the same course. You can access the question bank by clicking on the question bank button. Select any subject of your choice. You can view the questions and detailed solutions that follows. Questions can be filtered by category, level, topic, question year, question type, and difficulty. Mock exams offer our users the ability to simulate an exam they're preparing for. To access mock exams, click on the mock examination button. Here, you'll get access to the upcoming mock examinations. Welcome to your study path.
Welcome to your mathematics study part. We have concluded the fact that plane shapes form a very important and essential basis for the construction or formation of solid shapes, right? Of course, we have said that some examples of these solid shapes have included the cubes, the cuboids, the prisms, the pyramids, and so forth. However, these plane shapes are not just put together in any given form. They have standard structures, they have standard combinations, and they have standard rules that guide their combinations into these various shapes. In fact, to calculate or to construct the various plane shapes themselves, we have to take note of the sides. We also have to take note of the angles with which they are combined, right? So it becomes very, very important for us to now look down at those angles and those sides and then learn exactly how to construct each and every single one of them. This brings us to the focus for this session. And for this session, we'll be looking at the concept of geometric construction. In this session, we will learn how to construct basic angles, the angle 30, the angle 60, the angle 90, the angle 180 as well. All basic angles that exist, we would learn how to construct them in this class. You would also now be able to extend these basic angle constructions into other angles like 135 and so forth and construct them as well. We will now take our learnings from these basic angles into the construction of various triangles and other quadrilateral polygons that can exist as well. Of course, you know, when we talk about quadrilateral polygons, we'll be talking about the squares, the rectangles, the parallelograms, and so on as well. So we'll extend the construction from the angles and the sides into the plane shapes themselves. Remember that once we have the plane shapes, we can easily also extend our concept to the solid shapes in total. Now, after we have learned about constructing different kinds of triangles, we will now also extend the concept into the construction of an equilateral triangle, right? For an equilateral triangle, we know that this means that all the angles are the same. They are not just the same, they are 60 degrees. And then all the sides are also equal, right? This is the unique consideration that equilateral triangles have. So we'll use our constructions of angles and of sides and of general triangles